Welcome, everybody, to part 2 of the 50-hour Cavalcade of Flat Earth Destruction. I've got coming up a debate with Vince Reacts, who you may see on YouTube a little bit, but I have to go to the bathroom before I can do that. And Vince is connecting right now. So, Vince, you're going to have to just wait a minute while I go to the bathroom. I've got a little song I'm gonna play while I hit the bathroom. So just a second here.
What is a full moon and what is a new moon on your model?
Probably like a magnetic cycle, and just like the center of a ferrocell cell image of a magnet.
Just like the center of a ferrocell spiral. Image of a magnet, it's just black in the middle. It's actually pure inertia, not just a little. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. Get it up! You start to see it charge up once more, and it goes back like it did before. Once it becomes like etherically spaced, you see it charge up and take its place. Oh, shucks, ain't that so? That's how moon phases work, fam. Pass the dresser. In the magnet's heart, centrifugal divergence flies. Centripetal convergence pulls. Defying all science, etheric whispers sing. Light and shadow blend, magnetic cycles spin, where physics seems to end. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. Yeehaw! Grab your partner, swing 'em round, magnetic cycles up and down. Either song in the air, hillbilly science everywhere, 'cause it's like etherically displaced. Yeehaw! Word salad buffet. Who has light vinaigrettes? It's behind the Jugger Ranch.
Then charges back up, and once it becomes like etherically displaced again, you start to see it charge up throughout a cycle, and it goes back.
And that was etherically displaced. And we've got in the house, Vince. How you doing, Vince? You gotta unmute yourself there. There you go.
Now.
There we go. We got you. Yeah.
Yeah. I'm not used to the Zoom. I always use StreamYard or Restream. So.
Okay.
Yeah. So 50 hours, eh?
50 hours, yep. I started at 6 o'clock yesterday, 6 p.m. I'm going until 8 o'clock p.m. on Sunday.
Is this the first time you have done such a long stream?
This will be the first, yeah. I will be sleeping.
When?
Well, after this, I got another hour, and then so about 4 o'clock my time, 5 o'clock my time, I'll go to bed. Okay. I have a playlist. I have a playlist of videos that I'm going to play while I sleep, so...
Okay, that's good. That's good. It's cool. 50 hours. But hey, listen, we need to spice it up. I watched a little bit. It's a little bit too geeky for me. You know, I am like the guy who flunked school. You know what I mean?
I do. Yep. I believe you. Yeah. I mean, I really, right here, I believe you.
Yeah, and also, you know, we are always so cordial, MCToon. I want you to yell at me. Can you yell at me?
I don't think so, Vince. You're too nice.
Why not?
I can't. I don't have it in me.
Come on, man. You have it in you.
I've got the power of utterly calmness.
Yeah, but you know one thing, like I don't know what we agree on, you know, on a lot of things in life, but one thing you
this is my
one
coffee.
thing that I
this was
coffee.
full. This was full at the beginning.
Hold on, do you also drink black coffee?
Yeah.
Yeah, me too. No milk, no nothing. Black, straight.
Yeah.
But you know one thing I see that you and me might have in common. You know what that is? Like when I've seen some of your streams sometimes when you think somebody fuck you over.
Is it our taste in music? I don't
know your taste. I know you like some metal, and I like some of the riffs. Yeah. I like old heavy metal. Like I don't like the new heavy metal because it's too wimpy for my taste. But so maybe that we agree on. But I've seen when you think somebody fucked you over, there is a switch that happens in you, and
yeah,
and that. I am the same way, you know, so I respect that. You know, when you think somebody's fucking you over, you turn on that switch, you know, so I think that's what we got in common. Probably the only thing outside of the metal thing.
We got GOV in the chat says, I'm a flat earther, but I don't know if I can handle a French flirf.
Oh, yeah. Oh, yeah.
Apparently you're French now.
Yeah, I'm a French gay painter from Sweden.
So,
you know?
So what's your actual background? And where do you actually live?
It's a mystery, MCToon. No, but I'm a Persian, Iranian, that is. But yeah. I like Persian sounds more elegant.
It does, yes.
Right? Persian Empire, that kind of a thing, you know.
Yeah, like you ride to work on a floating carpet. That's that's the idea it conjures.
Yeah. So I'm a Persian in Sweden, and I think I'm the only Trumper in Sweden, though. Yeah.
There must be more.
No, I don't think so. I really don't think so. I mean, there are some flat earthers I've seen on the app, but
on the app. Oh, you gave Dearth your
$3.
Your penance, yeah. Do you pay for the 11 a year?
No, I would though. To be honest, MCToon,
how do you know that there are other people in Sweden in the app? Then?
I mean, I can't say I know. I believe using Flat Earth Dave's own stuff. You know,
but,
I believe.
But if maybe I don't understand the app right. You need to pay for the friend finder in order to see people on the friend finder in your vicinity, right? Or I'm not understanding the usage correctly?
I think what it is you have to pay $11 a year, and then you have all the access to the Facebook, Flat Earth Facebook, or whatever you would call it. You know, it's like a Facebook.
It's a social media.
Yeah, social media. I think it's a brilliant thing. You know, listen, I hate cults. Okay, I don't belong to any cult. Okay, I am the jester, MCToon.
I disagree on that. Okay, what?
Yeah, I know. You say since I'm a flat earther, I belong to the flat earth cult.
There you go. Yeah, there you go.
I don't though. I don't invest that much time into flat earth. I just think it is flat, you know. But going back to the Facebook thing of Flat Earth Dave. It's a good thing, so flat earthers can connect, and then but flat earthers, it's not just that they have in common. They have a lot of other stuff in common, like. Oh
yeah, we've noticed. Like flat earthers believe every dumb conspiracy theory out there. Like, do you think?
Hand it out.
How about weather modification?
I absolutely believe that's real.
See. Do you think that hurricane could be caused? Yeah, of course you do. Have you any idea of the amount of energy necessary to cause a hurricane to do that?
No,
of course not.
But hold on, I've seen weird patterns of flights.
No, you haven't.
Okay. Yeah, I've seen. Yeah, I mean, if they are real,
it's called pareidolia.
Okay, what's that?
It's where you see things, because we are good at identifying patterns. That's how we function. Yes. So sometimes we see patterns where they're where there isn't an actual pattern, but we see it because we pick it out. So, you know, in some random distribution of data, we'll see pictures, right? You look at clouds, you say, oh, there's a bunny rabbit, there's a camel, there's a, you know, Starship Trooper.
I don't know how many times I've seen a camel cloud before, but go ahead,
yeah. So we see those things, but the cloud isn't a camel, and it is it shaped like a camel? Well, roughly, yes. Really well, no. Typically, if you actually had a camel that was shaped like that cloud, that would be a grossly misshapen camel. But it's in the neighborhood, so our pattern recognition sees it. So when you're like, oh, I see patterns in the light, that's your brain seeing patterns because that's what we do.
But MCToon, how did we end up here? I think what I said was I have seen, if I believe them to be real, flight patterns of a weird plane that went like almost like a little bit more of a half circle, then went back in and did a half circle and then left. And what people
around
are saying
the hurricane?
What people are saying is that was chemtrails triggering the thing before the hurricane. So
but there's no physics to explain that. Nothing at all.
No, but what I believe is this. They spray some chemical, whatever, something, and then they use HARP to trigger those chemicals, and that creates the whirlwind.
But it's just magic then.
I mean, it is magic.
But that's what you said. It's just magic does it. Because you said some vague words, some things that don't have any evidence behind it, don't have any application in science behind it, things that require in incredibly huge quantities of energy to be applied to it, but there isn't anything that could potentially store that quantity of energy, and yet then it happens. So magic.
You don't think that the HARP radio frequency sending things can do that?
No, not even remotely. No.
But how do you know, though? Maybe it can.
Because that's not how radio frequencies work.
Maybe they have another feature that they can do with the radio frequency thing, and then
maybe they have another feature that means magic. So magic happens.
Yeah, I mean,
it's just magic.
I think it's magic that you and me are speaking in high quality 4K stuff right here through the air. I think that's magic.
But it's not. I mean, people built it. It wasn't magic, and people understand it. And if you had, right, if you had worked through this type of a coursework, right? Then you would have a better understanding of, it's not magic at all. It's just an application of what's understood in already in electromagnetism and other topics as well.
So you don't think there is any magic? Like if you can understand something, it's not magical anymore. Is that what you're saying? Well,
I mean, it's maybe you've heard it. It's commonly said, a sufficiently advanced technology is magic to people that don't understand it.
Yeah,
but really bad paraphrasing.
Maybe you can have something that is magical, yet it's not magic because you can explain how it works, but it can still be very magical in its execution. Like, I still think it's weird that you can send pixels in the air, like a voice and all of this right now through the air. I still think it's magical, even though you can explain it scientifically with these chips and all that stuff.
But people made it. It wasn't that magic happened and then the chips appeared. Yeah. Right?
Yeah,
people sat down and said, "Hey, how could we do this?" Oh, here's how we did it. In the early 70s, here's how we can make a chip. And in the mid 70s, like, hey, we can make them faster and more complicated and do things better.
That.
And over time,
it's magical.
To you it is, but it's not actually, because people actually made it.
Yeah. So you don't think it's magical that through the air shit is flying and
no,
it's just flying through us?
No, it's just an application of physics.
Yeah, I think it's magical though. I do.
So Monkey Cat Pat wants to know, question for Vince, is there a conspiracy you don't believe in?
First of all, I want to say I don't believe that everything is a conspiracy. I think that's bad path to go, because I don't think everything is. And I think also the other side, the evil side, might actually throw in some of their own faked conspiracies, so to dilute the waters, so to say, like make everything look insane.
Okay. So back to the question: is there any conspiracy you don't believe in?
I don't know. I have to think about.
Okay, Bigfoot.
What are? I don't believe in it, but I'm not ruling it out. But I don't believe in it. No.
Okay, Loch Ness monster.
Same there.
Leaders are shape-shifting reptilians.
I'm 50-50 on that.
Oh my god.
Hold on, why?
50-50 on.
Yeah, because hold on. Yeah, MCToon, hold on. This is funny. You don't think it's magical to send these pixels through the air?
No.
If I say, but you do think it's magical for an entity to shift their form via frequencies or some shit like that?
That would absolutely require magic because it violates the laws of physics. Yep.
What if it's just magic until you know how it's done? Meaning they might have some super technology that can mask their appearance via frequencies that you don't see. Magic, reptilian magic, I call that.
Uh-huh.
Yeah, go. This is fun. Ask me everything you think. Yeah.
I mean, I thought that was the other side of the too far line for you, but apparently it's not.
No. I am wide, man. Worldwide.
How about there are secret mines on the moon that are populated by aliens.
Secret mines? Only mines, like turtles, brain.
No. A mine, like you dig underground to bring up valuable resources. Yeah.
No, I don't believe that, but because I don't think it's a physical object, the moon.
You don't believe it's a physical object?
Yeah.
Yet we can bounce radar off of it.
Maybe you can. Maybe you're bouncing that off of the firmament.
But why would the firmament only bounce when you're pointing at the moon instead of everywhere? The firmament would have to bounce everywhere.
That's a good question right there.
That demands an answer.
I can't give you one.
No. Got the white flag already. All right.
Yeah. Listen, I'm the jester, MCToon. I'm the jester.
Yep. You should get like a different hat, maybe.
Right? With those balls and shit.
Yeah. Hey, so Sarah Yoon says, are you aware that Trump wants to destroy Iran?
Yeah, I am.
Okay.
Well, hold on. Now, I don't know what's going on with everything. All I know is everything is looking bad under Kamala. That's all I'm saying. Under Biden and Kamala. And I think it's very weird.
Hold on. Well, just say.
Okay, go.
This is the place for people to go that do not want politics.
Got it.
Okay.
So this is a bad background.
So I don't. You're not scoring any points with that. I'll just say.
Let me just say this one point. I made an orchestral track just for Trump. That's the only thing I'm going to say. It's called Trump Triumph. It's a fantastic orchestral track I made just for Trump because I think he's a fantastic man.
Okay.
Anyway, that's all I need to say.
I mean, seriously, we're coming up to the election, and I'm absolutely sick of hearing it constantly. And of course, I write email filtering software. Yeah. And do you know what goes through email in massive quantity right now?
No.
Political emails. I'm like, tired of it. Please, I don't need any more.
But it's everywhere, right? And you can't get away from it. And I do think, though, this is the most important election that it's ever had. Anyway,
okay, Icy Spin says, how could the moon be non-physical yet cast shadows?
You're talking about those craters,
right? Yeah, you can see the shadows from craters on the moon.
Yeah,
how does that happen?
I don't know. You know what I think the moon might be? The moon might be, the opposite of the sun, the inversion of the sun. I think the sun is warm light, the moon is cold light. And I do kind of align a little bit to the theory that the moon is reflecting, the map of the earth and then some more,
That's so dumb.
I've seen videos where they actually, show the map of the earth and the other, there's a bigger part of the earth that we don't know about.
But it's not even close to the actual map. It's
Whatever
not even in the vicinity of the actual map. It's nowhere near. So
But, okay, maybe, but what if it is the actual map though?
it's not, because cartographers have mapped out the continents for centuries. So if those maps are wrong, then cartographers and surveyors have been hugely wrong.
Maybe.
On everything. Not maybe. Absolutely. And then if they are wrong, then it's very important that surveyors and cartographers do their jobs well, because if they screw up, then you have borders between countries and cities and property lines that are wrong. And people will get really upset if you're like, hey, even our neighbor's house over here, right? Or somebody's house, say, oh, your tree is going over your property. People have these types of arguments. Your tree is over my property. I don't like it, because they get pissy at their neighbor. And so they're like, well, different, depending on where you live, generally, if it's over your property, you can cut it. So people will go and be dickheads about it and like cut their neighbor's tree immediately above their property line. And so they get pissy about property line spacing.
I get that.
And they call out a surveyor to go and say, I need to know where that is so I can make that, I can cut that tree that's going over my property. They're looking at centimeter accuracy.
Okay, but what
and
if-
you're saying that the moon map is the map of the earth where you're hundreds or thousands of miles off.
Well, I don't know how, accurate it is. But
It's not accurate.
But going back to the borders thing, can we actually go to, aren't there just a specific part of the border where you can actually go, and then maybe everything else, around the border is like blocked off because it's government property or some bullshit like that? Like, can you actually go to every, corner of your country, you know what I mean? Like in the border, or is it just a specific part that you can access where they, when they're guarding it and shit, then you can pass through to the other country,
So what part do you think is not accessible?
I mean, all of it, all of the corners of
The corners
that's the
of the
corners
country.
of the continent. Yeah. Can you access all the corners, or is it just specific?
Most continents don't really have corners like that.
But you know what I mean? Like your country's borders or borders. Yeah, borders is what
The
I'm
borders
looking for.
between your country and the neighboring country?
Yeah, and all the border, like all of it through, 360, whatever you say.
Yeah. Yeah. That's
Can
not
you
a
access all?
You don't need to access it all, but you would. What do you mean
Yeah,
you would?
because to test if what you're saying is true with the mapping being off, stuff like that. Anyways, hey, I got a globe killer. I got a globe killer.
Oh, this will be
wanna hear
good.
it?
This will be good.
Yeah, I made it myself.
Okay.
And I want your opinion.
Do you want me to give you my opinion before or after you tell it to me?
Well,
I can give it to you before.
no.
All right, I'll wait till after. Okay.
It's better for you to hear it out. So we can't drill straight down to wherever, China, wherever it would be.
We can't?
I mean, can we?
I mean, with enough money potentially, but people aren't that motivated. Yeah.
So, some people say you can't because you will hit the fucking core thing, the core that spins. Spins inversely. the scientists, they're saying that the core is spinning the opposite of the Earth's spin. Have you seen that? That's what they're saying, at least.
Keep going. Yeah.
Okay, so some people are saying we can't drill through the planet because of that core. So we can never end up on the other opposite side of the ball, do you agree with that? Like,
because you'd eventually get to where it's liquid metal.
Exactly.
Yeah. Well, yeah, you'd run into problems with material science that it'd be difficult to have materials that would be able to sustain the deal with the heat. Yeah.
You just can't do it.
Yeah.
But what I'm going for here is this. I would want to know if it was possible to drill down right here, right? Let's say there wasn't a core and you could just drill through half of it right here. This is all, fantasy stuff, but
Yep.
This is a little bit entertaining. Come on, MCToon. Okay. So you drill half of it. Okay. At what point, if you were to drill, does the, what would you call it? Flip happen?
Flip.
The flip. Just like Joe Biden did on election day, the flip. But anyways,
I think that he would break a hip if he tried to flip.
Yeah, that's true. So at what point, when I'm drilling here, the tunnel I'm drilling, at what point here should I start flipping upside down and start drilling upwards instead? You know what I mean?
Yeah. When you get to the middle, the center of mass.
Here.
Yeah.
So if I drilled down, and now I'm at the center, and I haven't drilled anything now, and I've only drilled to the size of my own body, there would still happen a flip here, and somehow I would, I don't know, mash into the wall and turn into a ball like Sonic the Hedgehog, and then now I'm upwards now. So now I have to have a drill that can drill upwards, which is impossible. So...
Well, it's not impossible to drill upward, but continue.
Yeah, but in my size, think about it, MCToon. I am drilling, and it's only my size I'm drilling.
Well, let's make it a bigger hole then, okay?
Yeah, you would need a bigger hole, right? Because otherwise the flip would be weird.
Yeah. Maybe you had, too many McDonald's cheeseburgers.
Yeah, exactly. Okay, let's say there is a bigger hole.
Yeah, okay.
That fits, I don't know, 2-3 of me.
Yeah,
so
and a machine that can drill up. Yeah, okay. All right, so
I can take the drill.
Yeah, so where would you flip? Okay. So yeah, let me you want me to just give you the answer? Okay. Let's say you could somehow magically drill a tunnel from one side of the Earth to the other and put some sort of a wall on it, and then you'd go through. So as you got farther down, the downward acceleration due to gravity would start to reduce, and when you get to the middle, it would be neutralized, and so you'd be if you're right in the middle, you'd be in free fall.
I would be like,
and in fact, if there was some sort of a giant chamber inside, you'd be the entire portion of that inside chamber there. That was, if it was, totally centered, you'd be, there'd be no gravity because you're in the inside of a Dyson sphere at that point. So gravity in all directions neutralizes and cancels itself out. Right. But if you kept going through that tunnel, then as you got on the other side of the center, then the downward acceleration would be toward the center again. And so you'd be, as you continue to move back toward, it'd be toward Australia, or the ocean outside of Australia. If you went from the United States generally, you'd need to continuously increase your effort to keep going toward the surface, because then gravity would, the acceleration would increase again.
So when I come to the center, it's like a hovering kind of a place where I now can just choose which direction I want to, go to. So I do 180 and I take my drill with me and I now drill upwards.
Yeah.
All right. Okay. You're good, MCToon. Okay. So, but I have another solution though. Couldn't you just do this though? So to avoid the molten core, couldn't you just, if you were to, you see my hand, right? If you were to drill down just a tiny bit right there, and then do 90 degrees.
Sure.
There.
Sure.
That same thing wouldn't happen, right?
Well, yeah, because you wouldn't have gotten to the middle. Yeah, you'd now be. So when you're down a third of the way from the surface, right? Somehow, putting aside all the challenges with material science that we'd have here, but then you would then turn gravity. The pull of gravity would still be toward the center, and so when you made that 90-degree turn, it would be perpendicular to gravity. But as you, on your diagram there, as you got farther toward the surface, the downward vector would continuously change.
Yeah. It's things like this, that, I don't know. It's hard for me to, bye, MCToon.
I understand that it's hard for you. So how is this? Is this the Globe Killer, or is there something else coming up that's the Globe Killer?
I got a bunch of few things, that I got for you.
Okay.
I'm telling you, you're good though. This one.
All right. Well, hold on. I want to.
No.
Was that the Globe Killer, or was that just?
Potentially.
Okay.
Yeah, because you have to buy the idea that in the core you are floating and then choosing directions and shit.
Inside the Dyson sphere.
But let me add this, MCToon. This isn't even possible, by the way, because the core is there, so we can't even do. Yeah,
I mean we've set aside the challenges of material science. So if we're able to do that and get to the middle, well, if we have the ability to have unlimited budget and not have any challenges with material science, we would just siphon out the core and bring it up to the surface and build some big structures out of the core.
Hold on,
right?
siphon out that core. How hot is that core?
Not too hot for our unlimited budget and no challenge material science.
That's nice.
Totally easy. Yeah. I mean, the entire premise of this is fantasy stuff, so we're running with it, right?
Yeah. Absolutely. This is all in fun.
Okay. You moved on. What was the previous one?
Yeah. We'll go to that.
There we go.
We can take this one. We can take this one.
Got it.
Maybe I've said this before. I don't remember. But the Earth does tilt, right? Like this and tilts back.
No.
It's always constantly like this.
It's always tilted one direction. Okay. I mean, there's a many thousand year modification of the tilt, but generally, from year to year. So it's on the opposite sides of the sun. So this is a common misconception, not just amongst flat earthers. People think that the Earth tilts annually. It doesn't. It's tilted one direction on one side of the sun, if this is the sun, right? And then 6 months later, it's on the other side of the sun, still tilted the same direction. So on this one part of it is closer to the sun. This part, right?
Yeah.
And on here, this part is closer to the sun. So that's what causes the season. So, yeah.
Okay. Good, because that leads me into the other one.
Okay.
This is the one where it says, just like you said, at half of the year, we are this close to the sun.
Yeah.
And which is the winter part, funny enough. And that one is the summer part, which is looking way further away. Like, I want to say...
What percentage? What's the percentage further away?
Well, this is the thing. Looking at animations and pictures of it, the percentage difference seems almost... What would you say?
So
at least a third.
But do they claim to be to scale?
Probably not.
So that you,
But that's problematic.
You need
problematic, though.
No, it's not problematic at all.
Why do they do that? Because it is a,
because if they're attempting to show that there's a difference in the diameter of the orbit in different parts of the year, if they were to draw it to scale, you couldn't see it because the amount that it's off is so small.
Okay.
Right. So it would not be a very useful diagram. You just point on the diagram something like, we've drawn this to scale. So even though the Earth is farther away by this amount, you don't see it on this diagram because to scale, we can't demonstrate it because it's less than 1 pixel wide or whatever it is,
Yeah, but that's the problem, though, because that makes what they're showing inaccurate.
Of course it is. And since they typically label it as not to scale, right? Obviously, none of that diagram you have there is to scale because the scaled size of the sun to the scale size of the Earth, not right. The scale distance between the Earth and sun, not correct.
Yeah.
The scale ellipticity of the orbit, not to scale. None of it is to scale in that diagram. If you were to draw everything in that diagram to scale, the sun, if you made the sun 1 pixel, right? How could you make the Earth? The Earth has less than 1 pixel. There's no pixel. There's no pixel for the Earth. So you make the sun 10 pixels. Now, can you put the Earth on screen? Probably not.
You have to exaggerate so you can visibly show it. Okay. Do you believe in this? Is it possible for the Earth and everything else to stop spinning at some point, or is this spin forever? What do you believe?
Well, conservation of momentum says that that the motion is going to continue going. Earth's spin does vary because of conservation of momentum. There are things that affect it, but the amount that it's affected is very small. So within scale of humans' existence on the Earth, it's not going to stop. No.
Okay, but let's play with the idea. Let's say it stopped.
Just stopped?
Yeah.
Okay.
Yeah, it stopped, and then eventually completely still.
Okay. Well, we have some problems with the conservation of momentum.
Yeah, what would happen then if that happened? In your idea,
I think Randall Munroe covered this at some point in his What If series. So I remember at least seeing it somewhere in some treatment. Anyway, if the Earth stopped and nothing, right, magically, somehow the Earth was stopped, and the things on the Earth weren't also magically stopped, then you would have things like all of the water would slosh. It'd be quite dramatic.
Slosh? Yeah.
Well, if the Earth is moving and the tangential speed is 1,000 miles an hour, and then the Earth stops, but the momentum of the Earth was nullified somehow, but the water wasn't. Well, now the water is all going to want to go 1,000 miles an hour in the direction it was still going. That's a problem. So let's say we have the water also magically not have momentum, and we stop the Earth and the water at the same time. Yeah. Well, if nothing has momentum, not air, not people, still, not buildings.
Yeah, it's all still now.
Well, then, for the most part, we would not notice much. What would happen is the measurements of the downward acceleration would vary, because at the equator, the downward acceleration is slightly lower due to centrifugal acceleration. And at the poles, it's slightly higher because there is no centrifugal acceleration there. So that would change. What else would change? Well, certainly our view of the stars and sun would change if we were no longer rotating, right? We would not see the sun move daily. We would see, assuming that the Earth continues to orbit the sun, we would now see an annual sunrise and sunset. Okay, the orbit stops.
Everything is
okay.
Everything
Yeah,
stops.
well, then half of the Earth would be lit by the sun, and the other half would not in perpetuity. It would drastically change weather.
okay, would we fall?
Fall.
Yeah, like the Earth, would it just stay put in the universe, or would it?
Well, we're invoking
fall
magic,
down?
so gravity is toward the center of the Earth. So we haven't yet introduced the idea that gravity stops existing and that the Earth doesn't have mass. So yes, people would still be standing on the Earth and at least initially walk around and do things normally, but the weather probably would change pretty dramatically because there'd be no more day-night cycle. So half of the Earth would now be dark, and the people there probably wouldn't be able to migrate quickly enough to survive to the more reasonable areas. And similarly, the places that were in the sunlight would get hot pretty quickly. And so I think people would probably live near, eventually migrate or only survive near the Terminator line.
Yeah, I would choose the sunny part of the Earth, and I think dark people will go to the darkness. But okay, so basically we wouldn't fall or nothing. One thing with when they show animations of space time or whatever.
Space
have you
time?
noticed? Yeah.
Okay.
When they show the sun, the ball sun and the ball Earth or whatever, and they're trying to show space time. Have you noticed that they always use like a plane that has, that, what do you call it? That dents in, like the ball is on the plane and it bends in the plane.
Oh yeah, the warped space. Yeah. So why do they do that? Well, yeah, because it's a difficult thing to conceptualize because space is 4-dimensional, not 3-dimensional. We're used to 3-dimensional. That's how we experience life. So
we see.
In 4 dimensions, it's an abstraction that we don't have intuitively. But what they're doing is they're going one more direction. They're removing a dimension. They're moving it from 3 dimensions into 2 dimensions so that they can introduce the 4th dimension. So they're taking 3, dropping it to 2, and then adding in the 4th dimension as a 3rd dimension. So that's what they're doing. That's why they do that.
Adding in the 4th as a 3rd. That's
because they took the 3 dimensions and just chucked one and say, we're going to visualize 3-dimensional space as 2 dimensions. And then we're going to bring in the 4th dimension of time as the 3rd dimension. And now we're going to draw it on a 2-dimensional diagram. So
hold on, MCToon. Why would the 4th dimension turn into time? Why wouldn't it just add another axis, just like the 3rd did?
That's what it does.
To the 2nd.
That's what it does.
Yeah, but time doesn't feel like an axis.
Yeah, it's not intuitive.
Time is, I don't know what time is really, but like when I'm picturing fourth dimension, I'm picturing, there was a little kid, a little science kid on YouTube that you probably seen the video. He talks about the 1st dimension, the 2nd dimension, the 3rd dimension, and he's saying like if you were a 2D character in a 2D dimension, you would not. A circle for you would be like a line that is wide or some shit like that. Anyways. He said, and this is funny, I'm quoting a little 10-year-old kid here, but he said that the 4th dimension is something you can't even imagine, just like the 2D characters can't imagine a 3D world. We can't imagine a 4D. But you don't believe in stuff like that. You think just the 4th dimension is time and that's it. There is no 5th dimension, 6th dimension, 7th dimension.
I don't have anything about them that I have very strongly held positions on.
Yeah.
If you look at what people say about string theory, they say all sorts of
strings,
kind of different. They're like, oh, there's 11 dimensions and there's this and those are at this point mostly ideas, hypotheses, and some things about string theory have been kind of poked at a little bit, but I think for the most part, it's still a lot of hypothetical things. So, but no, I wouldn't stake any claim about anything beyond fourth dimension. And
you know me, I think everything is based off 2D. Everything is based off 2D.
But you are a three-dimensional being.
Yeah, but it's still based off 2 axes, left, right, up, down, in, out. It's all based on
that was 3 axes.
But what I mean is it's derived out of the 2 things. Left, right, up, down, in, out.
That's 3.
I know that's 3, but in that it's 2, right? The core of it. What do you mean no? In, out is 2.
That's 1. Right? That's 1.
No, in, out.
Yep, that's 1 dimension.
That's 2. Yeah, but I know it's 1 dimension, but it's 2 axes in it, right?
It's 1 axis.
Well, okay, you can say it's 1, but then the opposite is there too. Like in or out, right?
Nope, that's 1 dimension. Here, let me show you.
What?
I've got my slide rule here, right? We got in and out. This is 1 axis, 1 axis. Now, here's another axis, in, out. And I know. Here's another axis, in, out.
Exactly, but it has to go from point A to B, right? When you do this, it's going from point A to B, right?
I don't think you know what a dimension is.
You start here. You should bring up that thing you had there.
Slide rule.
The slide rule. You start from left or you start from right to left. It doesn't matter. You start from somewhere. Yeah. If you take it all out, all of it out, not completely out, to the start of it. Yeah. That's point A. Yeah, that's point A. And then when you push it in, you're going to point B.
Yeah, point A and B are on the same axis, though, right?
I know. But
B, whatever. Yeah, 1 axis. One axis.
But I'm pointing out that A and B are 2 things, though.
Yeah, both of them are on the same axis, though.
I know. But those are 2 things still. A and B are still 2 things.
Yep.
A and B, A and B. A and B. So I think in the core of everything, it's a 2D thing that gives the hallucination of 3D. Just like a hologram is a 2D thing, right? But it can create, it can give the illusion of 3D. It's all 2D. Yeah.
Okay. Now what?
That's it. I told you about the circle, right? Yeah, I told you the circle is a rectangle, right? Like a circle is made out of lines. Yeah, I think I told you that.
A circle is a rectangle. Hold on a second. Let me process that for a second. Circle is a rectangle. Circle is a No, I'm not getting it.
Okay. First of all, let me just say, a circle is, again, point A to point B. Like that, right?
I don't know. Are the sound effects meaningful?
Yeah, I'm trying to make a sound for each line that changes angle.
Okay.
From the center.
How many angles are there?
How many angles? 360?
Nope.
What?
Try again.
362?
No, infinite. The answer is infinite.
Infinite? What does that mean, infinite? Hold on.
You can always cut it in half again. How about that? If you're like, well, let's have an angle of 1 degree. Okay, can you cut that in half? You can. You have a half a degree. Can you cut that in half? You can.
Yeah.
It's a quarter.
Endlessly.
Yes. So infinite.
Yeah, that's like the golden ratio thing, which I do believe in. Golden ratio thing that goes infinitely in and infinitely out. And I think that's proof of the creator, by the way. But anyways, which is endless, lives outside of a beginning and an end, the creator. I'm not religious, by the way, but I do believe in a programmer creator that lives outside of time, lives in a stream of time.
So you say you're not religious and then you make a religious statement. You know
Why
how
is that
that
religious?
doesn't quite...
Why is that religious to believe in a creator?
Because it's a belief. I mean, I'm not saying you can't. I think I'm just saying, you should correctly understand what it is that you're doing. You are describing a faith. You said you use the word believe,
Yeah.
right? That's
Maybe I did.
and there's no like, you can't just go and test it, and you can't just go and shake the guy's hand.
But the golden
right? So,
ratio that is found in everything, pretty much.
but it's not found in everything.
It is, it creates a rectangle.
It also doesn't create a rectangle.
It does. Have you seen these videos when they do the calculations? 1 + 1 is equal to 2 takes the previous 1, adds it, becomes 3. 3 takes the previous 2, becomes 5. 5, 3, 8, and it creates, it starts with 1.
That's the Fibonacci sequence.
Yeah. Golden ratio,
yeah.
they call it too. Yeah. And it creates a rectangle, right?
No.
So
it doesn't.
What do we know?
It creates a spiral.
Yeah, the spiral is inside the rectangle.
No. I mean,
all of the videos show that.
If you decide at some point to just stop at a number, then yes, I guess you can put a box around it, but it's not perfectly distributed within that box. There are gaps around it, right? You're just putting a bounding box around a non-rectangular thing. You can put a bounding rectangle around any shape.
Yeah, because I believe the foundation of this reality is a rectangle. You know why?
But the golden ratio isn't a rectangle. I mean, you could since it's a ratio, of course you can make a rectangle out of it, but that's not.
Yeah,
that's, oh my
and
gosh.
a circle is a rectangle.
No, it's not.
It is.
It's not. What?
I'm gonna show you, MCToon. I'm gonna show you.
Show.
Okay, but before I show you that though, we do agree about. Hold on. We do agree about
Probably not.
what.
Probably
what
not.
creates a what creates a circle is a line from in the center here, right, and then goes up, and then does all the different angles, with the same line to create a perfect circle.
Yeah, the line equidistant from the center is a circle. Yeah.
So
Okay.
it's really made out of lines if you go to the core of it, like straight lines, each angle. Yeah.
Okay. Or are you talking about when you draw, let's say you draw a circle, but you only do it every 1 degree, and so you have 360 points around the circle? Is that what you're talking about? And then you draw a line from angle 0 to angle 1, and from angle 1 to angle 2. You see how I started at 0? I'm a programmer. And from angle 2 to angle 3, right? Is that what you're talking about?
Okay, I'll show you.
And then you have an equilateral. What?
I'm going to show you the video.
Okay, an equilateral shape.
Yeah.
With 360 sides, right? Okay, you're gonna show me a video.
360 sides. This one I will probably have to share it so you hear it. I share it so you hear it. Right there.
Right.
Do you
Yep, I see it.
get it? Huh?
I don't hear anything yet.
Let me see if you hear it. Hold on.
A circle. But where does pi r
You hear that?
Yes.
Okay.
come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle
That's
into...
the lines I'm talking about.
Yeah. Yeah, he didn't make those sounds that you did.
Huh?
Yeah, he didn't make those.
Yeah, no, I'm the artist here. I have to make the sounds.
Okay. All right.
Color it.
You can see that every time the shape becomes more like a rectangle.
But it never is a rectangle. It's always a parallelogram, right?
Well, you have to chop it into small enough pieces so it will turn into
Oh,
a
yeah. We got to
perfect-
get to calculus here. We got to do infinite pieces, infinitesimally
not infinite, but
small pieces. No, you have to.
Yeah.
In order to get there, you have to because look at that bottom one. The bottom one.
yeah.
If you didn't have the curved tops, which you do have,
yeah.
right? Just look at the left and right side. Those left and right sides are parallel.
Yeah.
The top and bottom, if you ignore the gaps and just somehow choose, the outermost, well, then that's parallel. But so you have a parallelogram. You don't have a rectangle.
Yeah, but hold on. I just have to say, this is not a flat Earth video. This is just a regular video call.
I know. Yeah. Yeah. All right.
Yeah. I just
Yeah.
want
This
to
is the
display
area
how
of a
everything-
circle formula. Okay.
Yeah,
Okay.
this has
Keep going.
Nothing. Yeah.
So, how small must we divide a circle before we can get a perfect rectangle?
Infinite.
Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make.
This almost reminds me of what you guys say about the curve, that we're so small, or like the Earth
proportionally.
is so
Yeah.
big.
It becomes a manifold.
Straight. Yeah, it becomes
You know
straight.
what a
the universe.
you know what a manifold is?
Folding a man.
No. All right, keep going.
No, tell me, what is a manifold?
A manifold is an area where the amount of curve exists, but it's so minute in comparison to the other dimensions that it appears to
straight.
not have curve. Yeah.
Yeah. And I think that's what flat earthers are like. What you call up here, we call it is. It is flat. You say up here, we say it is. You
Well,
know.
except we can measure it. But yeah, keep going on this.
Okay.
But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle,
That's the
as
radius.
you can see, is the same as the radius.
Yeah,
Yeah,
the height is the radius, and then
Yeah.
the base is the perimeter or circumference.
Yeah.
Yeah.
So height is equal to radius.
Yeah, 2 pi r is the
To find
base.
the base,
Take
we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r.
Yeah, now it's like hieroglyphs
Yeah, it's
for me.
just
But
pi
you
r.
want me to continue to
Wait,
play?
oh yeah, this isn't hieroglyphs. This is middle school math.
Okay.
When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r
Awesome.
squared can be used.
Yeah.
Yeah.
So that means the circle is really just propped up or disformed rectangle. Not disformed.
Not
but, you know.
not. You have to modify it. You have to warp it to be a rectangle. So it's not a rectangle.
Or
you
what
can-
if the circle is a morphed rectangle?
Either way around, they have a relationship where you can morph them from one to the other, but that doesn't mean that the circle is a rectangle. You have to modify it.
Well, okay. Let's look at that for a second. Let me stop sharing this so it doesn't take up the whole screen. I only see one of them trying to, like, for example, the rectangle is not really curvy. The rectangle is its own shape, its original shape. while the circle appears to be curvy, but it's just made out of lines, really. So it's just giving you an illusion of a circle. But if, in its core, it's made out of straight lines, which I then say there is nothing other than straight lines in this reality. Just it appears that it has curves and valleys and this and that, but in its core, it would be straight lines, like a 2D yin and yang thing. But yeah.
I don't think this is really your strength.
I know. That's why I'm here.
Yeah.
Listen, you know what my strength is, MCToon.
I think reality has yet to find your strength, Vince.
Oh, I can tell you one of my strengths.
Is it?
You know what
is it choosing awesome headwear?
No. This is not awesome at all.
Okay.
I would suck at that. But my strength, one of my strengths is I am not scared of either sounding dumb or looking dumb. You know what I mean?
Yeah,
I'm not scared.
Yeah. That is one of your strengths.
I know. Thank you for confirming. Yes. You know, a lot of people are, though. A lot of people are scared to sound or look dumb. You know, I am not. So I'm here to tell you guys you can do it too. You can do it.
Yeah, chat. You can also choose to look dumb or be dumb. Take it from Vince.
Yes. I take
Follow
the bullets
Vince's
for you.
lead.
I take the bullets for you like Trump did. I take it. I'll lead the way.
Oh my gosh.
You know what I mean?
No.
So, but that frees you. Anyways, go. Yeah.
It frees you. Did you know that I'm going to Antarctica, Vince?
When?
Speaking of freezing, December.
December with who?
I'm going with Will Duffy, who is paying for Austin Whitsitt and Jaron to go.
Oh, are they gonna come with you guys?
Yep.
Well, let me just say one thing though. I don't know that much about Austin Whitsitt. I've tried to watch a little bit of Austin Whitsitt.
Yeah, headache. Instant headache, right? I know.
No, it's not headache. It's boredom.
Okay.
I don't know if it's headache or not because I'm the complete opposite of you in that way because I'm not into numbers in that way. Numbers and shit. Yeah. So to me, when I hear Austin, he might be right, he might be wrong.
But
I have no idea.
he's not into numbers either. He can't do math any more than you can.
But he's come on. That's
he can't.
Here.
He's never done algebra. He can't handle algebra. Even
like
basic stuff.
At least it sounds like
he's never done it ever. He gets confused by it. He 2 years ago he asked ChatGPT to do some algebra, and it did a horrible job of it. And he's like, "Hey, look at that!" And he sent it on to Bryant Myers. Like, this algebra proves whatever he said it was trying to get to. And Bryant looked it over and he sent me a copy and we both looked at it like, holy cow, that's so wrong. Every step of it was wrong. There wasn't a thing that was.
Why don't you confront him with that?
We did. We did. Yeah.
So what happened?
Oh, he cried like a little baby. He lied about what I was saying he was doing. Made up stories, stuff like that.
Let me just add something quickly about when somebody lies or not. I think in today's social media world, we are quick to claim that somebody's lying. Maybe they are, but I don't think all the cases are somebody lying. They could just be plain wrong.
It could be. Here, let's listen to this.
Yeah. Okay.
And they'll say, "Oh, you just can't understand math." And I literally used to get accused of cheating in my algebra honors class, right? Because I wouldn't show my work and I'd be the first done it, and she thought I was cheating. And I'd have to go, she'd give me a new piece of paper, a new test, and I'd just breeze through it in front of her again, and to prove I wasn't cheating. And then she'd end up accusing me of cheating again, and numerous math classes this actually happened. But Doesn't
Okay,
matter.
pause
I'm
it for a
certainly not
second.
trying to brag.
Yeah, like when I was good at algebra and I would just like breeze through algebra and do it in like 2 steps.
You should call and talk to some of my teachers. I used to get in trouble because they said I was cheating on my algebra because I didn't have to work it out.
But I had like an aptitude for math. Like if I sat down with you guys when we were in high school and Algebra 2 honors, I would have smoked you, dude.
I'm certainly not trying to brag.
I used to finish long form algebra without showing the work.
But I literally have an aptitude for math, bro.
I have an aptitude for math.
I'm so tired of people saying I can't do math, dude. I scored like incredible on my math entry exams in the college preparatory classes and stuff like that, and full ride to private university and stuff.
Honestly, I just got a full ride to play football.
But I literally have an aptitude for math, bro.
And dude, it's well known that I have like an aptitude for math.
I'm certainly not trying to brag.
I got a scholarship to a private university.
Can you believe how humble he is? I mean, the humility is so amazing that he's that humble, you know?
There was something with the first thing he said. He said somebody accused him of cheating and he didn't want to show that, but he could show the teacher, I think, or whatever it was, that he could do it.
Yeah.
So what is your take on that? That he cheated before and he learned that, like he practiced that in his head so that he could show the teacher?
No.
Or what?
No. So, well, I've taught all my kids algebra. So I know, I'm very familiar with the things that they try to do as they're learning it, because kids typically want to skip doing the busy work of algebra and just get to the end. So they look at it like, oh, you get these contrived examples as your first entry into something, right? You're like, here, solve for x. 2x equals 1. Solve for x. They go, oh, x equals whatever, right? Half.
Yeah.
Without going through the steps, because they see that because it's a similar pattern. They just see the pattern. And so they're like, oh, I'm just going to write down the final answer. And then you get to the next step up and they're like, okay, I see that same pattern. 2x plus 3 equals y, things like that. And and they'll skip forward. But the point of doing it is doing it so that you know that if you have a variable multiplied by a number and then a number added onto it, well, what's the step-by-step process to do that? Well, you need to know the step-by-step process, because later you're going to have
going through it.
By going through it. And so I see
organically sticks. Huh?
Yeah, I see my kids do it always when they're introduced to a new concept. They just want to skip past it because they just want to finish the homework. I get that. I'm like, no, you need to write down every step. And I typically tell them, I do this when I'm doing algebra. I'm not good enough to skip those steps. And they will try to skip those steps. And I'm trying to just drill into them that, I'm okay at it and probably better than them, right? Obviously I'm teaching them, and that they should not be skipping it either. And so I think that's what was happening there. He would just write down the answer without doing the intermediate. And the point of doing algebra is doing the intermediate steps. That's the whole point.
That's like life. And one thing Mr. T said. He's like, some experiences you just can't buy. You have to go through them.
Wait. Mr. T said, I pity the fool that that try to put me in an airplane without, because I pity the fool. That's what Mr. T said. There you go.
Yeah, pity the fool. No, yeah, that was pretty good.
That's Mr. T. Yeah.
Yeah, I never heard you do voices, but good.
Yeah, I can. Yeah, Mr. T.
Yeah, but he said basically some experiences you have to actually go through, and that's the only way to get them. That's pretty much what you're saying with the algebra thing. You have to go through it. You can't just, buy it or cheat on it. You have to go through it, right?
Yeah,
that's what you're saying.
Yeah, and so he, the test isn't. and my kids get this, they've heard it a lot. The teacher isn't curious about knowing the answer. They're not like, oh, I wish somebody would give me the answer.
Yeah,
that's not what the teacher wants. The teacher wants the student to know how to get the answer. So it's the process that is what you're looking for, not the answer.
And you suspect he did not go through the process. He just memorized what he needed to.
Yeah, he maybe saw the pattern because it was the simplistic thing. And he's like, I used to do long form algebra. Like, what is long form algebra? Right? Was he doing quadratic equations without any intermediate steps? I don't think so. Was he, I don't think he was doing actual like complicated algebra just in his head.
And
I think he was doing intermediate
with
stuff.
This, like you not going through it.
Yeah. We've laughed incessantly at his ridiculous claims.
Okay, so going back, you're going to Antarctica with maybe Witsit and Jaron.
Well, they're getting free trips, and they've signed the agreement to the contract that they're going. So as of now, it looks like they're coming. Yeah, and they are paid for. I am not. I'm doing this stream as a fundraiser to go. Mm-hmm. So that's why I'm doing this 50-hour fundraiser. So
all right. So
as it is now, let's see. Hold on. As it is now, I have 16,000 of 40,000 raised. So
that's pretty good, man. That's fucking good. So when is it? In December? When did you
December? Say? Yep. Yeah, we'll be on the ground in Antarctica December 14th.
Are you guys gonna be on the same like, I don't know, boat?
It's so we fly from southern Chile down to Antarctica. So there's no boat, and we're not near the water. We're inland.
Okay.
But yeah, we'll be on the same 757 in that final hop.
You won't speak to each other, or will you?
I don't know. It depends if he wants to be civil.
Yeah, I mean, I think you guys can be civil.
I can.
Yeah, but you're like a mirror too, right? If they're civil to you, you're civil to them, right? And vice versa.
Yeah,
like
I mean,
if you're not an asshole.
If he's going to be coming up to me trying to throw down, it's not gonna be a. Yeah,
I saw something. Some guy, a flat earth or something, said satanic thing. Whatever. You were like,
Joe Hill. Yeah, Joe Hill.
So he couldn't say to you what he thought was satanic.
No. So I don't know if you saw the whole thing. In April, Joe Hill and I had a debate on a Saturday night in a church. The same Will Duffy, the guy that's paying for the trip to Antarctica. It was the church that he is a pastor at. He doesn't get paid to be a pastor. He's got money outside of that. So
hold on. That's not the pastor that was getting angry at the flat Earth pastor the other year.
No, that was Greg Locke and Dean Odell, different guys. Okay. So he I went to church. We did a Saturday night debate between myself and Joe Hill, and then on Sunday morning, Will said, "Hey, we just take over the sermon portion." I mean, it wasn't a sermon. I wasn't doing that, but I talked about it. Did a little bit of addressing of the Bible verses on basically showing that there's disagreement on it, so you can't draw conclusions because there's disagreement on what things mean. So if you're going to be like, this is what it has to mean, but there's a bunch of other people that say that's not what it has to mean. So who's right? Let's just go measure the shape of the earth. That's how we figured out. Anyway, so then I went through a bunch of things about the shape of the earth. So Joe was there that next morning as well. And then after that, Joe had a phone call with Dearth. You know Dearth.
Yeah, Flat Earth Dave.
Yeah.
I like him.
You should not. Anyway, so
I do.
So then Dearth said in a video, he said that Joe told him that it was literal devil worship. the presentation I gave on Sunday morning.
Yeah, exactly.
So
I saw that. Yeah.
I played that for Joe, and I'm like, what part was it? And he couldn't tell me. He's like, the whole thing. No, literal, which means not figurative, literal devil worship. So in order to be literal devil worship, there'd have to be a portion of it where devil worship happened, literally. And I'm like, well, when was that? He's like, the whole thing. Anyway, so I recently then published the whole presentation that I gave.
Yeah.
And people in the comments were saying, because I did it in 4 parts, people were like, where is the devil worship? I missed it.
Yeah.
Sarcastically. Because it's anybody watching without even watching the thing that I gave would know it wouldn't be in there. Why would that be something that you would have in there? So.
Yeah, and he couldn't tell you what part. Like, see, this is the thing. If I think something about somebody, I know what it is, or I know why I think that. I would be able to explain it to you. So if he had said that to Flat Earth Dave, that he thought that was satanic, you would be able to point it out, though.
Yeah.
You would be, like that specific moment where you said this, that was what I thought was satanic or this or that. But he couldn't do that. So you think maybe he was protecting Flat Earth Dave, or he just couldn't pinpoint what he thought was satanic?
I thought going into it, playing that whole thing and asking Joe about it, that Joe was going to say, no, I didn't say that. And Dearth is exaggerating, but he wouldn't do that. And then I'm like, is he, throwing himself under the train so that he can get bonus points with Dearth? But no, he then did say grudgingly, sort of, maybe, kind of, that he said those things about me to Dearth.
Okay, so
he was never very clear.
Why couldn't he say that at that point when you asked him?
He, I think, was embarrassed.
Yeah.
He was being confronted it was really confrontational. And I think he wasn't expecting it. I know he wasn't expecting it. He didn't think that was going to happen there. So, yeah, he was caught. So I looking back at it now, I think, he probably did say those things because he's doubled down on it since then. So.
Yeah, because I know you probably don't like Flat Earth Dave, but my interactions with him, I did a stream, I think 2 years ago with him. I don't see him as a liar. I know you might see him as a liar, but I don't know. To me, he comes across like
he's a super liar. It's one of his skills, right? He had pictures up that he labeled as Apollo 9, Apollo 11, and Apollo 12. And he said, they're the same picture, or the clouds on the earth didn't change between all of them. But all 3 pictures were from Apollo 11, and he labeled them Apollo 9, 11, 12.
Well, maybe he did that on mistake. Like
a mistake? How did he make that mistake?
I don't know. Overlooked it? I don't know.
Overlooked it.
Like he missed, I don't know. He does a lot of shit. He has a bunch of shit.
So I get it. So what you're saying is that somebody told him that and he blindly believed it like a gullible sheep?
I wouldn't put it that way, but...
Well, what would it be? I mean, if he many times said in presentations, this is on NASA's website, Apollo 9, 11, 12, point, right? He has it, it has it on his screen behind him there. Is he, Apollo 9, 11, 12. Yeah. Multiple times in presentations, he said that. And he said it's on NASA's website. Now, that's not on NASA's website. He could not have looked on NASA's website because it was never on NASA's website. So he blindly believed what somebody else told him when that somebody else told him that it was on NASA's website, or he blatantly lied about it. One or the other, it's not a good look.
Okay, but why don't you debate him?
Why won't he debate me? That's the question.
He doesn't.
He won't.
Hey, if I ever talk to him, I'm going to say, why don't you debate MCToon?
Tell him he's a pussy. Tell him he's scared of me.
Okay.
Tell him he knows he would get embarrassed and it would cost him money.
Oh shit!
Tell him
Shots
that.
fired. You know, I like a good fight. You know what I mean? Like UFC or boxing. So I mean, we should set this up: a fight between MCToon and Flat Earth Dave. 2 hours. You can go 2 hours. You're going 50 right now. You can go 2 hours, right? With Flat Earth Dave.
Of course, he'd run away though.
Hey, if I set it up, will you do it?
Yeah.
Okay, I will
luck.
ask him.
Yeah, I get asked all the time things like, you know, why don't you debate the big names? Why don't you debate Debate? Like, I've had a challenge out to Debate for 4 years. He won't debate me. No, he won't debate me.
See, I have a problem with things like that. I don't care which side it is. Like, if you don't dare to step up to the table or whatever you say and duke it out, then you're not coming across confident. You know what I mean?
Yeah.
That's one of the things. Oh, yeah, by the way, one of my viewers asked, why don't you debate, what is his name? Nathan Oakley.
I have an invitation to debate him too.
Oh, really? So you're going to...
Yeah.
Okay. Nathan.
I offered to
That's
do it
the
on...
guy that sounds like a douchebag, right? Like,
he's a douchebag.
Fucking idiot. Like, he comes across very...
Oh, yeah. Yeah, I 2 or 3 years ago, I said, let's debate on Modern Day Debate or some other third-party platform. He won't do it.
Yeah.
Res Rhetoric has an even longer standing debate with him, debate challenge, and he won't do it. So, and of course, Oakley leverages his platform, right? He has the ability to mute everybody that he talks to, right? And he absolutely taps into that. So the debate the challenge is, I'll do it.
You did that once, though.
Where I'm not in control and you're not in control. It's a third party in control, and that is what he won't do.
Yeah, the only time you did that though was against Ross, and which I then later on because I had Ross real offended.
Oh,
Ross.
What about?
No, muting him. But to be fair, you know, me and him did some content as well. So me and him had some argument at some point too, and he does yell a lot. So I do understand. You know, when I muted him that time.
So all right, we've got a couple things from the audience here. Let's look at this here. Monkey Cat Pat Pat says, Vince, what about Project Bluebeam? Another conspiracy theory.
The alien invasion.
No, Project Bluebeam is just somehow magic making people see things. Using magic.
Projecting like holographic 3D stuff into reality that looks real. Yeah, I believe in that.
Yeah, he's in Monkey Cat Pat Pat. Sarah Yoon. Sarah Yoon says, why is it that he believes and perfectly retains conspiracy theories but recalls absolutely nothing from when MCToon has corrected him previously?
Well, it's because that person is talking about when you... The only one I really remember when you corrected me was when I said the sun, you know, the rays came in that way, la 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 la, and you said, well, if you look at a light source from above, it becomes parallel. Remember that? You said something like, I said, why isn't the sun sending one big ass parallel ray to the earth? Why does it look like, you know, like a local light source? And you showed me.
I don't know. I played the video.
You showed. She showed the light source from above. It becomes straight. Blah blah blah. I was like, okay, you got me there. But to answer that question quickly, is because I want to see things. I'm not, you know, with I don't learn that much with numbers and drawings and shit like that. I need to see it in actual reality. So therefore, I'm still on the flat Earth. Anyways.
So you don't need to see flat Earth in reality. So that's why you accept flat Earth?
No, I do see flat Earth in reality. That's why I accept flat Earth.
But you don't see flat Earth in reality, though.
Oh, but I do.
But because you don't see far enough. You don't see far enough for flat Earth. There's nothing can be obstructed bottom up when you're at the ocean.
I mean, I do have
That's
examples.
that's
to
the
show
prediction
you,
for flat Earth. Zero bottom up obstruction. No matter how far away it is, there can't be any bottom up obstruction. That's flat Earth. So, all right.
I mean, isn't that okay? Hang on.
So, Icy Spin says, can you steel man TFE, the final experiment for Vince, and get his position after? Okay, so the final experiment, that's the going to Antarctica trip. Okay. So I'll explain what that is. That's flat earthers for years have said that the sun sets in Antarctica and there's never a 24-hour circling sun. That's the claim, right? Because if you're in Antarctica, say 80 degrees south latitude, and the Earth is shaped like this, right? A circle.
Yeah.
Then you're on the perimeter of the circle. And so you'd always have to be looking toward the center of the circle to see the sun going around like that, right? You couldn't ever see the sun while behind you while you're facing north. It couldn't be that way. It couldn't go over your head. Not possible. Actually, right? That's the claim of flat Earth, and says, so then flat earthers for many years have been saying that it never does that. The sun does not do that in Antarctica. So Will Duffy's like, well, let's just get some flat earthers and go. So that's the whole point. So he's going to pay for 2 flat earthers. There's another one going, somebody else paid. Dave McKeegan, do you know him?
Dave McKeegan, no.
He does videos. He's from England. He has a dog.
No.
That's the dog in his videos. Anyway,
no.
Glober does great videos. Fantastic stuff. Myself, Critical Think, and a couple others potentially are going as well. So
how many Globers compared to flatters? 4 to 6.
3 or 4 flatties and 5 or 6 normals.
Okay, that should have been equal though, because now 5 Globies can say, "Hey, we saw this." 3 flatties.
It could be. But when Flat Earth Dave was offered a free trip, he said no. When Nathan Oakley was offered a free trip, he said no. When Dean Odell was offered a free trip, he said no. When Mark Sargent was offered a free trip, he said no. When Eric Dubé was offered a free trip, he said no. So 5 flat earthers were offered free trips, and they said no. So it should be, you go talk to them.
Yeah. Okay. Fair. That's fair.
Yeah.
That's fair. So one more thing on that though. How big part of Antarctic will you guys be able to
look at? We're going to go to Union Glacier.
Okay.
Which is at about 80 degrees south latitude.
Okay.
And there's a camp there. We're going to just be in that vicinity there.
So, but will there be something the flat earthers will say, yeah, we were just on a small little part of it and we couldn't go where we needed to go, and therefore this is all pointless, like what came out of this?
Will they see the sun due south?
Yeah, or whatever.
That's the question. That's what is being answered.
Okay.
Not did we go here? Did we go there? Did we see penguins? Did we?
Hold on.
Whatever.
So I don't know how much time we got, but there was a angle of a thing I wanted to show you.
Well, yeah. Well, so let's finish this topic though first. Okay.
Okay.
So now, according to this map, a 24-hour circling sun is impossible in Antarctica. So what would you say if we go there and flat earthers are there too, and we all witness a 24-hour circling sun, right? What would you say in response to that? Would you say, all right, that's impossible, Earth's a globe?
So the flat earthers are saying it should not be a 24-hour sun.
Yeah, they're saying it's impossible. Yeah, so Jaron says he thinks the sun will set.
And in saying setting, it means leave your field of vision.
It crosses the horizon and you don't see the sun.
Yeah, but through the flat earthers' point of view, they say when the sun is setting, it's just left your field of vision.
Yeah, he's not. Jaron isn't playing word games, right?
Okay.
Well, in Sweden and in America, we look west, the sun sets, right? So playing word games doesn't change that the sun was in the sky, and then at some point later, it's no longer in the sky. It has crossed the horizon, and it is not there anymore. That's what means when we say the sun sets. So Jaren, not playing word games, says he thinks the sun will set when we're in Antarctica. So
yeah, but he could be wrong.
He could. So I have said, if the sun does do what Flat Earth predicts and does not do what the globe predicts, that I will upload a video to my channel saying that the Earth is flat, and I'll delete all my other videos. And if a flat earther is interested, I will give over the credentials to my channel to lawyers, so that, and now the flat earthers would have to pay for the lawyers, but I would give the credentials to my channel to the lawyers and pre-upload that video, leave it unlisted, and then the lawyers, without me being able to stop them, would be able to set that video live and delete all the other videos. I'm willing to do that. And I've committed to that if the sun does not do what the globe predicts. So I'm bold enough. I have enough confidence in that. So what about you?
Well, listen, they could still be wrong. First of all, I do believe what you're saying, but some person could have said, yeah, but you're so confident that it's gonna be a 24-hour sun, and that's why you're making this bet, you know, like,
yeah, absolutely,
yeah.
That's absolutely why I'm saying that. So, yeah. but that doesn't do anything for you. I'm asking you, what's your response to it, and what would you commit to as?
Yeah, see, I don't know that much about this specific thing in Antarctica, so I don't know what I can say. Like, I don't know if the flat earthers are right in what they claim against your claim, you know, like, I don't know if they are right in what they're claiming. I'm just going off of, I think they know more than me, but I don't know if they are accurate in their claim that they're doing with the Antarctic against your claim. I don't know if they are right in what they're claiming.
Okay, that doesn't answer my question.
Yeah, but I'm trying to answer that. I don't know what to answer, because you're looking for me to say, well, if we find a 24-hour sun, then you'll have to admit it's a globe. I'm not that easily, sold on that. Like, even if you are right, I'm still not completely sold. You know what I mean?
How do you determine whether or not a model is correct?
How do I determine if a model is correct?
Yeah.
I don't know. If I can test it, maybe.
Yeah. How do you test if a model is correct? What do you do? What
you try to do it in a miniature or something. Miniature.
Well, that's one way, but that's not a, that would be, you'd make a physical model of it. You'd say, yeah, and then see if you could do a 2-scale.
Yeah.
Okay, but what about if you have a mathematical model or an idea of it, and you want to see if that idea is correct?
Mathematical model.
You're like, a mathematical model is the Earth is flat, right? That's a
plane.
That's a mathematical model, right? Because it's geometry, right? Geometry is a part of math. So so we've got that. So how would you test to see if that's correct? What would you do?
Test if the mathematics make sense or some shit like that.
Yeah.
I don't know.
Well, the answer is you take that model and you'd make a prediction using that model.
Yeah.
Right? So you say, well, this model predicts this will happen. Right? You figure out what the model predicts, and then you go check to see if that is what happens. Right?
Yeah.
So flat earthers try to do that with the globe. Flat earthers often go, oh, well, according to the globe, we should be able to see this far. right? You've heard
Yeah.
that, right?
Yeah.
And then they go out to the ocean and they get a camera and they're like, oh look, we think we can see too far for what the model predicts.
Yeah.
Right? Now, my response to that is you didn't actually use the model correctly. You didn't make a prediction using the model. You made a prediction using not the model.
But they use the, curve calculator thing, to see that there should be this amount.
Incorrectly. Because the simplistic curve calculators do not include refraction, but in reality, refraction happens, right? If refraction didn't happen, the camera that I'm using to look at you through wouldn't work. Because that camera lens uses refraction in order to get you in focus. Right?
Probably does, yeah.
Not probably. If it wasn't for the refraction in the camera, you'd be a blur, right? It wouldn't work.
Yeah.
So,
but I'm gonna show you this.
All right. Well, hold on. We're almost done with this, and I had to walk you through how to actually do science.
Okay. What science though? Hold on. What science though? Because some science, you know what I think about some science. Some science is wackadilly.
I just said
wackadilly.
I'm just talking in general about how to do science.
Okay.
You use a model, you make a prediction, you test that prediction to see if it happens in reality. And if it doesn't happen in reality, then your model's wrong. And if it does, then your model might be right. It's not proven right. You can say it's confirmed if you want. That's fine. But all that you've done is you've said you've identified that the model could be correct. That's what that means, right?
Yeah, but okay. Continue. Yeah. Well, okay, I agree.
Okay. So the flat Earth model says that I was messing around with my papers because I was looking for a map that didn't have drawing on it. So here, I'll
that's the UN flag too. Yeah.
But for reference, this particular map is described as from the globe in the patent, right? So, all right.
Are you showing something?
Yep, just a second. Okay, so you see the map here, right? So
yeah.
So if you're here, we're going to be down right about there.
Okay.
Right down there. So now, so we'll take the sun, and I'll use the eraser head here as the sun. Right. Mm-hmm. So here's the sun doing circles around the Tropic of Capricorn in December. Right. So there it is. So here it is. This is noon for our observers here.
Okay.
Right. It's noon. Right. The sun is at the highest in the sky. And then let's move it six hours forward. Right. So here's where the sun will be 6 hours later. And so when we're there in Antarctica, when we look toward the sun 6 hours after noon, it should be, what direction is this? From here, what direction? Northwest.
Yeah.
Right? Because this way is west, right? This direction is west.
East.
This direction is north. So this is diagonally 6 hours after noon. It should be northwest. Now, 12 hours after noon, the sun's going to be out here, like over Australia. Okay?
Yeah.
And if you call up people in Australia and say, hey, what time is it? They'll say, it's about noon. Right?
Yeah.
And so if you're in Antarctica right here, which way should you look in order to see the sun?
I mean, you should be looking towards Australia.
Straight north. Yeah, this is the direction you should see.
Yeah.
If you're all right. So this is what the flat Earth model predicts. Okay. Mm-hmm. So if this is what happens, then what will I do? If 12 hours after noon, right? Noon is when the sun's here, right? If 12 hours later, if I look north and see the sun, what will I do? I already told you.
12 hours? You mean
it takes 24 hours. It takes 24 to go all the way around. So halfway around is 12 hours later. So if we look north and see the sun, what will I do? What did I tell you I would do with my channel?
You would say it's flat and delete all your videos.
There you go. Because it doesn't match my model. It doesn't match the globe. It matches this model. I'm like, I'll follow the evidence. If the evidence says that, I'm with it. Okay? Now, on the other hand, if we look south and see the sun, if the sun is there on flat Earth, and we look south and see the sun, what does that do? What does that do for flat Earth?
Yeah, that would be weird, because if you see the sun behind you, maybe there's a second sun. Can it be a second sun?
Well, why would we not see that one, number one? But number two, it's noon.
Okay.
We look at the sun. Yeah. It's 1 p.m. We look at the sun, and we film it between, right? We're bringing we're bringing multiple 360-degree cameras, so we can record it all the time. So we'll see it. And so a second sun, somehow the first sun and the second sun would have to swap. I don't know how that could happen. Would they both be in the sky at the same time?
Maybe it is doing its own course over other lands.
But how would the first sun and the second sun exchange places?
Maybe they are like their routes are, what do you say, matching each other.
But wouldn't we see one of the suns setting and one of the suns rising if there's two suns?
Yeah, you should see the other sun behind you.
You would have to see two suns at some point. You would have to see this sun set while magical other sun comes to appear somewhere over here somehow. Right now, the other thing is that this camera that you're looking at through is a P1000. I'm going to bring this camera with me there, and I'm going to bring the solar filter that I have. I have a solar filter for this camera, and when you use a solar filter, you can see sunspots. You know that?
Okay, spots on the sun.
Yep, and so other people.
What does that prove?
Other people, when the sun is here, and at different times of the day, other people are going to be taking photographs of the sun. So we know what the sunspots look like. So that when we are here, if we look this direction and see the sun out here somewhere, and we take a picture of it and we say, oh, look, here's the sunspots. And they take a picture and they say, oh, look, here's the sunspots. And if the sunspots match, sunspots are like fingerprints, right? They constantly change. They're never the same. So now the second sun, not only does the second sun have to exist, which is a weird thing, not only does the second sun have to somehow swap positions with the first sun without anybody noticing, which I don't know how that could be possible, but now the second sun has to have the identical sunspots as the first sun. How does that happen? Again, more magic to happen. So anyway, what would happen? Remember, what would happen if I saw the sun here? I wouldn't say, oh, I need to see sunspot. I need to do this. I wouldn't say, what if? I'd say, what? Earth is flat. That's what I'll say. Earth flat. I'll say that if I look due north 12 hours later, right? At local midnight.
And then after those 12 hours, would the sun need to go down, or what happens after those 12 hours in the flat Earth
in flat Earth, well, 6 hours later, sun here.
Yeah.
You'd have to look northeast to see the sun.
Okay.
Right? Because this is east-west. This line here is east-west.
Yeah.
Right? Okay. So the sun would have to be at this angle here, so northeast.
So you're going to come back around.
That. Yeah. So if for flat Earth, you'd see the sun doing in front of you, always looking north. You'd look north at noon, you'd look northwest. 6 hours later, you look due north at midnight. You'd look northeast 6 hours after that. That's what it would always be doing, looking north. But if it's ever south, Well, that doesn't work for this. That falsifies this idea because now it's down here. How did the sun actually get here somehow be seen down here? So Vince, I'm asking you, what would you do if this model was falsified? Would you be saying, wow, I will do the same thing that Toon does. I will boldly declare that completely doesn't work and I'm done with that model?
I wouldn't do that. I would say that is very weird, though, that happened, that the sun is behind you. I still don't know if that confirms a globe, but that is going against the flat Earth thing in that case.
Yeah. I mean, I'm bold enough. I'm brave enough. I would love it for other people to be brave enough. Anyway, we've got Pepsi Man. Pepsi Man in the comments says, "How will you? Do you know him?"
Yeah, I know him.
Okay, says, "How will you know if you're definitely in that exact location if you can't verify that? Then any science will be pointless." Well, not even remotely. But we will be starting here in Punta Arenas, and then we will be taking a 4 to 5 hour flight. Well, we can only be 4 to 5 hours from this location, and but it doesn't matter where we are.
Oh, why can't you continue like beyond the point that you're gonna stay?
What do you mean? Why can't we continue?
Yeah, go deeper into the Antarctic.
Go farther south?
Yeah, like that.
Well, we could, but that's not the trip we're taking. Because that's not the point.
Are you allowed to?
If you wanted. The ALE does all sorts of trips like this. ALE is the organization that we're working with. Okay. Antarctic Logistics and Expeditions. So they have other trips where you could go to the South Pole Station. You can do, I think they have a cross-country ski trip across Antarctica. That's not what we're doing. Who's ready for a cross-country ski trip across Antarctica? Not me. I don't have the time nor the money. Yeah, so
it is a tough sell. Yeah.
Okay, so how do you know it doesn't matter, Pepsi Man, if you are on ice and you see the sun due south? It's impossible on flat Earth. I've heard people say, what if they bring you to Greenland? Well, number one, Greenland is too far away. Number two, Greenland is dark. In December, at the northernmost area of Greenland, the sun is not up at all. So, I mean, it's ridiculous. And how can we know where we are? Well, we've got GPS. We were in an airplane flying south from the southern tip of South America. We flew over water, then we flew over ice, then we landed. How do we know where we are? Well, none of those things are possible if you take off from here, other than to wind up down here.
What if there is a point where the GPS will lie to you?
I need more than magic.
I throw shit out.
Yeah.
You know what I mean?
Well, like I said, it doesn't matter, because if you're here and you fly south, you're over water and then you're over ice. Where else might you be? No answer.
I mean, I think a flat earther would say you're just at the tip of or like a corner of at the edge of the whatever, Antarctic or something.
Yeah, but it doesn't matter. Where else could we be? Where we're on ice and we see the sun circle around us for 24 hours a day. Where else could we be? Do we need to establish? It doesn't matter. The fact that we're standing there on ice and looking due south and seeing the sun, it doesn't matter where you are. It's not possible on flat Earth.
But you know why I think they're probably lying to us about the globe? You know why I think they're lying?
I'm sure it's some nonsense thing, but tell us the nonsense. We want to hear it.
I think ultimately it's because they want to sell us on the climate. You know what? I don't want to say the whole world, the whole world, but the climate thing. And that is how they're going to enslave humanity and restrict their movements in the name of saving the planet, for the greater good, saving the ball. So I think they need you to think it's a limited resourced ball, so that people will agree to their own electronic enslavement.
Yeah, that's crazy. Anyway, so it doesn't matter where you are, Pepsi Man. I don't, the kind of incredulity you're having there about I need to prove somehow that I'm in Punta Arenas. I don't need. Nobody actually thinks that type of an argument is a reasonable argument. So you go ahead and require that, Pepsi Man. It's not a good look. It certainly is.
You hear that, Pepsi Man?
Yeah, that's
not a good look.
It's not a good look because the fact is Punta Arenas exists. The fact is I will be flying from the United States down to Santiago and then taking another trip down to Punta Arenas. The fact is I'll be there for 2 or 3 nights. I will, while I'm there, probably take some nighttime star trail photographs with the P1000 that I have.
So will you guys be live streaming or recording only?
So we are working to have the ability to live stream when we're there.
Starlink.
Yes.
Elon stuff.
Yep.
Okay. Cool. That's gonna be cool to watch.
Yep.
You don't know how long the live stream will go on, not hours, right? Some half an hour.
We've been talking a little bit about what to do and how to do it, and I'm hoping that after this weekend I have enough or all of the money committed to go so that I can just say yep, I'm going, and then pay for it and then be settled. I really hope that'll happen.
You hear that, audience? You need to chime in. You need to chime in, man. Chime in, because listen, you guys are following MCToon. You should actually, join in on this so that you get some, potential Hadouken against the flat earthers. You got to chime in, man. Don't let this fail.
Hadouken? Are you?
Yeah.
Are you doing Mortal Kombat sounds?
No, that's Street Fighter.
No, Street Fighter.
Hadouken. Hadouken.
Pepsi Man. Is Pepsi Man insane?
No. He's not
so
insane.
It says,
what does it say?
For all you know, you can be in the other side of the world, and they put a little sign, and you are in Punta Arenas. Maybe Pepsi Man is not smart enough to figure this out, but I am smart enough to figure out if I'm in Punta Arenas versus a little sign and I'm on the other side of the world. I'm booking my own flight there. So I don't know how they're going to trick me that when I fly from Minneapolis to, I think I'm going to probably go through Atlanta, and then Atlanta to Santiago.
There will be a sign.
How could I not know that I'm in Santiago? There will be a few clues other than a little sign that I'm in Santiago. For example, the presence of a bunch of people speaking Spanish. The presence of the other people on the plane that are like, I'm going to Santiago. I think Pepsi Man is insane. Anyway, so then I'm in Santiago, and then in the airport they're like, "Hey, go to this terminal to take the flight to Punta Arenas." But there's a little sign that says, "Oh, let's fool everybody into going to Punta Arenas," but they're actually going from Santiago in a 2, 3, 4, 5 hour flight from Santiago to the other side of the world. I don't know. Say they bring us to Australia instead of Punta Arenas, and all of the Australians, instead of saying, "G'day, mate, would you like a Foster's?" say,
Hola, naranjas, eh?
Oh, hola, vato. Would you like a tequila? So, and somehow all of the Australians are saying that. And then we get in a plane and fly 5 hours south, and we're still in Antarctica. You didn't solve any problems, Pepsi Man.
Maybe it was like Truman Show, They separated apart that it's just a bunch of actors for people that, anyways. Do you think Uranus is to fuck with us? The name Uranus. Come on, man. You gotta give me that one. Uranus.
I definitely get my own chuckles out of the name there. And I especially appreciate it because when you look at the way that the name came about, all of the other planets are named after what?
I don't know.
What's Jupiter? What's Jupiter?
It's is it a god?
It is, but what nationality of guy?
Greek or something?
No, the Greek god is Zeus. It's Jupiter, which is a Roman god.
Okay, Roman god.
Right? Mercury, Roman god. Venus, Roman god.
Mercury, I love Freddie
Saturn,
Mercury.
Roman god.
Saturn
Neptune,
is Satan. Yeah.
Neptune, Roman god. Uranus, Greek god.
So maybe.
So hold on a second.
Yeah.
And that's what's funny. The Roman one is Caelus. For Uranus.
Asshole. No.
but they chose Uranus over Caelus.
So there was a name Uranus, like Uranus.
Yeah. I think Uranus is probably the more accurate way to say it, but come on. It's spelled Uranus.
And that language, that's older than English, right?
That's Latin.
Yeah.
Greek, actually, sorry.
Yeah. So maybe the English language adjusted itself so that it can say Uranus.
That's probably, I'm sure it was all about the English language changing itself for that purpose.
Yeah, they're like, anus means this, and Uranus, so that they can just, anyways, that was a bad comparison. But
Pepsi Man, seriously, he is not. Wow. He says the point of the story is believe everything at face value because people is always telling you the truth. Verify, and re-verify. Never take anything at face value ever. How could you not know that you're in Punta Uranus? There are so many things that would have to be. What color is the sky in your world, Pepsi Man? Anyway,
it does change though sometimes. Yeah.
Man in Australia has a question but can't super chat. All right, Man in Australia says sorry to yell, but I can't super chat for some reason. It's okay. Can someone ask MCToon what accommodation he will be in and what equipment he will be bringing?
He wants
so you can go to ALE's website and you can look if you want to really see like their accommodations. It's all on there. So it's the Union Glacier thing. So there are tents that we will be sleeping in. These are double wall tents that are transparent to UV light. So UV light gets in and warms up the tent. The tents are on wood so that they're not right on the ice. And they say kind of comfortable temperature inside, and you can stand up inside them. So I think near the floor it's freezing, but where you're at, like on a cot, it's warm enough. And then we have a part of the rental is a sleeping bag that's very warm. So, that's where we'll be sleeping. There is a dinner tent, and then we will be somewhere in the vicinity recording to get the where the sun is. Apparently there is a chance where they will take the 757 and will do us like a sightseeing tour around the vicinity there to see the mountains and stuff. They have fat tire bikes where we can like bike up the mountain. So that's the type of stuff that we have there. So
you know what I can imagine Flat Earth is saying, like I'm just saying another angle. Like let's say Jaren and Witsit comes out of there and saying, yeah, it does look like it's a globe or something. Let's imagine that they would say that.
Yeah.
You know what flat earthers would think? That something happened, that they have to say this. They got threatened, they got bought off, you know?
Oh,
to
yeah,
say that it's a globe.
People have already been saying that.
Uh-huh.
Yeah.
Okay.
Yeah, because that's the rational thing to say. It's not.
But it's not impossible, though.
Yes, it is.
I mean, if there is a global elite that wants to hide this.
So it doesn't matter what they say, because you know what we're going to have?
Evidence.
Video, evidence, live stream, 24-hour video. People standing there saying, hey, look, it's midnight.
Okay.
There's the
fair.
sun.
Fair.
Right?
I'm going to watch that. Yeah.
All right. Let's see. We got some other questions for you. We've got Icy Spins can you steal man FTFE? I already got that. Sarah Yoon says, can you steel man this is for you. Can you steel man a magnetic cycle like the center of a ferrocell spiral that goes into its inertial state and charges back up to be etherically displaced?
I have no clue what you just said there.
That sounded like a lot of word salad, didn't it?
I mean, yeah.
It did, yeah. Whoever first said that was definitely spewing some word salad.
Was it with it?
So it was. Can you say, Vince, can you say to Sarah in Korean, can you say thank you?
In Korean?
Yes. No. Say kam.
Kam.
Sa. Kam. Sa.
Kamsa.
Ham.
Ham.
Nida.
Kamsahamnida.
There you go.
Kamsahamnida. Hey.
There it is. Sergio Garcia Lavado is a new member at Newton. Thank you very much, Sergio. And then Sergio says for €2, Antarctica, here we come. Thank you, Sergio. Flamin' Mo 78. Love the Flaming Mo. The Flaming Mo, fire made it good. Says, has anyone noticed that Vince kind of looks like Deja Vu from 1984 Top Secret? I want to hear him say, haven't we met before, monsieur?
Haven't we met before, monsieur? No?
I'm buying it. I'm good. I'm in. PJ gifted 5 memberships.
Right.
Sarah said that I have good pronunciation. I try.
Yeah.
I know how to say a few words in Korean, and I don't think that my pronunciation is very good because I was taught by an American. I was taught by an American. That's taught by an American. That's taught by a Korean speaker. But and the kinds of words that I can say in Korean aren't very useful in regular everyday conversation.
Fuck it.
Like if I said haranmaki, right? That doesn't mean much to people. I couldn't find out where the bathroom is by saying haranmaki.
What does haranmaki mean?
It means low block.
Low block. What does that mean?
It's a block. If somebody's gonna attack you low, you need to block low.
Ah, block low. Okay.
Yeah. Or sangdanmaki, right?
Block high.
Block high. There you go.
What is this? Kung Fu Master.
Aneso pakromaki.
Okay.
Right? Or pakro honoromaki.
Are you one of those Kyotoshin karate guys, or do you practice karate?
Yeah, well,
Kung Fu.
Karate is a Japanese word. Kung Fu is Chinese.
Are you one of those 80s masters? Remember in the 80s, there was a lot of karate masters.
Definitely 80s. Yes.
Like Karate Kid. Like that guy.
Yeah. So what else? Like, I can say Gichu Hyung Ilbu.
Gichu.
which isn't very useful. It's basic form number 1. That doesn't really help you if you're walking around Korea and you're like, I wonder what's a good place to eat. Gichu Hyung Ilbu? Nope. Nobody's going to tell you where's a good place to eat, if you can say that.
But yet, that's the thing you remembered. Kichu.
Well, yeah, because when studying martial arts, you learn about how to say basic form number
Those
1
things,
because they're like they want you to do basic form number 1, so they'll tell you, all right, everybody,
and you
Gichu
repeat
Hyung
it.
Ilbu. Yeah, there it is.
Yeah, that makes sense. Makes sense.
I'm so white. Anyway, that's 2 hours.
Oh shit! Already.
Are you? You've got 2 microphones.
Yeah. Listen. The problem is, I think it echoed. So, yeah, you know why I got 2 microphones? This one, for some reason, it's slow when I use it on Zoom or whatever the fuck. This one is low. So I have to use this motherfucker instead. You know?
Okay. So one is for me and one is for your live stream.
No, I'm not live streaming. No. I'm just using OBS. I'm not live streaming.
So which microphone are you talking through right now?
This one is not even on. I mean, this one is not working right now for anything.
So it's in front of you just for looks.
I mean, I can take it away.
There.
It doesn't matter. But I need, I need a fucking screen above there, you know what I mean? So.
All right. That's all good.
Looks. Yeah, I want to look cool with a microphone. That's how you look cool.
I intentionally have mine off screen. So that
you don't want to look cool.
Well, I never liked having microphone in front of me, so
I do because I'm a French gay painter. You know what I mean? It looks good on me. You know what I mean? Especially this mic, this type of mic right here.
Maybe next time you can have 3 mics.
Well, I have another mic too.
Yeah,
I can.
3 or 4. I hold on. Hold on. I think I got one, so I can also have.
All right.
Hold on.
You joining the club? You joining the French gay club?
Well,
is that what you're doing?
Yeah. All right. So I've got my second microphone going here. How do I look?
All right.
Is this good?
Not too good. It looks better without.
It's not the best. It's not the best looking microphone, but you know what I can do? I can get rid of this.
Like a recorder.
I can put. Well, it is. That's what it is.
Is it one of those Zoom? What is it called? Fuck is it called? Microphone recorders thing. Like you can portable. Yeah. It's portable.
It's a recorder
with batteries and
buffering.
Shit. Are we buffering? Did we say something we didn't?
I don't know.
Allowed to be saying on YouTube. We didn't say anything.
All right. Hold on. There it is. Okay. So now this. How's this look? Is this better? This is the wind muffler thing.
Starting to look a little bit fruity.
Would it be better if it was like a rainbow wig looking thing?
Put a rainbow there, and it fits the fruity name. Yeah.
Okay.
You become really fruity then.
All right. Okay. Well, cool.
Yeah. Very cool.
Astrocate, who is an actual NASA employee, says Astrocat, which is the name of her cat, says Astrocat loves gazing at the rings of Uranus.
Ooh, I bet you do. I bet you do. I like that too. Uranus is my favorite planet. Uranus is my favorite planet. It's circular. It's nice.
There you go.
Uranus is nice.
Thank you. There you go.
That's so gay.
Yep. All right.
That's the gayest thing ever. Especially said to a man.
Other than what you described yourself as.
The gay painter.
French. You didn't say French.
Oh yeah, the French gay painter.
There you go.
Painter. I remember I baked bread and shit in the form of a phallus.
A phallus-shaped
bread. That's the only one we sell. Takes some time to work on it, but once it's done and you put it in your mouth, it's good.
All right. Oh my gosh, that's enough. All right.
All right.
Thanks, Vince.
Thank you yourself.
It's been real.
It's been. That's the only thing I can ever promise. Real. Nothing else.
All right.
That's it. And good luck with your trip. And by the way, I'm gonna try to get Flat Earth Dave to do a debate with you. Hopefully, I can host that. That would be funny as hell.
Absolutely. You can host it. That'd be great.
Yeah, that would be fantastic. I'll check and see. But that will be when was you planning to go to Antarctica? December
14 to 18 is when we are on the ground
14.
in Antarctica.
Yeah, that's like in 2 months.
Yep.
Okay. So maybe if we can do it before that will be, or after, before or after.
Well, after that, the flat Earth will be done. So Dave will be toast. So he'll be looking for a different group of people to shill.
It will still be exciting to see, though. You know.
Yeah. Yep.
Yeah. So that's I'll see. I'll try to do that. Let's see.
Oh no! Hold on a second. Paul Curtis's comment is hilarious. He says it looks like you shoved a mic up a tribble's rear end, right there. This.
Who, me?
A tribble. No, a tribble. You know what tribbles are?
No.
From Star Trek.
I don't watch Star Trek.
There we go. Okay.
I used to watch Transformers.
All right. Well, Decepticons roll out.
Oh, yeah. All right. Peace out.
Thanks. We'll see you.
Peace. Peace, MCToon.
All right. Well, he's always interesting. I got a little more before I was hoping at 5 a.m. I'm going to go to sleep. I will continue this live stream though and play a debunking series of videos while I sleep. So we got Gary Donnelly for £5 said, good morning, MCToon. Good luck with doing the 50 hours. This is helping me get through my day creating macros. You're creating macros on a Saturday? Wow. All right. So here's what this is. This is what we're doing now. This is choose your own adventure time. And if people aren't up for it, that's fine. So we've got, I'm going to go over here to Discord. And that's not the right one. Let me get the correct one here. All right. So here is the Discord channel, Choose Your Own Adventure. If people are interested, we can jump in the live chat. I don't know if there's people kicking around right now or not, but if you're interested, let's see. Where's my live chat? There it is. I will jump in my live chat right here. It's like there's a waiting room and there's a debate voice chat. So if people want, I'll be in the waiting room. There we go. We don't need to have rules on it. So anyway, there's my my channel, my Discord server, and I will grab, if you want to join, you can join right there. There's a link. So yeah, Vince is funny. I he's out there. He's a little goofy. He's like, maybe we can have some jabs at each other. I'm like, okay, but I mean, I didn't have any desire to do that. So, Sarah, it's okay. About timing them out. I generally, unless people, I say go there, right? If they say the types of things that YouTube doesn't want people saying, that's really the only time that people need to to do much moderation. And yeah, when people tell an off-color joke, well, they tell an off-color joke. I laugh at off-color jokes. So, okay. A couple more thoughts about the moon from XX Argor XX. Says, this is the Flurfy video I was talking about in my super chat. Let me know if you wish for me to share it to your DM. I know I'm getting close to the end. All right. Man of Stone. Oh, Man of Stone is dumb. He thinks he's all that too. Let's see here. Let's get this video by Man of Stone up. And I'll play it here. What is this? All right, so this music. It looks like the Globies weren't all impressed with my first couple of thoughts, but Moon, they didn't think there was proper analysis. Yeah, definitely. They simply aren't convinced that the content of my video serves to invalidate anything at all about Newton's assertion that mass attracts mass. What is this about? I saw it. Obviously, there's some other videos that was referenced, but I have no idea what they are. And this was just posted. All right. Globies still seem to be quite convinced that they were taught demonstrable truth in school when it comes to gravity. Of course, it's been confirmed empirically.
At the exact moment that the moon is on the inside, or it's closer to the sun, right there, this is at the moment where the moon in reality is said to begin going back towards the earth in the other direction, okay?
Yeah. Mm-hmm.
At this moment, why would the moon ever go back away from the sun?
Oh my gosh.
It's going towards, when it's on the other side, it goes towards the sun, which makes perfect sense. But at this point, it begins going the other way, even though the sun's gravitational force is twice as strong as the Earth. So how is the Earth able to overpower the sun and pull it back?
The Earth doesn't fall into the sun because it's orbiting the sun.
Ooh, I recognize that voice.
Velocity that maintains its orbit, and this is the only reason why it's not falling into the sun. If the Earth were to stop, if it were to lose its velocity, then it would fall into the sun. The moon also orbits the sun. The moon orbits the sun with the same velocity relative to the sun as the Earth, as you can clearly see every day when you look at the sky. The moon follows the Earth, so it's orbiting the sun, and it's staying in the same orbit, and its movement around the Earth is just local movement around the Earth due to its local gravity. But if it were lagging behind, if it were not maintaining the same velocity in the sun orbit, it would definitely fall into the sun. So the answer for the moon, for your question, is the same answer as why doesn't the Earth fall into the sun?
That's
because they have an orbital velocity.
It's funny how flatties think that they figured something out that the rest of society, rest of the people that do deal with these things regularly are like, no, yeah, we totally got that figured out. That's not an issue. Like, oh, we totally found an issue. Like, have a little self-awareness. Like, you don't. Hold on. Oh, somebody's coming into the Discord server. That's why I was hearing some noises. Okay.
Sorry.
Anyway, yeah. Who? Let's see. I have to look here. Who's joining? We got. What do I call you? That's letters.
Maddie.
Okay. But anyway, yeah. Flatties think that they've figured some problem out about that other people didn't think about before. Like, you're not coming into something that nobody thought about. Anyway, that might be an interesting video to address. Are you here to talk about that, or just because you want to be on Discord?
I'm new to this, so
Okay.
I don't know. I'm like a nervous wreck right now. I've never joined a voice chat before. I didn't think it was going to send me directly to you.
Oh. Well, here you are.
You're definitely one of my favorites, so it's nice to meet you.
Oh, well, thanks. So to review the idea behind this, and I know it's a weird time for people, but I thought maybe people in England would be kicking up a little bit, or Europe, was to look at potentially creating a video, writing a script for the video in here now, so that it could be, I could then on Sunday record a video live during my live stream. So I don't know.
That'd be cool. Am I the only one on voice with you?
Right now you are, yeah. Can you see, are you on a phone or on a computer?
My phone.
Okay. Yeah, you can't see as much stuff on a phone.
Yeah, I have the Z Fold too, like the big fold out one, and I still like it's too much.
Oh yeah.
Yeah. So like, will others join, or?
I don't know. Let's see. I got another one here from Ion that posted the Dunning-Kruger effect from the actual paper. Oh, that would be interesting. I'll click on it here so people can see. So they graphed out. So the Dunning-Kruger effect paper isn't nearly as dramatic as the fan fiction. Yeah, the fan fiction that we have down there on the bottom. But I think in some instances we do see that. Like, you know, have you ever seen a flat earther think that they know more about a topic than experts?
Of course. I mean, the Dunning-Kruger effect, I think it implies far more than just flat earthers. There's like a pandemic of it right now across the world with this intellectualism.
Yeah. I see Icy Spin has popped in too.
I figure I'd jump in so he doesn't feel all alone.
Yeah, it was a little like, I guess I'm the only one here.
I don't usually do a lot of stuff on the voice chat on my Discord server, so people aren't in the habit of it.
Yeah.
But we got some more
I've been
coming.
watching on YouTube for years, but I just started using Discord, so like this is like brand new to me. Like I knew it said to like join voice, but I really wasn't expecting to get like a direct line. I was like, hi.
All right.
Thrown right into the line stand, right?
Hi everyone.
We got Sergio here, Sergio Garcia.
I think this is the first time I've actually talked with you, Toon, so nice to officially talk to you.
Oh, yeah.
Sorry about my pronunciation. I'm Spanish and I'm learning with your videos.
Oh,
so thank you very much for your
that's good.
You're
a golfer.
Physics
You're a
classes
golfer, right?
and English lessons.
A golfer? Sergio?
Yeah,
What?
Sergio Garcia. Isn't he a golfer?
Oh, I don't know.
Can you hear me?
We can, yes.
Okay.
Yeah, I'm just interrupting. Sorry, go ahead.
And we got Blitz.
I'm very shy, so sorry about that.
We got Blitz here.
So MCToon, you're doing a marathon to raise the funds to get you to Antarctica, or what? Is that what's happening right now?
That's the plan, yeah.
Gotcha.
I'm at 16,000 about of 40. So
Jeez, it's that expensive, though, huh?
Yeah,
Holy shit.
just the portion of to ALE is 33,000, 32,500. No, 31,000. I don't know. I'm forgetting. I've got it all in a spreadsheet.
Yeah.
Well, let me pull it up. There it is. 31,900 is the Antarctica portion of it. But then I need to fly down there. I need to buy about $2,000 of gear. I have to pay for a hotel. I have to get a insurance, like in case you fall down a crevasse insurance. Yeah.
Jesus.
Seriously, I mean that's.
I mean, yeah, I know it's real. Yeah, absolutely. Well, I'm glad you're going, because I know when it first started coming up, the final experiment, that you had said no. And then I saw your video where you had said that you actually like purposely waited so you wouldn't scare up any of the other players.
Yeah, and I didn't even want to say that, because I'm like, well, am I tooting my own horn to say that? And I asked Jaron. I said, I asked him about that. He said, no, you're right.
Yeah.
That if I had been always going from the beginning, that probably other flat earthers would not be interested.
Well,
so.
I would definitely say you're one of the like stronger debaters on the whole flat earth topic. That I can see that being tough to go against or want to bump shoulders with in person.
Yeah, I don't know how it's going to go with Witsit there, because he's I have no idea. Anyway, Sarah Ewan says, didn't Witsit used to criticize NASA for exaggerating links to the Nazis? Now he's a white nationalist. Make that make sense. Yeah, that's.
I haven't seen the video that was pinned in your chat. Is it pretty bad?
Yes.
I think I saw, it might have been Creaky that just did a video with CC, or maybe somebody, but with CC, and he included some of his political rant, and I never knew that like CC leaned that way and like had those kind of anti-immigration feelings and stuff, and I was like, wow, why is it seem that like so many flirts, they all fall into that same camp? It's bizarre to me. Like,
yeah,
it's because conspiracies inevitably, if you dig deep enough, every conspiracy is about the Jews. Every single one.
Yeah, I know it does. A lot of them go down that rabbit hole.
It's really sadly true, Blitz, that Veritas, the guy that did the 8-hour documentary. Yeah, he made that point too.
I don't think I've seen that. I know who Veritas is, but I haven't seen that.
It seems the bottom of all it's a religious thing.
Yeah, now I've seen others. So like I that Sam Abayusa guy who's French, but he lives in Israel and he's a Jew now. I don't know if he was before or not, but anyway, he says it's Catholics. Right? So he's kind of departed from the tradition. Yeah, he's like, it's the Catholic spinning water ball. Like, what are you talking about? Well, the Catholics introduced the globe in the 1500s. No.
Didn't they like vehemently fight against it?
Like he was so wrong on such a ridiculous level. Like, it wasn't the globe wasn't introduced in the 1500s, and it wasn't the Catholics that introduced the change in the 1500s. It was heliocentrism that was introduced, and it was the Catholics that were resisting it. Right. So backwards.
Yeah, they watch something and stuck in it forever. No evidence can throw it away.
So Icy Spin posted Sergio Garcia there. A Spanish professional golfer. Yeah.
He took out some time out of his day.
What happened?
To come in here and talk.
I appreciate that you're coming here, Sergio, from your 36 international tournaments as a professional wins. That's great.
Most notably, the 2008 Players Championship.
He's got the Wikipedia up.
What are you talking about? I don't know. What are you saying?
Garcia with the same accent mark over the I. It has to be you.
That's funny. So there's a chat, the Choose Your Own Adventure chat. Icy Spin posted the Wikipedia article to you, Sergio.
Oh no, where is my hair?
Yeah, you're trying to play it off.
It's an old photo. You went to Turkey and you got implants.
I don't know, that Sergio Garcia looks a little bit like Carl Pilkington, if you ask me.
Yeah.
Did people do
any more run-ins with Darth Dawkins? Just curious.
What about Darth Dawkins?
We have a lot of Sergio Garcias in Spain.
I was wondering if Blitz had any more run-ins with him. I caught a video of his a month and a half ago.
I had a run-in with him a few weeks ago, I want to say. I was on somebody else's live stream, one of the acolytes of Darth Dawkins, and then when he couldn't hold up his own end of the argument, he called in Darth Dawkins.
There's Darth Dawkins. Oh man, I can't stand him.
Don't even go looking. He's ridiculous. It's not worth it.
It's not. No, it's not worth the headache.
Anyways, the Earth is a globe.
Yeah. I've happily rarely heard Darth Dawkins. I've only almost exclusively just know him by his incredibly bad reputation.
He's a one-trick pony, if you will.
Yeah, it can't go off script. It's amusing the first 13, 14 times, and then it's like, all right, this guy really is.
It's similar to Kent Hovind.
Yeah. Does he bring the the SpongeBob?
No, he's like an angrier version of Ken Hovind. He's less fun-loving.
Yeah,
that's possible.
Angry Kent Hovind.
It's got a different type of word salad than Witsit, but word salad nonetheless.
I love that.
Did you all see when Professor Dave explained really pulled out the bottom of the salad? Trust me.
That was good.
That was amazing.
Has anyone come across the Creation Museum on TikTok?
No.
No.
You're talking about Ken Ham?
No, they do. He does a live. There's this guy. He works with the Creation Museum, and he goes. He has a chart. Apparently, a chart that goes all the way back to the beginning of time. That's only 4,000 years ago, and he gets these calcite buildups right within pipes, and tries to say that's like the speed of geological process. I don't know how he relates that to like his delusion.
Great.
I thought the
lime scale buildup.
I thought the Bill Nye Ken Ham kind of walking tour was interesting. I know you're not a fan of Bill Nye so much, Toon.
I haven't seen that debate.
I don't like Bill Nye.
He's a childhood hero.
I know.
He did good on the. He had a debate with Ken Ham too, but he also went to the Creation Art Museum. I guess it's like the museum he built an ark. It's like in Tennessee or
somewhere down south.
It was good. I mean, Ken Ham was just spewing nonsense, and Bill Nye was like, actually, we need to promote science more and this and that. So I mean, he did a good job at kind of like keeping Ken Ham in check. I guess, as it were, but it's
They're so
here or
set in
there.
their ways that there's no amount of evidence that other than like even the flares, like unless you put them on a commercialized flight to outer fucking space, they're never gonna admit. Like they're just
No,
not.
not even if you did that, they would still deny it.
It's CGI.
I think the goal is to just kind of intercept
They'd just
their
be like,
voice
"Oh, that was
and try to.
screen. That was screens inside our thing. We didn't go above the. We didn't even go above the Kármán line."
Has anybody thought how the world would work with Earth's physics? You know, no gravity, no planets, no space.
Nobody ever has.
100,000 suns.
Yeah, so much physics would have to be different.
Yeah, so many things would have to be.
unexplained.
Yeah, there's too many observations to support the reality that we exist in. Is that we're on a fucking globe that's spinning through the space and time. That we've measured the orbital mechanics over time, and we've learned from the past, generations. We're not banging sticks and stones anymore. We're building high-powered rocket engines.
What I don't get is like you can't deny like our science, like it does line up, even if they don't believe it. Like, fine, okay, I'll accept that you say you don't believe it, but the facts line up correctly. So if it's not that, then what is it? And they never have a replacement.
That's the point.
What didn't you know
what
that
level of technology
is independent of replacement?
I've heard that before.
Yeah, that was Whitson. Did Whitson say that?
Yeah, man, who said that?
Just
What did you
imagine.
Imagine a Witsit world. What will be the technology level? If we obviously
nothing. There'd be nothing.
There's
Stone
no
level.
space, no satellites, nothing.
What measurements? You're not going to get any of that information from these people.
Maybe Iron 8.
So here, Austin simultaneously doesn't have a model.
I don't have a model.
Did you hear that on Discord?
Yeah, it was good.
And says that his model is better.
Although not even specifically claimed or defined, is far superior to yours because it's limited and falsified.
There it is.
Pick a side, buddy. Pick a side.
So the model that they don't have is superior to the globe model. And in his claim that his model is better, he says that it's not well defined. His not well defined model is better than the globe because the globe, he says, has been falsified. Wow. I mean, how backwards could you be? Right? Yeah. The problem with flat earthers is they don't test the globe model. They test the straw man of the globe model. They don't understand the globe, but then they think that they do, and they test the limited understanding of the globe that they have.
I always ask them a lot of these things. I love asking specific questions like, why was the gyroscope invented? And they never know that. Like, I have Google right here. It's like, this is how easy it is. Hey Google, why was the gyroscope invented?
Oh, the answer is obviously going to be fake.
Yeah, I think the bigger problem is how they completely misunderstand how science works.
Part of the rotation of the Earth. When the Earth rotated beneath the gyroscope would maintain its orientation in space.
There we go.
You sound different.
I can't imagine living life like with that much distrust of everything and anything. You don't trust anything.
But these things you could do yourself. A gyroscope is just a rotating. It's just
50 degrees per hour.
Yeah, rotating ring with bases.
Like, it's less than a $30 setup, and you can prove that there's a drift.
Indeed.
Well, no, hold on.
Peer review.
For $30, you're not going to make a gyroscope that's precise enough to measure Earth's rotation.
The drift, the 15-degree drift, yes, you can.
For $30?
Yes, for $30, I guaranteed I could wire up something that would.
I'm sure with enough ingenuity.
And with a pendulum?
No,
It's more cheap.
No, it would be a magnetic gyroscope.
Maybe.
That I would have with like a single Arduino board.
Well, what's a magnetic gyroscope?
It's like a gyroscope that you're adding energy, but you know the amount of energy you're putting into it.
So it's physically spinning.
Yeah. And it just keeps it stable, and it will, by natural precession, it will process in a rotational direction.
So the reason why I'm pressing X to doubt is because Globebusters actually commissioned somebody to build a gyroscope, a physical gyroscope, and they did. It was a pretty good one. Globebusters tried to hide the evidence because it processed. But it was pretty difficult to make because just the bearings are rather expensive, because in order to have it spin for long enough to actually get a measurement that's not something that's the friction.
Over an hour period.
Yeah. But yeah, the bearing was the most difficult. I think one of the most difficult things.
You can calculate the torsion over time. You don't actually have to so you could indirectly calculate the drift. You don't have to, you know what I mean?
Nope.
The way you're doing it is you're just sensing the difference. Like there's going to be an angular, it's going to want to change its angle, right? So it's going to exert a certain amount of.
Yeah, it's going to process.
Yeah.
Yeah. Okay, so I just posted there from Jesse, is Jesse Path of Light, who is active on Discord. That is the mechanical gyroscope that
that's a big one.
Yep, that Globebusters commissioned to be built, and it measured 15 degrees per hour drift.
And Stefan guy is a flat earther, right?
Yeah.
Or Steph.
All right, so we've got just a second. In the chat, we've got Scott's Tots Gaming, who I think is being a little bit of a jerk face. So Scott, I don't know what you're about, but it doesn't seem to be the kind of stuff that we want here. So I don't know. You can either stop it or I'll stop you.
What's he doing? I can't see it.
Well, he's being kind of racist.
Hey, Jesus.
Yeah. So I'll say, I'm at in about 13 minutes is when I'm planning to end this section and then go to the debunking playlist, and I won't be here during that portion. I'll be unconscious for most of it. But people, yes, if Scott continues to do what he's doing, then you just block him. So anyway, keep going about the gyroscope.
I think
I think Blitz was saying something about the gyroscope a little bit there. Do you have anything about that? Any thoughts on it?
I was just saying that, maybe you could do it for $50 if you're an extraordinarily talented fabricator, right? Like, if you know how to weld and you know how to machine, then maybe you could do it.
Yeah. I'm sure somebody can pull it off.
But most people aren't that, so.
Yeah.
Or if you could rent a gyro.
Well, that'd be a little better way, yeah.
I mean, I don't really see the point in this anyways, though, because we all saw behind the curve.
I already know.
They spent, what, $2 grand on that thing?
Okay. You got to go one at a time.
Sorry. Did you rent a theodolite when you did the football field measurement? I think you were talking about doing that at some point.
I thought about doing it. In the end, I knew I did not have enough time at the field to actually do any sort of a leveling exercise. So I didn't do anything other than just go to the field and take some pictures of it. So I hope to make a video standalone video of it, but I took pictures from the side where you can see the field is curved. You could, standing there, you could tell. A theodolite's a surveying instrument that measures vertical and horizontal angles.
Gotcha.
So
it's like when you see the guys on the side of the road
with the tripod.
It looks like a tripod. Yeah.
Yeah.
Yeah, this is where you get into tensors.
There's an app too, like a theodolite.
Yeah.
Yeah, Toon's got experience with that.
Yep, when I flew from Anchorage, Alaska to Minneapolis in 2019, I used the theodolite app on my phone to measure if the horizon rose to eye level. Turns out it didn't. The moon was below eye level. So I was at about, this is amazing, I was at about 35,000 feet. So according to Flat Earth, the moon could be no higher than 35,000 feet at that instant.
Yeah. So I'm curious about, because I've used these apps before on planes too, and you can see the horizon dip. But I'm curious what mechanism the phone uses to determine what level is, because if it uses an internal accelerometer, there might be issues there, because if the plane is, moving up, if the plane is climbing or decreasing or whatever, then your accelerometer would be thrown off.
Yep. Yeah. The accelerometer, it is using a 3-axis MEMS accelerometer, and yes, if you're banking, it can get it incorrect, or any of those types of things. So yeah, you have to be flying at level flight, as they say. So there's ways. Of course, if you just recorded a video for long enough, you could tell, because it would be, you can only bank for so long on a plane before it's gonna, have to straighten out. But yeah, flat earthers have said, well, how do you know you weren't, how do I know you weren't banking? And the answer to that is, you can also take a flight and you can also do the measurement. You don't debunk that measurement by saying, nuh-uh. You debunk that measurement by doing a better measurement.
And to be honest, it's not like an insight, like it's not like, measurement error. Like it's a pretty significant amount of dip too at that height.
Yeah, 3.5 about degrees.
Yeah, which is easily detectable outside of experimental error.
Oh yeah. The accelerometer in the iPhone is rated at 0.01 degrees. But the display on the theodolite app is only precise to 0.1 degree. So, but yeah, the dip is 3.2 to 3.5 degrees. So, I don't know. I've not seen any flat earthers ever repeat that measurement and say, oh, look at this. The only thing they ever do is they take a phone on a plane and they record out the window with no measurement and say, it rose to eye level. How did you measure that? They didn't.
No, they just say, look, it's flat.
I have video from my flight when I took a Bell helicopter out of Florida at Cocoa Beach, Florida, and flying over the NASA landing pad for the shuttle. I got to fly over that, and
that's pretty cool.
It's like when I was at the beach, I was at sea level. When I was at the beach, I have recording of it. You can't see the shipping lanes. But the moment I lift off and get a certain altitude, you can see the shipping lanes.
Yeah.
And you can see all the ships. And it's like, how does that work? You can't do that on a flat Earth.
Well, they, as we just saw in the previous guest here, he can't even begin to do middle school geometry and math. And that's par for the course for flat earthers. So when we're like, well, it's predicted on a globe that when you increase in elevation, you will see farther. They're like, nah. But then they hear some word salad from some other flat earther about, whatever it is. It doesn't even matter what it is. It's just a
azimuthal grid of vision.
That's one of them. Yep. Or some other collection of words about, well, when you have a better angle of view, therefore you can see farther. That doesn't make any sense. There's no
Rayleigh criterion.
It would really blow their minds when they figure out that all maps are wrong.
Don't tell them that.
Well, they try. Then they try. They have, and they're like, "Aha!" Like, yeah, you don't get that. That's proof. That's evidence for that's evidence for Earth is a globe.
Yep.
If the Earth were flat, then a flat map of a flat surface, you don't need to do any fancy projecting. You just make a 1-to-n map and you're done.
Yeah, you wouldn't have to worry about the tensor unit of the curvature.
Yep.
Well, they say always nah or that's weird.
That's it, yeah.
Did you see Red's Rhetoric stream with his new telescope?
I did not, but I saw some people posting clips of his stream. So
it was fantastic.
Yeah.
He found 2 geostationary satellites and was tracking them, and you could, because he overexposed them for 15 or 20 seconds.
Yeah.
In between each shot, and so you could literally see the stars that weren't visible, like streaking across the screen behind the geostationary satellites. It was pretty awesome.
Yeah, that's cool.
Toon, I have a question about the final experiment.
Sure.
What do you do you know what the surrounding it my thing is that I'm convinced that if there's a mountain that's in the way of the sun for even a minute, they're going to use that as we don't know what happened behind the mountain.
Yeah. So we know what latitude we're at. We know how high in elevation the sun will be. So at midnight, the sun will be 13 degrees elevation. And we know, I had done the analysis for the landing pad before I knew where the actual camp is, right? So the landing pad and the camp are about 10 kilometers apart.
Yeah.
So we heard from somebody at the camp there that where the camp is, it's closer to a mountain. So in the very early morning, the mountain is at camp blocking the sun. But we're going to move for observing the sun. We're going to be at a different spot where we don't have an obstructed view because of the mountains.
All right.
So, yeah.
Okay, good. Yeah, because I was convinced they're gonna pull the sun simulator argument. Or something like that. They swapped the sun.
Yeah. So
I think that's what the due south argument's for, right?
Yeah, that's the whole thing. And of course, if it's lowest in the sky when it's due south, and the mountains are due south of where the camp is approximately. So it's probably right about there. So camp is probably there, but we're going to be I think we're going to be east of the camp where we don't have an obstructed view. So.
Good. Are you going to be using sled dogs?
The point is, even with a fake sun simulator, you said, MCToon, it will be black everywhere. Like a lamp, So it's impossible to fake that.
Yeah, the sky will be blue. And if somebody did have some sort of an incredibly powerful spotlight, the sky would be black.
Exactly.
Yeah. Plus zooming in on it with the solar filter would show.
Filter.
Yeah.
Yeah.
So then the other, the other thing that
does not know that.
The other thing they talk about is it could be reflecting off of the dome. Well, of course, why would you not see the sun directly? But if it is reflecting off the dome, then, I mean, as ridiculous as it is, then it would be a mirror image. So again, seeing the unique pattern of sunspots will identify that.
Yeah, that makes sense.
You would also see distortions as a result of the reflection, and this can be easily demonstrated just using optic simulators.
Of course, yeah. Again, things they don't understand.
You have reflections with your glasses? imagine a giant dome. It will be crazy. The reflections, the lights. I don't know. It's very weird to think about.
I mean, I had this conversation with who was it? I had this conversation with somebody who was making this claim about coffee cup caustics and reflections, and that's why blah 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 blah. And like there's only really two options here. Either you have specular reflections, diffuse reflections, or something in the middle. You only get coffee cup caustics if you have diffuse reflections. And so if you have diffuse reflections, you wouldn't actually see the sun. You would just see a kind of glow around the edge. And the only way you would see the sun is if you have specular reflections. And if you have specular reflections, you would just see two suns. You just see the reflected image and the actual thing. So there's no two ways about it. You can't have both. And we observe neither.
Yeah. It doesn't get you very far.
That's also very interesting. Sorry about that.
I need to get some sleep now. So what I'm gonna do, I'm gonna drop out. You guys can keep talking in this channel if you want, but I'm gonna drop out and I'm gonna put my my live stream in the playlist for people. So thank you very much to all of you in the Discord chat here, and I'll catch you all later.
Yeah, it was fun.
It's been a pleasure.
I'm gonna drop off. Sleep run. Good luck, night, guys.
All right, see ya.
Good night.
Okay. Well, this has been quite something. So here's the plan. As I said, I've got a playlist. I rendered the entire playlist into one long video. This playlist is a bunch of videos, including, as I said, Slice Arcane. I picked them individually. Like, I didn't just go watch every one of them. It's over 6 hours long. So I'm planning to sleep for about 6 hours, which is about a normal amount of sleep for me. So it'll be the bottom of the screen has the live chat, so you guys can keep chatting, and the top is just the donation stuff that I've had up before. And then there's a view of the room, so you'll be able to see me when I'm coming in and out of the room, if I do come in and out of the room. So anyway, thank you so much for sticking around for this portion of it. There's more to come. Let me make sure that if there's any super chats, I haven't missed any before moving on. Just a second here. Oh, I got a couple. It's past your bedtime says, "What are you doing up so late?" It's past your bedtime. That's so funny. I love that. Thanks, past your bedtime. And CJ Lamoureux says, "Up for work 5:30 a.m. to 8 p.m. today. I'll be watching all day, hanging out with you, Toon." Awesome. Well, these next 6 hours, the playlist is going. And I tell you, editing this playlist, these are great videos. They're fantastic. I hope that you really do enjoy them. Gary Donnelly is a member at Newton, says, "Sweet dreams. I hope you sleep well." I hope I do too. You know, sometimes you get so tired you have trouble sleeping. I hope that's not the case. So anyway, we'll start it off. Make sure it's all running before I head off. Looks like it's going.
So, as you can see, after my last video, Nathan Oakley 1980 from the Flat Earth debate team posted a question, which I'm going to try and answer for him today. I'm also going to give an advert to Nathan's show because he's done the same for me in the past. Thank you.
Thanks for the advert. I really appreciate it when my bitches do work for me.
Oh, sorry, Nathan. I thought we were pretty cool with each other.
No, you little bitch.
Oh, I think I need to start again. I'm not here to debate you or fall out. All I want to do is just answer that question that you left. That's it.
I don't give two shits if you want to debate me.
All right, I think I need to do something to sort this out. You know, can we just start again? Or, you know, how can I make this better?
If you want this all to go away, you can. You can make it disappear instantly. Just stick your tail between your bitch legs and fuck off.
All right, Nathan, this has got to stop. I've got something to say to you.
If you've got something to say to me, just come and say it. Like all the other globehead bitches who've had their heads ripped off by me. Yeah?
I don't want to say it anymore.
Buddy, bitch, you need to understand, you're not holding any cards. I'm holding all the cards.
How did you do that?
You can click that little button.
And subscribe to Conspiracy Cats now.
Well, that was how this video was supposed to start when I started making it on Monday. But then this happened.
Well, hopefully we'll get Conspiracy Cats joining. Nice chap that he is. I expect this conversation to be extremely civil.
And I was. I was very civil. I was very polite. And then, Father of the Year, Nathan Oakley, for some reason decided that it was my turn to be on the end of a firm hand. Watch this.
Father of the Year.
Don't
Love it.
explain it to
G'day.
me. Show it to me.
All right, I'll tell you what, Nathan. We'll pick this up another time.
No,
I'm
why?
quite happy to chat with you, but I'm not one of your bum boys who's going to be shouted at. We'll pick this up another time, pal.
So, what happened was, I started doing some actual science and talking about some actual scientific concepts. Nathan couldn't handle it and decided to start shouting to try and divert away from the fact he had no idea what I was talking about and I was about to prove him wrong. So, that has somewhat changed the course of this video. The editing and the continuity might look a little bit odd, and I might look like I'm wearing lots of different clothes at lots of different times a day. But let's start the video again now.
Welcome to Flat Earth Debate. I'm your host.
And I'm thick as pig shit, so why don't you watch Conspiracy Cats instead? And remember
to subscribe and hit the bell notification icon to keep up to date
with how Conspiracy Cats tears me a new one every single week.
So, this week, Nathan Oakley called me a bum boy.
Bum boy.
And his bitch.
Yeah, that's what I make people like you Conspiracy Cats, my bitch.
And then he named his show after me. He then even came to my channel and reminded me again that I was his bum boy. So I gave easy picking, low hanging fruit, Nathan Oakley a choice. Change your tone and the name of that show, or this. Now he decided this. So, Nathan, you are going to change the name of that show, and I've thought of a brilliant name. It could be Nathan Star Performer Conspiracy Cats. Now, I know that's a bit of a mouthful. So how about the acronym of that? NSPCC. Maybe we should look into that.
Nathan, can you hear us?
Wow. That's odd, he must have turned his microphone off. Now, rather than sinking to the level of Superdad and sticking with personal insults, I think it's important that we look at Nathan Oakley's ability to do and understand science before we teach him some science ourselves. Now, let's remember, and this is really important, this is where the irony lies. Nathan Oakley hosts a show every day called the Flat Earth Debate Show, where he actually uses his understanding of science to debunk the heliocentric model. This is really important. He tries to debunk the heliocentric model. So you would think it reasonable that he should have at least some sort of understanding of the heliocentric model, because otherwise he would look bloody stupid, wouldn't he? Let's test him out.
Excuse my ignorance. Is the moon between us and the sun in the heliocentric
Yes,
model?
but not.
You're so dumb.
A new moon, yes.
So if I drew a line of sight from my position on a sphere Earth to the sun, the moon would be in between on that line.
During an eclipse, directly in line, yes.
That's what I'm trying to get clarity on. It. If it's not directly in line, what is it?
You are really dumb, for real.
Only perfectly between us when it's an eclipse.
Sure, but is it between us and the sun?
You're so dumb.
Just explain to me. I'm ignorant. Literally, I don't know.
Well, I'm not going to argue with that, Nathan. You really are ignorant and thick as a brick. Let's carry on.
But every month, you'll get a new moon and a full moon. The new moon is when the moon is in between the Earth and the sun, and the full moon is when the moon is, on the other side.
Oh, forget the full moon. So, does the moon sit between us and the sun?
You are really dumb, for real.
For God's sake, man, it's not that hard. You run a debate channel where you try and debunk the heliocentric model. You are clueless. You are genuinely clueless, man.
So it is physically between us and the sun, but because of the way it works in terms of how it lights up throughout the month, you're saying we shouldn't see it.
You're so dumb.
So when we have a transit of, say, Venus, and Venus goes between us and the sun, in the same way the moon is going between us and the sun. We see it between us and the sun.
You can see the transit of Venus, yeah.
Right. So why don't we see the transit of the moon in the same way?
Now, when I decided to show everybody your intellectual understanding of science, this episode jumped to mind because I listened to it live. And this was before we fell out, and I was cringing with embarrassment for you. Really cringing with embarrassment. This is embarrassing. The 11-year-olds I teach can understand this. You don't even have an 11-year-old understanding of the heliocentric model, and you are trying to debunk it. That's either very, very arrogant, or very, very stupid.
Because it very rarely crosses directly in between.
Yeah, I just established that though. It is between us and the sun. That's what you said. Yep. That's why I got clarity. Yep. And in the transit of Venus, it is between us and the sun. It's the same, right?
Yeah.
Right. Hold on. Stop. So it's the same, and we see the transit of Venus, but we do not see the transit of the moon.
Yeah, the transit of the moon is an eclipse.
That makes no sense.
That is what an eclipse is a transit.
Sorry, is the transit of Venus an eclipse?
It's unbelievable, isn't it? And this went on the whole section for about 40 minutes. He had to have his hand held and be walked through 11-year-old science just to get the understanding. And he still didn't get there. But you'll notice at the end of that clip I've just played, he starts to raise his voice and get a little aggro. He suddenly thinks after the 20 minutes he's had his hand held that he's now an expert and he can start debunking the model. And that's what he did with me. I was very polite and I was talking to him in a very civil manner. But he didn't agree with it. He had the same level of understanding as he does about the moon phases and decided to get a little bit gobby. Now, Nathan, I am going to give my answer when I'm nowhere near your mute button. Both myself and Red's rhetoric know you can't do without it. Now, Nathan, I could go on and on and on and do at least another hour and a half about your inability to grasp key stage 3 science concepts, but I want to help you out. Now, why do I know you need helping out? Well, after our little debate, I went on your social blade stats, and immediately after I left, I took a snapshot, and this is where you stood. Yes, Nathan, that big red 4, that -4, shows that during our little head-to-head, your subscriber numbers dropped. Now, anybody is free to look up my Social Blade stats for Thursday, the 23rd of August. And what you'll find is I gained 86 subscribers that day. So thank you, Nathan, for the advert. I really appreciate the exposure, pal.
You cannot have gas pressure without a container.
All right, I'll keep this brief. Let's look at how pressure works. I want you to imagine you stood in a room, you've got a basketball, you throw it at a wall, and it's clear that that wall is going to feel a force when the basketball strikes it. And if the wall is only made of plasterboard, for example, the basketball might go straight through. Now, we get a force, or we can determine that force through the equation force equals change in momentum over time. And when the basketball bounces off the wall, it changes its momentum. Now let's change that analogy and look at a balloon. And the air particles inside the balloon are like the little basketballs, and the inside of the balloon are like the walls. And when the particles of air bounce off the inside of the balloon, then they are creating a force. And if that force is big enough, it will cause the balloon to expand. Or if the net force, the expansion force, if that's bigger than the force pushing the balloon in from the particles striking on the outside, that will be the atmospheric pressure. Then the balloon will expand. Now, what Nathan is saying is you can't have pressure without a container. Now, in a way, and only in a very small way, he could be determined to be right, because without something for the particles to be striking, you're not going to get that change of momentum. But that doesn't mean that there has to be a dome. All that means is I just take the balloon away. Without the balloon, these air particles aren't going to be striking anything. Therefore, there is no pressure. Now, Nathan seems to think that because we say the upper atmosphere has a PSI of whatever, he seems to think, well, how can there be a pressure up there? What are they hitting against? They must be hitting against a dome. No. What they're saying is, if I was to put an object that high up in the atmosphere, and that object was a square inch, then the PSI is the pressure it would feel if it was there. It's very much like saying, you know, if a tree falls in the woods, does it make a sound if nobody's there to hear it, right? Is there pressure up in the atmosphere unless I put an object there to experience that pressure? That's what I would have got across to you yesterday if you hadn't been such a knob. Right, you prick. Now, let's talk about moon phases, because he really struggled with this. No, Nathan, we won't actually look at moon phases today, because you see, there are so many examples of where you have gone so wrong and been so dim in all your debates. It would be remiss of me not to highlight every single one over the next 12 months. Now, you can make this go away. Debate Red's rhetoric. Get out of your comfort zone, get out from behind your mute button, and actually engage in a scientific debate. Until you do that, I have this little pussy here. I'm going to call this little pussy Nathan. And little pussy Nathan is going to live there. And every video I make, people are going to be able to see little pussy Nathan until he actually debates somebody from out behind his mute button.
The most obsessed with conspiracy cats YouTuber of the week. Science, you lot have nothing but fairy tales to back your delusions. Natural science is going to give you NASA fanboys nightmares for years to come. Keep digging your grave, you arrogant twat. Your days of mental child abuse are numbered.
So, Stuart McKenzie there from the YouTube. Now, Stuart McKenzie sent me that because I dared make a video in which I used the Boltzmann equation as a scientific explanation for the distribution of gases in the atmosphere. Now, not being able to understand any of the science I posted in the video, he decided to call me a child abuser. And then when he didn't get the response he wanted, he sent me this.
I am waiting. Testicle lover?
So we are well used to posters like this now. Stuart McKenzie, a typical moisture baiter. Very quick to go onto someone's channel and say, oh, you're just a fanboy, NASA fanboy, you don't know anything about science, blah, blah, when really they've just been presented with a 17-minute long video containing at least 10 minutes of scientific explanation in there that he just fails to address. But I've got Stuart McKenzie with me right now. Now, Stuart, why would you post something so ridiculous on my channel?
By accident. You know, you start off saying, don't do it. Next thing you know, you're doing it.
All right, well, look, we all make mistakes, man. I forgive you.
You're a special kind of guy.
Oh, cheers, pal. Just in future, you know, just show me a little bit more respect, yeah?
I'll give you respect. You deserve it.
All right, man. Well, thank you for coming on.
I'm here to do this for you because I worship you.
That's a bit strong.
I'm bowing down to you.
Right, you're freaking me out now.
I would prefer to worship you without you worshiping me.
I didn't say I was going to worship you. Fuck off!
I'm worshiping you.
You need to leave. Now.
I freaking worship you. I mean, what would I do without you?
I am in love with Ron Burgundy.
I'm not special. You know, you're special.
Oh, you're special, all right. Now, I really apologise for the disjointed nature of this video. It really was meant to be something else. Nathan, this is a path you've chosen, not me. For the benefit of everybody here, I did send a message to Nathan after that debate, you know, to try and sort things out. And he responded by coming back to my channel to goad me, which is why I've taken this. And I am going to make him look every bit the idiot that he actually is. And the thing is, he has no credibility whatsoever. How can you have such a lack of understanding, but yet claim to be such an authority that you debunk people? Well, you can only do it with a mute button. It's going to get embarrassing for you, Nathan. Anyway, the clip you've just seen was meant to replace the Chatbox Travels for this week because this video has been sandwiched together in a really strange time frame. What I would ask the Conspiracy Cats subscribers, if you happen to want to help me on this, okay, if you have the time to do it, if you've got a clip of Nathan's, a real favourite clip of yours, where he demonstrates his amazing intellect and you'd like me to put it on here, because I am going to do this every video for 12 months if I have to, until Nathan can come down. Sorry, little pussy Nathan. If you have that, whack it in my comment section, and that would be a real help to me. And if you haven't, no problem. I'll enjoy listening to his idiocy myself. So Nathan, it's game on. However you respond, just remember, you are nowhere near as good as me at this. See you, Super Dad.
Hi folks, this is Astronomy Live. Back in September of last year, I did an analysis of this time-lapse, which was taken on a flight from Zurich, Switzerland to Sao Paulo, Brazil. Taboo Conspiracy claimed that this video contradicted the globe, but I wrote some software to do an accurate prediction of what the globe expects and compared it to the time-lapse, finding that it matched perfectly, and that the flight was indeed flying over the curvature of the Earth as expected. Taboo Conspiracy is not so happy about that, though, and he's got help here from Matthew, and together they've released another video calling out MCToon and myself. Matthew here is very confident that the time-lapse he's presenting of a flight from Sao Paulo, Brazil to Lisbon, Portugal contradicts the globe. But before he even released his video, I asked him for some very specific information about the time-lapse. I wanted to know the exposure length of each frame in the time-lapse and the date and time of the flight. He claimed it was because I was going to say it was fake. I'm not sure why he thought that, but that's certainly not what I was planning on doing. It's certainly not what I did in my previous video on this subject with MCToon, and I cited that video and asked him if he had watched it. He finally posted his video, and he posted a link to the video that he sourced for this time-lapse of a flight from Sao Paulo to Lisbon. He said the date was on the video, but he wasn't sure about the flight number, and he didn't know anything about the exposures of the frames. In fact, the date shown on the video that he's citing only provides the month and year, not even the day, let alone the time. Now, Matthew was working with Taboo Conspiracy to analyze this video. Taboo was also the one we were responding to in our previous video on this subject. And Taboo's analysis on this video also doesn't give the information on the exact date and time or the exposure length of each frame. More on that in a minute, but first let's hear why Taboo thinks this video contradicts the globe.
If the jet's flight heading southwest was perfectly offset by the globe's alleged rotation, then if the plane turned around and headed the opposite direction to the northeast, then the upward movement of the stars, as modeled by Google Earth, would have to double. It's not like the Earth's rotation can switch directions for different flights. By switching the aircraft's heading to the northeast, the flight and the Earth's rotation would no longer be opposing, but would be combining to double the apparent movement of the stars. You can watch it yourself, but facing northeast, the stars should rise up and rotate counterclockwise. And that's exactly what the stars do. Of course, some of the stars rise up in the middle, but the ones on the left actually drop. That means they're rotating. Regardless, there is no indication of a curvature adjustment, especially when you consider the fact that we should be doubling the amount of upward star movement if the canceling out claim were true. For the second segment of the video, we're going to see two sets of islands before the plane lands in Lisbon. The Cape Verde Islands, or Cabo Verde, and you can actually see the volcano Pico do Fogo very well, and then you see the Canary Islands. That gives us a time lapse of approximately 2,000 miles confirmed by the islands. Even at 2,000 miles, the upward movement of the stars should be very recognizable. Here is what it looks like on Google Earth. But remember, assuming the canceling out claim of our globe proponents was correct, the time-lapse of the stars filmed by the pilot traveling northeast should appear twice the amount shown right here on Google Earth. You can essentially double the amount of movement you're seeing right now, and that is what we should see if we lived on a ball. Now, let's watch the actual 2,000-mile time-lapse, and we're going to concentrate on just one star right here that's visible right from the beginning. Again, the stars are going to rotate counterclockwise. Some stars will rise, but this one will actually drop.
Astronomy Live cutting in here to say that I want you to take note of how long this time-lapse is taking to go from Cabo Verde to the Canary Islands. When you saw his Google Earth time-lapse, that was on loop, and it was much faster than this time-lapse. But that's not the only very important difference here, and we'll address that in just a minute. For the moment, back to Taboo Conspiracy.
And here it is, right before landing in Lisbon, Portugal. Here's the beginning position. Here's the ending position. The same star was visible for over 2,000 miles heading northeast. Comparing that to what we should have seen if we lived on a globe, the truth becomes obvious. There is no curvature adjustment by aircraft. This ends the globe. The upward movement of the stars should have occurred, but it did not. As confirmed from several video sources, commercial jets do not drop their noses to account for the curvature of the Earth. Forget my 20-mile laser test proving the Earth is flat. There is no measurable curvature over 4,900 miles. No curvature of the Earth means the Earth is demonstrably flat. Thank you for watching.
So, remember what I asked before this video was released? I wanted to know the date and time of the flight and the exposure length for each frame so that I could properly compare it to the globe. Matthew did not have that information. It appears that Taboo doesn't have this information either, and of course that begs the question. If Taboo doesn't have that information, how can he compare it to the globe and claim to find a contradiction? In fact, Taboo goes right back to the same old well of using Google Earth in the same wrong way all over again, not accounting for the rotation of the Earth during the time-lapse, and not even understanding exactly when this time-lapse occurred or the exposure length of each frame in the time-lapse. His Google Earth version of the time-lapse only takes about 134 frames, or about 4.5 seconds before it loops. For comparison, the second half of his time-lapse, covering the span from Cabo Verde to Lisbon, takes over 20 seconds. He also demonstrates no understanding of my analysis of his previous video, which he mischaracterizes as claiming that the motion of the plane perfectly canceled out the apparent rotation of the stars as seen from the plane. That is very clearly not the case, and in fact what I did was compare the globe model to what we see in the video, and I found that it matched perfectly. This kind of in-depth analysis and comparison requires knowing the flight path of the plane, the exact date and time of the flight, and the exposure length, so that the exposures can be matched to the time that they occurred. That is the reason I asked those very specific questions of Matthew before he released this video. And his failure to provide that information, and the failure of Taboo Conspiracy to even know that information, shows that they did not do the kind of in-depth analysis that I have done previously, and which I will be doing on this video. Again, the video only tells us the month and year of the flight. We'll have to try to figure out the exact date and time in order to properly compare it to the globe. It starts out at twilight while in the southern hemisphere, and we can see a number of stars and constellations. Using astrometry, we can positively identify these stars and constellations. Here's an astrometrically solved frame from the beginning of the video as twilight is fading. We can see the Big Dipper in Ursa Major is prominently on display. The front of the Dipper's bowl points towards Polaris, but Polaris is below the horizon. It's not visible in the beginning of the video because, again, the video starts off in the southern hemisphere. As we fly over Brazil, there's a jump cut in the video, and suddenly we're over the Atlantic Ocean and in the northern hemisphere, but we don't know exactly where until we see Cabo Verde a couple seconds later. The video continues, and eventually they reach the Canary Islands. A short while after that, the video makes mention of the fact that you can see the International Space Station flying overhead, and this is the clue we need to figure out exactly when this video was recorded. We know that the month was April and the year was 2021, but we don't know the date and we don't know the time. But we can conduct a search to see when ISS was at this position as seen from this location over the ocean. We can use the time it took for them to go from Cabo Verde to the Canary Islands to estimate the approximate location over the ocean when the International Space Station appears a few seconds later. We can also see that they start their descent from cruising altitude just after the ISS pass, so we can look for that in the flight data as well as a sanity check to make sure we're on the right path. While we don't know the exact flight used, we know that it was a direct flight from Sao Paulo, Brazil to Lisbon, Portugal. We also know that we saw it fly directly over Cabo Verde and the Canary Islands with no deviations in between for weather, so we can use this flight data as a proxy for the actual flight and estimate the position it was at when the International Space Station was observed. By astrometrically solving a frame containing ISS, we can get its coordinates and feed that into a program I wrote to conduct a search and find when ISS was closest to those coordinates as seen from our estimated position over the ocean in the month of April 2021. The result was April 30th, and not only did the result match very closely with the observed position of ISS, it also confirmed the motion of ISS as seen in the video. The two green circles represent the expected positions of ISS 7 seconds apart, and they are 22 pixels apart. By comparison, the streak of ISS in the frame is about 21.26 pixels long, and so we expect that the total exposure length was a little less than 7 seconds. We now have an exact time mark for when this flight was occurring, and we also now know what the exposure length was for each frame, so we can actually compare this to the globe and see what the globe predicts in terms of the motions of the stars. In fact, we have a specific request here from Matthew to analyze the zenith angles of the stars in the video. He claims that they shouldn't rise according to the globe, so we're going to find out what the globe really predicts. In fact, do you remember that particular star that Taboo Conspiracy was pointing out throughout the video? He doesn't know which star that is, but thanks to astrometry, I have its identity. The star is actually Musida at the very tip of Ursa Major, and so in my analysis we will look at the expected zenith angle of Musida as the plane flies. In the middle of the frame, very prominently, we can see Polaris, the North Star, and so we would expect that all of these stars would be appearing to rotate counterclockwise in this view. As we watch the time-lapse, you will see that, and you will see that Polaris rises in the view over time as the plane heads north, as expected on the globe. We'll also monitor Alderaan in the constellation Cepheus on the right. This will give us one star east of due north and one star west of due north. The reason that Polaris is prominently featured in the center of the view, even though this plane is heading north-northeast, is because the camera is actually panned a little bit to the left. It is not looking dead ahead the way the camera did in the previous video that I covered in September. This is another reason why my software is so useful in this situation. I will project where the plane's nose is expected to be on the globe given its position from the flight path that we downloaded from FlightAware, and given the time information that we're able to figure out based on the exposure length that we saw in the frame from ISS and the time it took us to go from Cabo Verde to the Canary Islands. Here is the fully annotated video. I analyzed the unbroken portion of the video from Cabo Verde to the Canary Islands and then on to the ISS pass to where they start the descent from cruising altitude. On the left-hand side, you can see the date, longitude and latitude, as well as the zenith distance both of Musida and of Alderaan. Musida is labeled with a green circle on the left, and Alderaan is labeled with a blue circle on the right. As a reminder, the zenith distance is the angle between the star and the zenith directly above you. It is equal to 90 degrees minus the altitude over the horizon. So the larger the zenith distance, the closer to the horizon. Also on the right-hand side is a red circle that represents where the globe predicts the nose of the plane should be. The globe prediction has the nose of the plane just above the horizon throughout the entire time-lapse. Again, that marker is placed there based on the coordinates in the image and the globe prediction for the nose of the plane as it flies over the curvature of the Earth. The flat earthers are claiming that the stars we see rising from the horizon, like Polaris, are not rising fast enough, and if that were true, we would expect the globe prediction would have the nose of the plane dipping below the horizon, as it expects the plane to dip more than what we're seeing here in this video, based on how Polaris and the other stars close to it are rising. We also see Musida descending towards the horizon as the Earth rotates, and we can see that the globe prediction has the zenith distance increasing for Musida over time, even as the zenith distance for Alderamin continues to decrease to the point that it's not even in the field of view by the end of the time-lapse. I want to emphasize that the zenith distance data in the top left corner of the screen is not empirically determined. This is actually the globe prediction based on the position of the plane from the flight path data that we got from FlightAware. And we can see that that data is accurate because it lines up with when we see both Cabo Verde and the Canary Islands. So when Matthew claims that none of the stars in the field of view should be showing an increasing zenith distance over time, he's simply wrong. The globe accurately predicts an increasing zenith distance for MCTA throughout the course of the time-lapse, and this is in fact the star that he and Taboo Conspiracy are pointing out in the video. So let me finish by offering a couple predictions of my own in terms of where I see all this going, because this is now the second time that I've addressed this kind of claim. And in both cases, the globe accurately predicts exactly what we see in these time lapses. I may have tipped my hand a little bit by asking Matthew very specific questions about the precise date and time of the flight, as well as the exposure length used throughout the time lapse. He previously claimed my only play was to claim the video was fake, but he can now see that's definitely not what I was going for. But he now understands that the reason I was asking those questions was to perform this kind of in-depth analysis, and that I need that information in order to accurately compare what we see in the time-lapse to what the globe predicts. I was lucky, in this case, that we had a few markers that we were able to use in order to perform the investigation. We had the plane flying over Cabo Verde and the Canary Islands, and importantly, we had the ISS labeled and visible in the video. The visible islands in the video allowed me to determine an approximate position from which ISS was seen, and ISS itself gave us a definitive marker for exactly when this flight occurred and the exposure length used throughout the time-lapse. Given that Taboo Conspiracy completely mischaracterized my previous analysis of the previous time-lapse that we took a look at, I don't expect him to learn anything from this video, and I certainly don't expect him to accurately describe what I just did. What I do expect is that at some point they'll make the same kind of claim again, only next time they'll try to make sure that they pick a time-lapse that doesn't feature the International Space Station or some other prominent, well-known satellite that I can use to try to locate exactly when the flight occurred. They'll try to find some time-lapse that doesn't have that kind of detailed information associated with it so that they can make the claim without worrying about me being able to do this kind of in-depth analysis. They've already provided 2 time-lapses that I've been able to analyze and show that these planes really are flying over the curvature of the Earth. But if they want to provide a third one, I'll be happy to oblige. The longest part is simply running the astrometry on several thousand video frames. But in terms of doing this analysis, the software is ready to go whenever they are. I don't expect to change their minds or for them to even be honest about the analysis I've done. That's not my objective here. Honestly, I had fun just doing the detective work to figure out exactly when this time-lapse occurred, and I was fortunate that ISS made such a prominent appearance that made that possible. This also gave me the opportunity to improve the annotation software. Instead of simply annotating my own homebrew planetarium program and reprojecting the results, I was able to directly annotate the time-lapse video in this case instead. And I feel like that worked really well this time, because not only did it give us all the information we needed, it also showed that the video really was panned a bit to the left, which had influence on the results as well. A link to the source code is available in the video description. Thanks for watching, and clear skies.
Hello and welcome back to Baldy Cats. Now, in today's episode, I'm going to do something a little bit different. I'm genuinely going to try and help somebody, and the person I'm going to try and help is a flat earther. Now, this flat earther is a rude and arrogant flat earther for sure. A walking, talking example of Dunning-Kruger, absolutely. However, they do genuinely need help. So I'm not going to ridicule them in this video. What I'm going to do is really try and point them in the right direction and get the gears turning. Now, this did start last week, and I've linked my first video that started all this off, I suppose, in the description. However, if you don't want to watch that, here's a little catch-up.
So this guy here goes by the YouTube name of That Guy, and that guy sent me a series of abusive messages just like this one, in which he told me he had an experiment which I was too scared to look at because it totally debunks gravity.
Testing the theory that gravity is what's holding the air and water and everything to Earth.
So when I checked out his video, he decided he was going to take a plastic bottle and create a vacuum with it.
But when you create a vacuum, and I put my finger over here, that's a vacuum inside there.
I know, that wasn't a vacuum. Anyway, he took his bottle and he put it upside down in a jar full of water. And as the bottle expanded, water naturally entered into the bottle, leading him to the conclusion that vacuums suck, and therefore the vacuum space should rip the atmosphere right off the Earth, meaning that space is fake. I responded by showing him this very simple child's experiment, which shows that you cannot suck water from a sealed container because simply the reason the water went into the bottle or up the straw is because of the weight of the Earth due to gravity pushing down on the water, not because vacuums suck. And here was his response.
Intellectually dishonest. Either he's that stupid or he's straight lying and being dishonest.
And unsurprisingly, the insults kept coming.
You're a moron, Baldy Cats. Idiot.
Thanks for noticing.
You actually have to think about the shit that you say.
Yeah, funny you should say that, and you'll see the irony of that comment pretty soon, I think. Now, that guy, as he's known, did make a response video to me, but I'm not going to take his response video and address all the points, because even for me, it is ridiculously low-hanging fruit. For example, one of the comments he posted and one of the points he made in that video was this comment here, where he literally says that the number 0 is nowhere near the number 0.0000001. Now all I can say to that is, if you come around to my house and you build a fence for me, I will pay you no dollars and you won't be very happy. But then if you come around the next week and you paint the fence for me, I will pay you $0.0000001 and you'll feel like you've had a massive pay rise because those numbers are nowhere near each other. Brilliant. What else did he say? Yeah, he said this.
Learn what vacuums are. You cannot have a gradient from high pressure to low pressure. Only high to a lower high. Do you understand?
Now, his whole video was full of little gems like that, so you probably understand now that I use the term low-hanging fruit. And I'm not going to take the easy route and take his video and ridicule it. I've put it in the description so you can watch it and you can see for yourself really the mistakes that he's made. But what I'm going to do for you, that guy, well, let's take a look.
Yes, I have made for you a Flat Earth defense kit, and after watching this, I don't expect you to immediately jump to the globe, because I know that's not how it works, but what I do expect is, if you've watched and you've listened, over the next few weeks you'll have so many nagging little doubts that you'll want to know more, and you may actually start learning and doing proper research rather than just watching Flat Earth debate shows and picking up your nonsense from there. I think in the long run, this is going to be a good cure for you. Let's get started.
So what I've tried to do in putting this kit together for you is not pick out the obvious things that you'll have heard over and over again. Some of these arguments, some of us may be familiar with. I'm hoping that one or two are new to some people. But let's start with the idea that density is responsible for things falling and not gravity. And let's use the common pendulum.
Now, pendulums swing back and forth and they gain height and they lose height. But the interesting thing about a pendulum is we can predict exactly how long the time period for one full swing will be. Now, according to you, density is the only reason that things fall. In that case, when we're predicting the time period of a pendulum, you would imagine that somewhere in that equation we would find density, which is mass divided by volume. But when we actually look, we find that there's actually no mention of density, mass, or volume in that equation whatsoever, even though the equation works 100% of the time absolutely perfectly. What we do find, however, is the time period of a pendulum is dependent on the length of the string and little g, which is acceleration due to gravity, which, by the way, can be calculated using the gravitational constant, the mass of the Earth, divided by the radius of the Earth squared.
So according to your model, density and not gravity is the reason things fall. It's the reason that a pendulum, when it gets to the top of its swing, is going to start coming back down to the bottom of its swing. So isn't it incredible that there is literally no equation out there that incorporates the density of a pendulum to the time period of its swing? But there are equations that accurately predict that time period using gravity. Just let that sink in for you, and let's move on.
Now, something else we can do that's perfectly predictable and perfectly reproducible and perfectly accurate is to predict the speed something will be travelling at just before it hits the ground if you drop it from a known height. Now, in your model, things fall because of density. But when we have a look at the equation we use to perfectly predict the speed something's going to be travelling at the floor, there's no mention of density, there's no mention of mass, there's no mention of volume. In fact, v squared equals u squared plus 2as contains that little a in it, which is acceleration due to gravity, little g.
So yet again, isn't it incredibly frustrating to you that when we're talking about the physics of things falling, if we want to perfectly predict and accurately predict how fast something's going to be travelling when it hits the ground, we don't use density. Density is completely irrelevant in those calculations, but what is relevant is acceleration due to gravity. You would think that if density was the reason things fell, that somehow we would be able to use it to predict how something was going to fall. But we don't. That should bother you. It should bother you massively.
Now, a brilliant little experiment that allowed us to calculate the exact charge on an electron was Millikan's oil drop experiment, where Millikan took drops of oil and calculated the gravitational force pulling down each of those drops of oil. And then he looked at the electrical force needed to suspend that drop of oil in the middle of the container, and from that he was able to work out the exact charge of an electron. What you'll notice is that because the oil type he used was the same for every single droplet, the density of the oil was not different.
Now that really is a fantastic little experiment, and I do urge you to look at it. But essentially, Millikan used the force of gravity pulling an oil droplet down. And remember, all those oil droplets had an identical density. They were the same oil. So he used the force of gravity pulling it down due to its mass to calculate, essentially, the charge on an electron. Now, you can say that that was a flawed experiment, as long as you're prepared to admit that you don't believe in silly, stupid little things like capacitors or transistors or rechargeable batteries or electric circuits. Other than that, it should quite bother you that density was, again, completely irrelevant, and the force of gravity has been able to produce something that's been so useful for us and all of mankind.
Now, before I go any further, I want to credit this man for what I am about to say. This is Team Skeptic, and he mentioned this to me when I was on a live stream with him a couple of weeks ago. I've linked his channel in the description. It's well worth checking out if you're not aware of him already. Please give him a subscription. So, Team Skeptic suggested that if density was the reason that things fell, then we should simply take some weighing scales and choose a very, very big object, a heavy object, that isn't very dense. Like this aircraft carrier you're about to see. That aircraft carrier is floating on the water, which means it must be less dense than water. We are then going to take an object that is more dense than water, like a bowling ball, and we're going to place that on the other side of the weighing scale. Now, if objects only fall because of density and things trying to find their equilibrium, then that bowling ball should be lower on that weighing scales than the aircraft carrier. But for some reason, it's not. It's almost as if the fact that the bowling ball is more dense than the aircraft carrier literally has no effect whatsoever. And there's another force at play.
So the bowling ball is clearly more dense than water because it sinks. The aircraft carrier is clearly less dense than water because it floats. So why, when I put them on the scales, if density is the reason things fall, why doesn't the bowling ball find its equilibrium, as you like to say, at a lower position than the aircraft carrier? It's almost as if density, as a model for things falling, has literally no predictive capabilities whatsoever. But we've already seen the predictive capabilities when we use the gravitational model. This should really start to be bothering you. Let's move on.
Now, observations of Polaris are something we can all do ourselves, and they are a 100% flat Earth killer. Anybody that understands anything about trigonometry, anybody that understands anything about high school maths, knows that the observations of Polaris absolutely stone dead kill any idea of a flat Earth. And why is that? Well, take a look at these two pictures here. When we make our observations of Polaris on Earth, we find that for every 111.3 kilometers we move, either north or south, Polaris will change its angle in the sky by 1 degree. Now, this allows us, using the heliocentric model, to make perfect and precise predictions. So I know when I go on holiday to the south coast in a few weeks, I know exactly the angle that Polaris will be in the sky because I know exactly how far south I've gone. However, using the flat Earth model, as we can see from the diagrams above, as I drove down to the south coast, Polaris would have to physically change its position in the sky just so I could see it at that 1 degree difference. Now, clearly, that's totally ridiculous, showing that the flat Earth model has zero predictive capabilities, yet again, when we're talking about observations of the stars. Now, because I know this is going to be brought up in the comment section, if you have a look at the numbers I've used on the graph, what I've concentrated on there is just having a 111.3 kilometer difference between the top diagram and the bottom diagram, and a 1 degree difference between the top diagram and the bottom diagram. I am not stating that Polaris is only 60 odd kilometers above the Earth. You can really start with any numbers. As long as those numbers are 111.3 kilometers apart, you'll find that the distance Polaris will be different on both diagrams.
So yet again, the heliocentric model is allowing us to make perfect, reproducible predictions about our observations of the stars. Now, at this point, it's not even a presupposition. You can't say we're just assuming that the Earth is a globe, because we can apply this maths to any shape. We can say, well, would this work if the Earth was a square or a triangle or a flat disk? And what we'll find is only one shape, only one, explains and predicts our observations of Polaris. And that's the one we're left with, which is a sphere. And that's not the only observation of stars that you can do yourself.
Another well-known feature of the heliocentric model that you can try yourself is the ability to predict accurately which stars in the sky will and won't be circumpolar from any given point on the Earth. Circumpolar means that it will not dip below the horizon. Now, to calculate if a star is circumpolar, we simply ask, is the declination of that star greater than 90 minus the latitude of the observer? And if the answer is yes, that star will be circumpolar. This means I can accurately predict which stars I will and will not be able to see being circumpolar when I go on holiday. And I'll be correct.
And once again, once you've made those predictions yourself and you've done the observations yourself, you can then apply that mass to a whole range of geometric shapes. Will it work on a square planet, a flat planet, and so on? And what you'll find is the only planet this works on is a spherical planet. It really is that simple. Let's finish.
And just to finish up, let's show some pictures of mountains casting shadows on the clouds above them. Something that's only possible if the sun is below the height of the mountain. Something that will be totally impossible on a flat Earth, however, perfectly predictable and observable on a globe Earth.
Now, that guy, I hope this video has helped you, and going forward, I hope these questions mull over in their mind and you realise that using density instead of gravity has literally no predictive capabilities whatsoever, and it only has flaws in the argument. And I could have made this video 2 hours long. I haven't even talked about why objects actually fall towards the Earth when the path of least resistance is above the Earth, because we know, if we take a look at this picture here, as demonstrated by this simple crisp packet, as we go up in altitude, the air pressure and the air density actually gets less. So if objects really do fall because of differences in density, then why can't that model explain why they fall downwards instead of upwards, where the density difference is much bigger? It literally makes no sense. I'm not really interested in your response, and I'm not really interested in getting into a head-to-head with you, because I don't want to ridicule people that say stuff like this anymore.
Learn what vacuums are. You cannot have a gradient from high pressure to low pressure. Only high to a lower high. Do you understand?
You see, a very wise man told me lately to go after the con men and not the conned. And that guy, unfortunately, you really are one of the conned. I can hear you regurgitating all the same stuff that comes out of the flat earthers all over YouTube, the flat earth debate team, the Globebusters team, and you regurgitate it with an obvious lack of any understanding of what the heliocentric model actually says. And if you understood it, you'd realise there were no contradictions and there was no problems. But you've been conned by these people on YouTube who are making a pretty penny out of it. So let me help you and let conspiracy cats go after the idiots.
Hey guys, and welcome to today's video. Today we are going to be covering a video I came across by YouTube user Owen Benjamin's Bear Cave, titled Circumnavigation Supports Flat Earth. In this video, Flat Earther, deep inside the rabbit hole, or dearth, is having a live conversation with a true human asshat named Owen Benjamin. Now, Owen Benjamin is a self-proclaimed truther who, like the rest of all Flat Earth idiots, is not interested in the truth at all. He admittedly hates Chinese and Jewish people, thinks everything is a conspiracy to hide the truth, and he can definitely prove that we didn't go to the moon. But the only thing Owen Benjamin is going to prove in this video is that he is a total fucking idiot. Now I want to say thank you to all my patrons and channel members whose support helps me make videos like these. So let's begin.
All right, so when you go east and west are circles around the magnetic pole, whether it's the axis of a ball or the center of the flat earth. It's the magnetic center. You hold your compass out and the compass will point towards the north, right? So if the north is that way and I want to go west, I'm going to go west. But as I go, I have to stay equidistant from that North Pole magnet. So west on a ball earth or a flat earth is a circle.
Right. No,
and east is a circle.
I see that
South
completely. That one never got me. The whole I go around the earth. It's like that makes total sense on dome earth or just not sphere earth to me. That one never got me.
Dearth, do you not realize that on a flat earth, due east and due west are two-dimensional curved lines, whereas in reality, due east and due west are straight lines that curve along a third axis, allowing them to remain straight with no deviation along the x and y axis and still curve back on itself so that you finish at the same point that you started. This well-known fact also explains the equatorial traversal of the sun appearing to be a straight line on the surface of the earth during the equinoxes, whereas on a flat earth map, the sun never travels in a straight line. The flat earth model simply cannot account for these empirical and historical observations, therefore it does not fit reality. As far as the compasses go, flat earthers would have to try to explain how and why a northern magnetic pole exists without a southern magnetic pole. To this day, we have never observed a natural magnetic monopole, and only an idiot would assert that the Earth is the one special condition.
Well, it only makes sense because billions of people have circumnavigated the Earth east or west. Nobody's done it south.
No one ever does it north-south. And why does no one talk about that?
Both of you guys are such fucking idiots. In 1982, the Guinness Book of World Records added Ranulph Fiennes and Charles Burton to the record books as the first people to make a surface circumnavigation of Earth crossing both poles. It took them 2 years, 361 days, but eventually they crossed both the North and South poles and returned to their starting point in Greenwich, England.
Here's where you get confused. So, see, there's a circle map behind me, but if you go north, which is towards the center, you can go over the north and go to the other side of the world.
Right.
So you go north, and then as soon as you pass the center, you're now going south. But if you keep going in any direction, it becomes south. If you point your compass west, then put your compass down and head in a straight line, you're heading south.
Dirth, you're dumb as dog shit, dude. Due west does not head south at any time and remains perpendicular to due north and south without any deviation along the x or y axis. Let me demonstrate this. Imagine that you are driving in a car on the equator heading east, and you wanted to circumnavigate the Earth. If the Earth were flat, then your two-dimensional coordinate system would consist of both an x and a y axis. We will call the y axis your left-right axis, and the x-axis as your front-back axis. On a flat Earth model, anytime you orient yourself so that your y-axis is pointed directly at the North Pole, you are by definition pointing due east. If you begin driving straight, you will immediately notice that the y-axis will begin falling out of alignment with the North Pole, meaning you are no longer perpendicular, and you are now heading in a southern direction. This is not what we see in reality. But on a globe, we are now working with a third dimension, the z-axis, which allows your car to orient itself in another dimension without violating its need to be perpendicular to the north and south. This is what matches our reality, as due east and due west are straight lines with no deviation on the x and y axis, only deviation on the z-axis. This is by far one of the easiest proofs to understand that shows that the Earth cannot be flat. But flat earthers don't get it, because flat earthers are idiots.
Oh yeah, I cut you off about the baskets. Finish your basket thought. I did a Jew joke. Finish the basket, my bad.
The basket is, whatever we talk about, it could either go into that works on a flat Earth, only on a flat Earth, or that works only on a ball Earth, or hey, that works on both. Circumnavigation east and west works on both.
It does.
Circumnavigation south only works on a flat Earth.
Dirth, you're an idiot. Any attempt to circumnavigate the flat Earth north to south would end up running into your imaginary flat Earth dome, or would just continue on forever. I've recently seen some flat earthers that suggest that there may be a portal on one side of the flat Earth that immediately transfers you to the other side of the flat Earth, suggesting more of a Pac-Man Earth. I mean, who knows? I've personally seen a movie where a child was swept up by a tornado and dropped off in Oz, so I guess anything's possible on a flat Earth.
And my expertise is not in some of these technical fields. Like, some pilots I know think the Earth is flat. One pilot wrote to me to ask you about direct communication, why sometimes if you go too low, they have a hard time communicating because of the perceived curve of the Earth versus higher. Do you have an answer for that?
Yeah, so that gets into perspective and angles of attack. You know, when you're looking or sending a radio wave, the farther out it goes, the angle of attack gets less and less and less and less. Like,
while Owen Benjamin might be an expert in being a racist and a total fucking idiot, I happen to have been a radar tech in the Navy in my younger days, and this angle of attack bullshit was never mentioned in my education. This is because angle of attack is a completely made up phrase by Jism and Nathan Oakley to try to confuse people just enough to believe they're bullshit. An omnidirectional radar wave diverges from its point of origin, meaning height really doesn't matter. Unless you are flying right next to the ground, you should always be in line of sight of the radar, and has nothing to do with perspective or angle of attack. The only way that height would make a difference in the ability to see the radar waves is if the lower elevation is inside of what we call a radar shadow that's created by an obstruction, and the higher elevation is outside of the radar shadow. This obstruction that keeps the lower elevation planes from seeing the radar is the Earth.
If you, let's just say you in a long hallway, you're in one of those long hotels in Vegas, and you laying down on the floor, you have a camera down on the floor, and somebody's walking down the hallway, their feet are going to disappear before they get to the end of that hallway because of the angle of attack. And it's the same thing with radio waves too.
No, Dirth. If you put a camera right next to the floor and a person starts walking down a long hallway, the minor imperfections in the floor can cover more and more of the person walking away from the camera, due to perspective. This explains the floor observation, but it does not explain radar shadows, because radars on ships at sea don't have to worry about obstructions on the ground for planes that are miles in the air. The only obstruction that keeps a plane from being hit by the radar waves is the curve of the Earth.
So as they're going, so people say, when the sun sets and I went up higher and I saw the sun again, I saw it set again, that proves the ball Earth. No, it doesn't. It just proves that you've raised your angle and you now have a better perspective and you've increased the viewing angle of whatever it is you're looking at.
Right. Wrong again, idiot. If the sun was 3,000 miles in elevation and the sub-solar point was several thousand miles away from you on the ground, then going up in elevation by a few hundred feet wouldn't actually change your viewing angle by very much, due to perspective. However, on a globe Earth with a radius of about 4,000 miles, your visible horizon would extend by several miles by raising up slightly in elevation. For example, an observer at 6 feet of elevation will have a visible horizon of about 3 miles in all directions. By increasing the viewer height by only 500 feet, we increase the distance to the visible horizon by about 24.5 miles. This is why increasing in elevation allows a person with a drone or in a tall building to see 2 sunsets or sunrises in one day.
But this gets a little complicated, and I'll just give you the brief explanation. Looking at something from a terrestrial point of view, looking at something else that is on the ground, a terrestrial object, that's going to shrink, and when its size gets too small for your eye to resolve, the angular resolution limits of your eye make it disappear. But if a terrestrial viewer looking at a celestial object like the sun or the moon, as it goes away, it's going to drop down and it's going to get eclipsed by the atmospheric layer in between.
So what you are saying is that there are special rules that apply to objects in the sky versus objects on the ground. No, you idiot. That's not how science works. Either the same rules apply to everything, or the rules you are applying are irrelevant. And as I stated already, a sun that is several thousand miles away and several thousand miles in the sky would not have that great of a viewing angle change when going up in elevation just a couple hundred feet.
If you're looking down, I could look down Long Island Sound here, and about 25 miles away, the clouds look like they're touching the horizon because everything is compressed. Well, the sun is above that, and as the sun goes away, it's going to get eclipsed behind that cloud deck, which looks like the horizon, but it's not.
Again, you are completely wrong. If the sun was several thousand miles in elevation, it would never touch the horizon. it would simply make a huge circle over our heads, going from largest at solar noon to smallest at solar midnight. Now, I can't understand how flat earthers can use perspective as a staple of their belief system and not accept this prediction that perspective makes. Maybe because flat earthers are willfully ignorant morons, or maybe because they're intellectually dishonest idiots.
If you want to learn about how perspective works, there's a video that was just put out on the Jeranism channel. Someone tell me the name, but it's about perspective. It's a couple days old, and it's a long video. It's like 2 hours, but it will explain how things disappear due to perspective and how there's the vanishing point and how things disappear from the bottom up.
I completely disagree. If you want to learn about perspective, visit an educational art website or a physics website covering optics. That will give you the true definition of perspective and the mathematical equation that accompanies it. Visit Jism's channel if you want to learn how to be a dishonest con man and take thousands of dollars from mentally inferior flat earth idiots.
There's a podcast called Dome Life by Paul on the Plane, and he does a lot of NASA stuff, but he had a pilot on that was talking where he knew the earth was flat, and he told a story about how I'm probably screwing this up a little bit, but how he talked to other pilots and they're like, really, what do you mean? And he's trying to convince them. So they, on multiple transatlantic trips, they brought globes on, they're tracking themselves, and it took the pilots about a year to go, okay, it's not a globe, it's flat.
I'm not sure if this is the same anecdotal interview from Paul on the Plains channel or not, but Wolfie6020, a great YouTuber and an actual intercontinental airline pilot, debunked that fake pilot's claims without a doubt. It seems as if lately, gullible flat earth idiots are just buying any story that comes out that supports their narrative without fact-checking the sources first.
Ahoy hoy, Jism. What do you think about people like yourself believing that document that says that Globe Earth YouTubers get paid by NASA?
Pretty sad if you ask me.
I agree. I think there's something we can all learn from it.
Their stupid hoax?
You sound a bit salty there, Jism. Anyway, if you want to know what I'm on about, click the link above my head, or maybe it's over there. I don't know what Team Skeptic's doing.
I mean, everything about an airplane is flying over the Earth plane. You know, if you look at flight routes from Santiago, Chile, it goes all the way up to the United States, across the United States, and then back down to the south rather than cutting across. But watch that on a flat map. Every line is a straight line.
Wow. Now that was a whole bunch of useless information. A plane starts in Santiago, Chile, goes up to the United States, then back down south? How about giving us a starting point and ending point so that we can compare it to a great circle and see if it matches our model? Now, for those of you who don't know what a great circle is, it's any line that connects 2 points on a sphere in the shortest distance possible. It also happens to go all the way around the sphere and meet back up at its starting point. Examples of great circles in reality are the equator and lines of longitude. However, the equator is the only line of latitude that's also a great circle. All other lines of latitude are not great circles. Let me give you an example. Let's take 2 points that are not on the equator but share a common latitude. Now, one might think that the shortest distance between these 2 points would be the line of latitude that they are on. However, this is not the case. Let's assign the 2 points to the coordinates of 45 degrees north, 90 degrees east, and 45 degrees north, 90 degrees west. This puts the 2 points on opposite sides of the globe. Now, by doing some calculations, we can compare the two distances between the 2 points along the line of latitude and the 2 points along the line of their great circle. Given a radius of 4,000 miles, a line of latitude at 45 degrees north will make a circle on the Earth that is parallel to the equator that has a radius of 2,828.43 miles, giving it a circumference of 17,771.53 miles. We already said that the 2 points are on exact opposite sides of the Earth, so we can divide the circumference by 2 to get a distance along the 45th parallel of 8,885.77 miles. If we take that measurement along the Great Circle with a radius of 4,000 miles, we will see that the circumference of the Earth is 25,132.74 miles, which is larger than the other circumference. However, we will only need to use 90 degrees or 1/4 of the circumference, and that comes out to 6,283.19 miles, which is about 2,600 miles shorter. So it is actually a shorter distance to follow the Great Circle and not the lines of latitude, which makes perfect sense on a globe Earth.
In the flight manual from NASA and federal area FAA, it says to treat the Earth as a flat, non-rotating plane.
Right.
Okay? In their calculation, flat, non-rotating plane. What does that tell you?
Well, for starters, that tells you that they are all in the same frame of reference. If the Earth was erratically changing speeds or directions, then that would present a problem for pilots. But since the Earth is rotating with a constant velocity and conservation of momentum is a thing, you can treat the Earth as non-rotating and flat, just as you can treat the inside of your car as not moving when traveling at a constant velocity. And the phrase treating something as if it were flat is not the same as saying it is flat. Dirth, you're an idiot.
Dude, just the spinning of the Earth when you're going east to west or west to east, if it's going 1,000 miles an hour and you're in a 300 mile per hour plane and you're in part of the atmosphere that apparently is so thin it doesn't get sucked out of an infinite vacuum, how the fuck does that not affect your flight map?
Owen Benjamin, you're an idiot. There is no such thing as an infinite vacuum, and the vacuum of space doesn't suck like a Hoover does. And plane flights that are about 6 miles up don't have to worry about getting sucked into the vacuum of space, since the Kármán line doesn't even start until about 62 miles up.
And people are
How
like,
about
the
this?
Coriolis effect with snipers. I'm like, I know snipers that have killed 50 fucking people, and they'll tell you straight up there's no Coriolis effect with the bullet. That's bullshit.
You know, if they shoot and it's a little left, they just aim a little to the right. It has nothing to do with Coriolis.
No,
They're a little
it's about
left,
their scope.
move to the right.
It's about how many yards it's bullshit.
Well, you heard it here first, guys. In the heat of battle, when hitting the target the first time counts the most, instead of taking the Coriolis into account, they just tell the snipers to miss the first shot and adjust accordingly. You can tell that neither one of these two idiots have ever been in the military. The Coriolis effect is something that is very subtle and therefore can only really be observed over large distances. The average sniper is simply not shooting at targets that are kilometers away, and therefore the Coriolis effect is minimal.
So just think about this. You know, the baller explanation for airplanes, an airplane sitting on a runway at the equator is traveling 1,000 miles per hour before it even starts moving. So whether it's going east or west, it takes that momentum and flies, and it has its 500 miles an hour land speed. So it's either going 1,500 miles an hour or negative 500 miles an hour, but its land speed is 500 miles an hour. What about an airplane that takes off from northern Alaska, where its land speed is only like 200 miles an hour because it's so close to the center of rotation, flies to the equator? How does it make up that 700-800 miles per hour?
Oh, I don't know, Dirth. Maybe with these, or I don't know, these, or these, and these, and oh yeah, these. Dirth, you're a fucking idiot.
And I made an app that shows you where you are on the Earth.
I love how Owen Benjamin is completely not paying any more attention to Dirth. And when Dirth realizes this, he thinks to himself, hopefully this idiot likes lights. And this is his reaction.
So I don't know if you can see this.
Oh, that's hysterical, dude.
No, Owen. You and every other Flat Earth idiot are hysterical. And as far as that app goes, download it if you want, but don't try to use it for anything purposeful like navigation. Remember what Durst said earlier. On his map, when you're going east, you're actually going south. That Flat Earth Clock app is just another way for the leaders of the Flat Earth cult to suck the money out of the pockets of mentally incapable Flat Earth idiots.
I'm gonna get that because I find that fucking interesting. Because that's one thing I want is a better idea of the map. But how about the fact it's the UN's map? Right in plain sight. That's the United Nations map.
I don't know if you know this or not, but the UN map is simply a two-dimensional projection of the three-dimensional Earth, which ironically also happens to be the Flat Earth map as well. Those idiots have still failed to explain why Australia on their map is so much larger and distorted than it is in real life.
It shows you seasons also. It shows you how seasons work. Because if you look, the sun travels in and out between the tropics. And when it's on the inside, it's our summer. When it's on the outside, it's our winter and the southern summer. And it makes perfect sense. And just remember that wherever the sun is, it's noon. So right now it's noon in Australia, so on the west side of Australia.
Oh my god, Owen Benjamin's face is killing me right now. Once Dearth started trying to explain seasons with his bullshit, Owen lost all interest and started thinking about porn again. Even Owen Benjamin knows Dearth is an idiot.
That's fascinating.
It's pretty cool. It's got a bunch of features on it. It shows you your weather for the day. I'm always expanding it, making it more. It's fun. And the other thing is, every day I put a new video on it, but then it has the video archive. So if you're researching Flat Earth, you hit the video archive, you got a huge playlist of the best Flat Earth videos, whether it's mine, Jeranisms, it doesn't matter. There's all different stuff on there. And, if you watch one good video a day, in 2 weeks, you'll be a Flat Earther.
I beg to differ, Dearth. I personally comb through hundreds, if not thousands, of Flat Earth videos a week looking for prime stupidity like this video, and I'm still not a Flat Earther. I think because you have to meet certain requirements before becoming a Flat Earther. First, you must be scientifically and mathematically illiterate. Second, you must deny observational reality. And third, you must be a total fucking idiot. Now, I'd like to take the time out to thank Owen Benjamin for allowing Dearth to come onto his show and showcase precisely how stupid they both are. Because Owen Benjamin, you, and Dearth are both fucking idiots. So it's that time again. Another video started, another video ended. I'm truly honored to have reached 10,000 subscribers in just over a year on YouTube, and I'm truly humbled by the support the community has given me. Each and every one of you guys are absolutely amazing, and I couldn't ask for a better group of subs. I'm Father Skeptic, and I'm out.
I told Killian I'd be back. I wouldn't want to be a liar.
Greetings, dear viewer. So this is the first part of a new series that will pick through the manure pile of flat earthers.
Vince, apparently they prefer the word retard.
Hey? Oh, how very kind. Flatards think there is a global conspiracy to hide the shape of the Earth, a conspiracy that dates back to antiquity, yet is all due to NASA and the United Nations, organisations formed in 1958 and 1945 respectively. What these mental defectives have yet to do is explain why the shape of the Earth is so significant that such a concerted effort to hide its shape would be necessary, let alone why treating the Earth as a spheroid allows the rest of humanity to be far, far, far more productive than they are. The best they can come up with is hand-waving about trying to undermine faith in their magic sky wizard, who allegedly built a flat Earth inside a giant snow globe just so that his creations could scuttle around talking to the ceiling and praising his capriciousness. Basically, their argument boils down to, "But my holy book!" They can't even agree on whether their flat Earth has an edge. Some of them think it does to suit their view of living in a giant snow globe. Others think it just goes on forever. This alone gives us a valuable insight into the fast pace of flat-earth research, because all they had to do at some point was travel a few thousand kilometres and find out. It's not like the last few thousand years they think they've been around have lacked the technologies to enable them to do that. They've had access to the same tools for measuring distances, directions and positions as the rest of us, and yet their achievements are nil. Despite this, these vacant-minded gobshites think they can make pronouncements about reality without having explored it. So, now that we have set the scene of who we're dealing with, let's get cracking. Flatards think Earth looks like this, because they saw it on a flag. This, and this, are examples of an azimuthal equidistant projection, one of many ways of projecting a three-dimensional spheroidal surface onto a two-dimensional one. If you've ever tried flattening out an orange peel into a nice map of its former self, you'll have noticed the problem. Presenting a rounded 3D surface in 2D means that something has to give. In the case of an azimuthal equidistant projection, what stays intact? Lines of longitude radiate from the centre of this polar projection, so directions from the centre point will be represented correctly. In fact, the centre point is the only point on this projection where one can determine the direction and distance to any other point correctly. For other points, only distances along lines of longitude will be consistent with reality. Distances and directions between any other 2 points will be incorrect. Consequently, shapes and areas are also incorrect, and become increasingly distorted the further from the centre of the map they are. We'll come back to that. The azimuthal equidistant projection does have some practical applications, but for general navigation, the problems highlighted mean it's an absolute clusterfuck. Consequently, Flatards parading this as their go-to map of the world gives some indication of just how little thought they've put into things, as well as revealing that they've never tried to use it. Due to their avoidance of doing anything more difficult than navel-gazing, Flatards preemptively claim that anything that looks a bit tricky can't be done. For instance, they can't even find out how big their disk world is because the UN would stop them. Of course! It is claimed that they patrol the southern seas and stop anyone going too far and finding the edge of the world. What these oxygen-deprived mouth breathers have failed to consider are the logistical requirements of such an operation. So let's do the thinking for them. Let's get a ballpark figure on how many patrol boats they would need. The straight line distance from the North Pole to the tip of South America is about 16,200 kilometers. Since flatards claim that distances on land are the same on their magic disc world as they are in reality, it's going to be 16,200 kilometers for them too. Let's have our patrols passing roughly halfway between Tierra del Fuego and the Krakow Peninsula, say 16,500 kilometers from the North Pole. This gives a circumference of roughly 103,700 kilometers of ocean to patrol continuously. Place a boat, say, every 10 kilometers, so no flatard can sneak past under the horizon, and the UN needs around 10,000 patrol boats just to stop flatard explorers discovering the truth. Ignoring the high probability that no flatard has explored further than the edge of their trailer park, I for one look forward to them providing proof of the largest boat fleet in the world, comprised of craft capable of handling the worst of the Southern Ocean. I also look forward to them finding out where they were built, who by, how much for, identifying shipyards capable of churning out 10,000 such vessels, and finding out where all the boat builders and crew actually are, given that nobody has noticed any of this stuff going on. Then of course they can explain why no flatard undertook such an expedition before the UN created this alleged fleet to stop them. There is of course one key reason why nobody will ever find the missing boats and their missing crew, and that's because it's just another pathetic ad hoc excuse concocted by flat earthers to try and account for their bone idleness. That and the idea that the earth is flat is bollocks. Noting that flatards claim that distances on land are the same on their fantasy world, they've failed to consider a simple and fundamental problem. Whilst you could just stick a landmass onto a polar grid without changing distances between its locations, you can't do so without changing their coordinates. The best you can hope for is to get one line of points matched up, but then the coordinates of everywhere else are wrong. It's inescapable. Consider, for instance, Australia. 30 degrees south of the equator on the eastern coast is the small town of Red Rock. Let's take this point here, 30 degrees south and 153 degrees 13 minutes east. At the same latitude on the west coast, just 6 kilometers south of the town of Lehman, let's take this point at 30 degrees south, 115 degrees east. The difference in longitude is 38 degrees and 13 minutes. If we were to set off from our point near Red Rock and drive west until you got to our point near Lehman, you would cover a distance over land between these 2 points of 3,687 kilometers. So what happens if we travel along the same 30 degrees south latitude line for 38 degrees and 13 minutes on the polar grid of the flat Earth? The 30 degrees south line is 13,322 kilometers from the geographic North Pole and must be on the flat Earth too, for reasons we saw earlier. We know the longitudinal and hence angular separation between our 2 points at this latitude, 38 degrees and 13 minutes, or 38.217 degrees. The length of an arc on a circle subtended by an angle alpha is alpha pi r over 180. When we crunch the numbers, we find that 2 points on the flat Earth's surface, 30 degrees south of the equator, and separated by 38 degrees and 13 minutes, are 8,886 kilometers apart. This is 2.41 times greater than the real distance between our points near Red Rock and Lehman. But flatards say that distances on land are the same on their giant space pizza as in real life, in this case 3,687 kilometers. In that case, they must agree that the separation in longitude on the flat Earth must be considerably smaller than it is in real life. It's an inescapable feature of the geometry. If we make L 2.41 times smaller, we must make the angle alpha 2.41 times smaller, which means that on the flat Earth, the difference in longitude between our points near Red Rock and Lehman would be just 15.85 degrees. Reality, however, begs to differ. And that's a paradox that flatards can't resolve. These points are 3,687 kilometers apart, and their longitudes are separated by 38 degrees and 13 minutes. It is simply impossible for flatards to keep distances the same without giving glaring discrepancies in their own coordinate system, and it is impossible to keep the coordinates of locations the same without giving glaring discrepancies in distances and, consequently, the shapes of land masses. Particularly paranoid flatards needn't rely on GPS to check this. They can use the old-fashioned methods of establishing longitude and latitude, and find themselves wondering why reality disagrees with their stupid beliefs. For the rest of us, the reason is simple. They're geometrically illiterate buffoons, and this is bollocks. The claim that distances on land are the same in the flatard disk world would also obviously mean that distances over sea couldn't be. As with problems on land, the further south you go, the greater the discrepancies would become if you travel over the ocean in anything other than a north-south direction. This also screws up simple travel. Qantas fly direct from Sydney to Johannesburg in South Africa 6 days a week. It's a direct distance of 11,060 kilometres, with the flight taking around 13 hours and 20 minutes at a speed of 830 kilometres an hour. As you might have expected, things on the flat Earth aren't quite so simple. Sydney Airport is 151.1772 degrees east. Johannesburg's OR Tambo Airport is 28.2461 degrees east. The difference in longitude is therefore 122.9311 degrees. Sydney Airport is 13,759 kilometres from the North Pole. OR Tambo Airport is 12,894 kilometres from the North Pole. Now that we have two sides of the triangle and the angle between them, we can use the law of cosines to calculate the straight line distance from Sydney to Johannesburg on the flat Earth. The distance d is equal to the root of a squared plus b squared minus 2ab cos c. When we crunch the numbers, we find that on the fantasy flat Earth, the distance is 23,419 kilometres. This is more than twice as far as it is in reality. For the Boeing 747-400s that Qantas use on this route, this poses something of a problem. With maximum payload, they have a maximum range of 13,438 kilometres, which means they would fall rather short of their intended destination, which somewhat defeats the purpose of a direct flight. Fear not though, the route taken by the Flatard Airways flight would pass over Papua New Guinea, China, the Himalayas, India, the Gulf of Oman, the Arabian Peninsula, the Gulf of Aden, the countries of East Africa, including a nice view of Lake Malawi, so could refuel along the way. There is, however, a lack of stopover options along the route. The Tibetan Plateau has a paucity of international airports. India's Indira Gandhi Airport is a bit too close to maximum range. Qantas don't fly there anyway. The next best option with a long enough runway might be Netaji Subhas Chandra Bose International. However, it's more than 1,000 kilometres off the most direct route on the flat Earth, and Qantas don't fly there either. So, if the Earth is flat, where do these flights go? Since no passengers who have flown direct between Sydney and Johannesburg have ever spotted China, the Himalayas, the Arabian Peninsula or Eastern Africa, let alone stopped at any of their bloody airports, we can be quite sure that this isn't the route taken. Also, as passengers on these flights do arrive in the scheduled 13.5 hours or so, Flatard Airways would have to fly at an average speed of 1,756 kilometres per hour, and faster with a refuelling stop, rather than the more sedate 830 we found earlier. The maximum speed for a 747-400 is 988 km per hour. So, unless Flatards can demonstrate that a 747-400 can fly at nearly double its rated maximum speed, and do so without critical components like wings and tailplanes simply being ripped off, and tell us where all the extra fuel is stored, and explain the slight discrepancy in scenery on the flight, we can safely say that the idea that the Earth is flat is bollocks. There is an even simpler problem which is a consequence of using a polar coordinate system: long-distance navigation. Travelling north or south are the only ways to travel in a straight line if you maintain a constant heading. If you maintain, say, a westerly compass heading on a flat Earth, you will follow a curved path. It would be inevitable. Clearly though, following a curved path on a constant compass heading is no good for commercial aviation, as it would waste prodigious amounts of fuel. The way to use the lowest amount of fuel and maximise your profit is obviously to travel as close to a straight line path as you can. Two problems would manifest themselves were flat Earths to try it. The first is one we've already seen. On the flat Earth, these straight line routes takes you over a completely different path and completely different sites. This ties in with our earlier point about maintaining coordinates of locations. The second is with the compass. If you take the straight line path between two distant points on a flat Earth, your compass bearing would drift over time even if you kept the aircraft in level flight. For instance, start flying west and keep the plane in straight flight, and on the flat Earth, your compass is going to drift south of that. Since flat Earths seem to think that with a round Earth you have to constantly point down to stop aircraft flying off into space, and conclude that Earth must be flat because they can't feel the plane flying down, they should, by the same pathetic reasoning, expect a plane flying west to be constantly banking to the right to maintain a westerly course. And remember, the further north the aircraft is, the more pronounced that bank is going to have to be, because the tighter the arc is going to be. And yet, not even flat Earths in North America and Canada have noticed this taking place and waved it around gleefully as proof of their codswallop. If flat Earths had passports and brains, they would have noticed that none of these effects happen, and never will, because this is bollocks. We're only just getting started, and we've already found some simple problems that are mathematically and geometrically irreconcilable between two differently shaped objects. We've seen that flat Earths can't even wrap their heads around the effects of their idiocy in 2 dimensions, so it's perhaps not surprising that their failures become even more laughable when dealing with 3. In the next part, we'll continue looking at how geometrically illiterate flat Earths are, as we turn our attention skyward and see what subtractions from the sum of human knowledge they've been able to offer there. See you then.
Dear me. Today, and I'm going to try and keep a straight face, I want to talk about flat earthers. Okay, so let me start this off by asking a question. Are flat earthers the stupidest people on the planet?
Every single story that is told by NASA has the subcontext that we live on a globe. The way they're faking things is with top of the line, absolutely cutting edge studio techniques like were used in the film Gravity.
The film Gravity is from 2013. The first moon landing was in 1969, which was when we as the human race observed from space, from a substantial distance, and you can clearly see that the Earth is actually round.
Well, that's a good comparison because the blockbuster movies bolster the NASA fakery. If you're watching Guardians of the Galaxy or Star Trek or Star Wars...
Hang on, is this guy actually trying to use science fiction movies to try and back up his theory that the Earth is flat?
So the fact that Hollywood perpetuates this meme, this lie, this spinning globe lie, heard every insult under the sun. And I think the reason we get these insults is because we are
the stupidest people on the planet. So if I had the opportunity to speak to this guy, the first question I would ask him is, can you actually prove that the Earth is flat?
No, I can't prove it. I can only support it with evidence.
What evidence? Okay, this is something to think about. You guys say that the Earth is flat. This is flat. So this surface is Earth. Do you accept that the sun is above us? Where does the sun go when it's dark? If the Earth is flat and it's always above us, where is the sun going? Is there some magic man with a light switch?
Ready and go! Good lad. Right.
Well, there we go. That explains that then. Somebody turns the sun off every night, and then the next morning they turn it back on. Why didn't I just think of that myself? What an idiot. Damn, that theory doesn't work either, because it's dark in Australia while it's light in the UK. So if it was a flat Earth, there'd be no time differences. It would be daytime everywhere and nighttime everywhere, all at the same time, so that theory doesn't work out either.
When it comes to science, there's things you can test right now, right? Fire burns, water's wet, drop something, falls to the ground, that appears to be gravity. Those are things you can test, right?
But the curving horizon, the sloping sea level, the spin of the Earth, unless you can see these phenomena with your own eyes, they may not be true.
Unless you can see things with your own eyes, they may not be true. Okay. Can you see air and oxygen? Oh my god. I said if you can't see it, it may not be true. I'm worried now that I'm not going to be able to breathe because I can't see oxygen. I'm shitting myself. Hello, is that Dr. Brian Cox, super genius?
Yeah.
I was just wondering what your opinion is on the flat Earth theory. I just want to make sure that my video is accurate and that I'm not the one that's wrong.
It's probably the most nonsensical suggestion that a thinking human being could possibly make. It is drivel.
Ah, right, so you do actually agree with me then. Thank you, Professor Brian Cox. Bye. See, Brian Cox agrees with me.
1, 2, 3. We're crazy!
Yes, you are!
Like many modern movements, this one has grown in large part out of the internet.
If it's on the internet, it's got to be true. Everyone knows everything on the internet is true.
For the serious students here at the conference...
Hang on, did she just use the words serious students?
For the serious students here at the conference...
This has got to a point now where it's becoming real.
Where it's becoming real.
It all comes down to proof.
There isn't any. At all. Dumbasses.
The Earth is flat. Why do you say that?
The evidence that we've seen doesn't suggest that what we've been told is true.
What evidence have you seen?
Well, I personally have been to Lake Balaton with FE Core, and we've actually done a laser test from one end of the lake to the, well, didn't do the full lake because it's massive, but we did a 12-kilometre test, and we could actually see the laser from one end to the other. And since then, the guys have actually produced a 40-kilometre laser test.
Kilometre schmometer. You said the longest test is they've produced a 40-kilometre test. 40 kilometres is actually 0.1% of the total distance around the Earth. So of course it's going to look flat.
So this guy with a laser debunks all the pictures?
No, it's not. That's the only thing. It's
go on, Phil, you old silver fox, get him. No, it's just an... How can you go on national TV and claim something so ridiculous? You're a grown man.
So what is happening here?
That's what I'm saying. We don't know, and science has never proven that as a force.
Isaac Newton got that wrong, did he? Did he just get that completely wrong?
He didn't want to answer that question, did he? No.
One of the highlights of my career, actually, was interviewing Major Tim Peake up in space on the International Space Station.
Right.
Now, he brought in his beautiful book. You see the curvature of the Earth. You very clearly see that it's a circle.
This is probably my favourite part of the whole interview, and I am going to link it below as well, because it's well worth watching.
So are you telling me that this interview with him, I'm talking to somebody that's just made that up or wasn't actually there? Or
Yeah, he's not.
He's not in outer space.
Can I just...
Where is he then?
In a Hollywood studio type.
Not necessarily
environment.
Hollywood
Maybe
studio,
here.
but...
Maybe where we are now.
But so you're saying that Tim Peake is alive?
Well, he's... I mean, if you look at Tim Peake and people like Neil Armstrong and all the astronauts, they're all military guys.
Everybody that's been into space, all astronauts are all military guys.
No, they're not. 230 individuals from 18 different countries have visited the space station.
230 individuals from 18 different countries, people, ordinary people, people that aren't military.
They were not all military. Some were teachers, We've met some of them, ordinary people. Are all 230 people liars?
Are they liars? Or are you just really stupid?
But we asked a poll. You've got a long way to convince our viewers,
Absolutely.
I'm afraid. Do you think the Earth is flat? No, say 94% of you, but 6%, yeah.
So what that tells me is 94% of the people they asked are normal, everyday, sensible people, and the other 6%, should I say stupid? Yeah, they're stupid, because the Earth isn't flat.
All right. All I'd say is go research it for yourself. There is a wealth of material online. Have a look
We're living in the
yourself.
age of technology. There's no excuse anymore.
That's quite right. We are living in an age of technology, so there's no excuse anymore for being that stupid.
Absolutely. Thank you. Although the Greeks saw the shadow on the thing, they didn't.
If you are
interested,
interested,
yes, we are. I bet there is.
If you are interested, the space station is currently off the coast of New Zealand.
Or is it?
I'm going to assume that these three men are all married as well. Can you imagine their wives once they watch this on TV? Oh my God, I can't go down asses now. You just made yourself look like a total idiot on TV and everyone saw it. Everyone's going to make fun of me now because my husband's a spanner. What were you thinking? Anyway, I'm going to leave it there now. There's tons of stuff online you can find about the flat earth theory, and it's all got one thing in common. It's complete and utter crap. See you soon. Bye.
You asked for it, I deliver one full episode of nothing but Chatbox Travels. I hope you enjoy it. Be on the lookout. There's one that's really disgusting, very disturbing. But the rest are pretty funny. I hope you enjoy it. And so we'll start off with Robin Minge.
Hello, my name's Robin Minge, 1936. Debate Eric Doobie or delete your YouTube channel. Simple. Strawman. Chocolate ice cream emoji.
You know, I get a lot of people that demand that I debate Eric Dubay. I will gladly debate Eric Dubay, but Eric Dubay is scared to debate me. Why is that? Well, Robin Minge, you take this news back to Eric. I accept. And if he doesn't, then make sure you tell Eric that he needs to delete his channel.
Hello, it's me again, Robin Minge. The star above us never changed from thousands of years if we live in a spinning ball floating around the space. How did the ancient culture record / maped it space, comma, and we still use the same techniques? Polaris star emoji never moves.
Well, Robin, I see you are a very good parrot of Eric Dubay. Unfortunately, Eric is wrong, and so are you. Tycho Brahe measured the location of Polaris just 500 years ago, and it was 3 degrees from the center of rotation. Today, it's about half a degree from the center of rotation. So there you go. Thousands of years, no. Only 500 years, and it's moved 2.5 degrees.
Gildas Camps. He is living in Bangkok, space, comma, and we meet often, space, comma. Jeep, your BS for yourself. Toot toot.
Joel is talking about Eric Dubay living in Bangkok, and apparently Joel and Eric hang out often. And then they go jeeping people's BS.
Camera tricks. 4 full stops. Mark is not going back to the center line. Full stop, comma, full stop.
Flat Squatch is talking about Mark Sargent. He's one of Mark Sargent's cult members. Anyway, Flat Squatch says that the high altitude balloon and airplane photographs of the curving horizon are just camera tricks. Of course, those were controlled for and covered in the video that I did. So it's just a lie on Flat Squatch's part. But Mark is not going back to the Santa lie. Okay, I don't care about Santa.
You are a tool and fool, and no one believes a forking word you say. Equal your own Neil deGrasse says you cannot see the curvature from the red ball jump. 2 full stops. Yeah, keep on lying to the rest of your booster shot fools. Space exclamation point.
Here you have another member of the Mark Sargent cult who is quoting Neil deGrasse Tyson. Of course, Neil deGrasse Tyson presented no analysis. So it's just an appeal to authority. But Neil deGrasse Tyson also says that the Earth is a globe. So are you going to stick with that one? Or are you just going to cherry pick Neil? And then standard for people with no evidence. They just cannot stay on topic.
Matt, come on. You are grasping, you are hoping, you are wishing that what you say is true. Lots of full stops. Wishful thinking, fantasies, the need to be right even when you're wrong.
Oh, Semper Fidelis 2970. I just have one question for you. Who the hell is Matt?
You're full of it. Turns, you are a very odd person. Who is paying you to be a spazzo?
Noel, and Ellen Chatfield. Very sly responses there. Thank you very much for those deep thoughts from you. Who is paying me to be a spazzo? I can't tell you.
You're gay? Lamau? Ovka.
Well, Wynand988, to my knowledge, I am not. But why does it even matter? Why is that even an insult in your mind?
Dispersion of density. I work at an airport, bud. Only the lower intellect portion of the population equates regurgitation of consensus to intelligence.
Austin Whitsitt, Flat Earth's largest purveyor of word salad, says dispersion of density is how the principles of flight is achieved. And how does he know that? Well, because he works at an airport. Well, sorry, Austin. In order to be the person who would know that, you wouldn't work at an airport. You would need to be an aeronautical engineer. They're not airport employees, Austin. They're employees of airplane manufacturing companies. And those people don't just regurgitate consensus in order to do their job. They need to understand things. They need to work through the actual application of physics and science. Things that you've never done. In fact, you have only regurgitated things that you agree with by people that are wrong, or even worse, just made up stuff. Austin, it's a complete failure every time you open your cornhole.
Oh no, a real photograph of a painting. Lol. Pathetic tune. 4 full stops. Hey, George. Space question mark. Alan Bean? I don't know what Alan Bean is.
That one is from Brian's Logic, who is claiming that these photographs were photographs of paintings. He doesn't actually provide any information for it, so I asked him, well, what was the name of the people that painted the paintings? And how do you know that? Where's the documentation of that? And where did they do it? And where were they housed? And who photographed them? And where's the documentation for all of this process? Of course, like every single flat earther, they think that just making a claim is proof. In fact, making a false claim when you know it's false is lying. Gotta lie to Flurf.
Forking hate these NASA-loving forktards. They were teaching flat earth in school before WW1. Do your homework, dickhead.
Well, I did my own homework, unfortunately for you. I was in a museum in Gordon, Wisconsin. It's a very small town. It's a very small museum, but they had the annual cyclopedia from 1878 in the museum, and here is the page on the Earth where it mentions that the Earth is a globe. 1878, last I checked, was before World War I.
You can come if that's Sabbath. 2440. You will go down in history as one of the worst people ever on YT. Once your retarded followers realize they've been duped by pseudoscience. You're just an ignorant lying dork. Hope all the lies you tell for money is worth it. Shame on you, nerd, you soulless piece of two spaces snooker-dookies.
Well, Flat Sabbath, I accept you calling me a dork or a nerd as a badge of honor. You feel free to call me a geek as well. Now, you think that somehow I'm wrong or have been duped by pseudoscience. Well, here is your invitation to come on and face me live, where you can present real science for Flat Earth. Not you don't understand the globe. Not that. For Flat Earth. Go ahead. Email me, mctoon@mctoon.net, and we'll get it set up.
Hopefully you said blatant lying deceiving. Fantasy Club defenders on the payroll will have all your jabs during the last 2.5 years, and good riddance.
Forget Mao, forget Pol Pot, forget that German guy from the 40s. That's child's play to Tony Dixon. You see, when Thanos snapped his fingers and he took away half of the population of the universe, well, the Earth has about 8 billion people, little less. That would be 4 billion. 4 billion. Thanos, 4 billion in the Marvel Universe. But Tony Dixon wishes for everyone that has gotten the medicine for that recent disease to be good riddance of, to them. That's 5.5 billion. He's worse than Thanos, too. That's how evil Flat Earth is. The conspiracy nonsense, the conspiracy mindset that Flat Earth festers in these people is absolutely disgusting. If anybody knows Tony Dixon, get him checked into an asylum. That's where he needs to be. All right, we got one more. Little fun. Cats looks well different with hair. Still, fortune favors the bald. You think so? You think cats would look good with some hair? I do too. Well, there it is, a full episode of nothing but Chatbox Travels. You asked for it, I delivered. Let me know if you like this, or if you prefer them embedded, or if you want both. Just put in the comments there. And if you haven't yet subscribed, please do that. Click on the notifications thing, and be looking out for the next video.
Hello and welcome back to the channel once again. I'm Mr. Sensible. Today we're going to have a look at a guy whose channel's called Right the Hand, and he's got a total gish gallop of misunderstanding, lack of knowledge and fail. I'll let him introduce himself.
What up, Right the Hand? We're going to be talking all the bullshit ball lies and my demolition of them, and it's not going to take an hour to do just Coriolis. I can probably do every single ball lie in under an hour.
And he's going to try. Better crack on with it then, Right the Hand. We haven't got all day.
So Coriolis here, we don't feel the spin, so it's not spinning. We could end it there, I guess. We'll do one more. They'll say, oh, but it's not spinning fast, because yes, it's 1,000 miles an hour, but it's only 1 revolution a day, so it's not that fast. And I would be like, oh, okay, that makes sense, because if you had a whole bunch of NASCARs going around a track, right? And somebody was like, wow, those cars are flying, man. How fast are they going? And you go, oh, they aren't going that fast because they only make it around the track once a day.
Yes, I take your point about the NASCARs, but they're on a banked track to stop them flying off. On the Earth, we've got gravity that does much the same thing.
All right, next. This is supposed to be quote-unquote Earth. What the fuck is it floating in?
It's not floating in anything. It's just in space. It's in nothing. Okay?
Is it... I don't hear any other people ask ballers these questions. What is Earth floating in? You know how many ballers say it's falling? Oh my God, they'll tell you it's falling. And I go, to what? Is it falling to the ground? They think there was some explosion and it's just like, it got thrown out 4.5 billion years ago. The universe threw a fastball of the Earth, put a little curve on it, you know, put a little spin so that all the water won't move.
Well, if you could just have a planet in isolation, just in the middle of space, it wouldn't be falling anywhere. We are falling towards the sun, or trying to, and as we curve, we miss the sun. Imagine throwing a ball and it curves down in an arc until it hits the ground. Now if you throw it so far it passes all the ground, that arc will continue.
So if this is a ball with water and atmosphere stuck to it in a vacuum chamber that is either being propelled for billions of years forward or is just straight falling, you need to demonstrate that. And if it's falling, why don't we jump off of it?
Yes, we're moving. What exactly do you think will slow us down? We're not going to get friction from the air. It's space. We will continue unless another force acts upon us. We'd continue a straight line. In our case, there is another force. That's the sun. And that's why we go into a curve. And because of the speed and distance, that curve becomes an elliptical orbit.
And then say, hey, we can't see some of Chicago because Earth curve. You don't see Earth curve, okay? When you have a physical body curving away from you, you cannot see what is fucking curving away from you.
Wow, a flat earther who gets it. You won't see the curve away, you just see the horizon. And looking around, it will look like a flat disc. Brilliant. Well done.
You're not seeing buildings and then coming up with a fucking excuse for why you're not seeing them.
If I put something round the side of your house, you're not going to see it from the front. Why? Because the building's in the way. We're not going to see all of those tall buildings at a distance because something's in the way. The curve of the Earth.
And the best idea you can come up with is the Earth is curving away from me in such a way that eventually people are going to be upside down under my feet. The only reason and the only proof that the Earth is quote unquote a ball is that they don't see a building.
So, Mr. Sensible.
Hello, mate. It's Dan.
Yeah, so how's it going, pal?
Yeah, I'm good, thanks. I'm just watching Flat Earth debate.
Oh, you don't want to do that, man. You'll go blind and your palms will go hairy. Here, I think that Arwin's just seen my 1,000 subscriber special. I think he's a bit miffed now we've seen how long it took me to do it. Anyway, pal, I'm doing a quick video about that right the hand bloke. And you know that thing you were telling me about the other day? Well, I wondered if I could borrow it, because I need it.
You got it. Oh, yeah, it's somewhere on my desk. Hang on.
Yeah, well, cheers, Pat. If you could send it to me, that would be great. I'll tell you what, I'll set you up on a date with Orphan Red, okay? See you, mate. Right, cool. Oh, excellent. Okay, now Dan sent that, we can go ahead.
The only reason and the only proof that the Earth is quote unquote a ball is that they don't see a building.
Thanks for that, Dan. I really appreciate it. Hey, everyone. If you haven't checked him out already, check out Simon Dan. He's an upcoming creator. Go and have a look. He could do with the subs.
So this, I don't know what the fuck it is, but until you can prove that something can fall around a ball in a vacuum chamber over and 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 over.
Oh no, I think I've broken my flurf.
Over and 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 over again. I'm not going to believe that it's fucking what you tell me it is. I'm going to believe it's a light.
Use a website like Heavens Above to predict when the ISS is going to come over. Get yourself some binoculars or a telescope and have a look for yourself.
Because only a light can move across the top of the sky. You don't have objects falling around a ball over and over again.
Bold ass assertion. Go read a science book.
This doesn't prove Earth is a ball floating in space. It proves there's a picture of something that looks like what you've been told. Don't assert because you have this, then that means the Earth is what they tell you. No, that's your faith in a picture. And on the same note, forget air next to a vacuum. We don't... You fucktards. This is why ball earthers and flat earthers, this is why I'm not a flat earther, because they're both as stupid as fuck. Now, you will argue, as a flat earther, show me a vacuum surrounding an air pressure. Fuck that. Why are you giving them something? Get that fucking ball with that fucking water and that air stuck to it in that vacuum chamber. Why are you leaving out half the equation?
Well, it looks like Princess Stroppy is throwing a strop. You want a ball of rock with water on it, with atmosphere, in a vacuum? We got one of those. We're living on it.
Alright, this is what they call a lunar or solar eclipse. I don't even give a shit. It's a visual event in the sky which I can replicate and duplicate exactly on a screen, which means it can possibly be a screen. So you can't say that it has to be matter orbiting matter in a vacuum, then the rock gets in the way of the sun, which is a ball of fire, which we'll get to, and that's blocking it out. You can't say that unless you can demonstrate the principles and properties of matter which allow that to happen in reality. I can demonstrate a screen doing exactly what you see in the sky. So until you can do that exact same thing in reality with balls and a light, Alright, now, things fall down. I'll say, yeah, things fall down. What, are you going to argue with me about that? Oh, no, things don't fall down.
No, not going to argue with that. Lots of things fall down. Mainly your arguments.
You could go, why do they fall down? I'll give you an explanation. Doesn't mean that's why it falls down. Now, the principal problem with their explanation of why things fall down, if you want to go down the route of explanations and how they're bullshit, but we'll try and connect it to reality, is they'll say the Earth is pulling everything down.
Gravity for the win.
And you'll go, well, how does it do that? Is there a physical connection between the Earth and the rock, and is it constant? Or is it a cycling pull? Is it a wave? Is it pulling, not pulling, pulling, not pulling? Or is there a constant pull? Is it uniform? What is the mechanism? Is there a physical connection? They can't answer any of these questions. So, there you go. Now again, I don't rarely hear people say this, but I'm going to give you ballers an argument help here. If people go, well, wood goes up in water, you go, well, the water is going down on Earth, right? The water's not floating up, the water is down on Earth. It's just there. Okay, so then it becomes, what's keeping water to Earth? I never hear a baller say that when I use the wood thing. Well, wood goes up in water. Well, yeah, but Earth is, quote unquote, pulling the water down. So what does keep water down? I don't know.
Gravity. Little g. By the way, whatever you do, do not talk to Anthony Riley or you've really had it.
These are the stars or lights in the sky. Yes, they move. That doesn't mean the Earth is spinning. That doesn't mean they're balls of gas in a vacuum spinning around us or stationary or whatever the fuck you say is happening. I'm sure there's plenty of other explanations for why what you see is happening, but it doesn't prove anything except what we see.
I can't take much more of you. You don't believe or accept anything. If you reached a crossing and the light was red, you'd refuse to believe it was dangerous to walk out. You'd step in front of a car because you wouldn't believe that cars are driving along at speed and you shouldn't cross when it's red.
Ball Earth is a religion. Where's the proof? Where's the science? Where's the evidence and demonstrations in reality? Everything you have is I trust experts.
In science, in real science, which is scientists, highly trained people with years of experience, conducting various experiments, gathering all the evidence, to my knowledge, there is not a single shred of evidence pointing towards a flat Earth. The percentage of evidence pointing towards a globe Earth, I believe, is somewhere in a region of 100.0000%, and it may be more. Your video is the biggest ranting of unsupported gish gallop of assorted crap it's ever been my misfortune to come across. The number of bold-ass assertions you made with zero evidence is beyond compare. So I suppose you win on that one anyway. A big thanks to all my patrons. Massive thanks to my wonderful patrons: Bernard Godfrey, Elizabeth Schneider, Frank Kelly, Frederic Sigard, John Calvin Hobbs, Mick Farnham, Mitch Goldstein, Poison Toad, Roy Fraser, Simon D and Steve Pleggy. Thank you all so very, very much. If you haven't already, please consider subscribing. Just hit mini-me down in the corner. I appreciate all the views, the likes and the comments. As I said, don't forget to check out Simon Dan's channel. He's a great guy and he could do with the subs. He's only currently got... Oh.
Greetings once more, dear viewer. In the last part we saw how the go-to map hijacked by flatards is not concordant with reality when considering simple geometry. And we wondered why people flying from Sydney to Johannesburg arrive on time, without seeing unexpected sights, and without crashing thousands of kilometres off course in the Himalayas. Unsurprisingly, a flood of choleric skid marks who think there's a global conspiracy to hide Earth's shape proceeded to smear themselves over the comment section, and in well over 14,000 comments as I speak, not one of them has demonstrated any ability to either address the content of the video, or to answer even the simplest geometric questions about their disk world. Having seen their abysmal failure to wrap their minds around 2 dimensions, in this part we're going to look skyward and see if things get any better for them. Let's start with the stars. Flatards love Polaris. Most seem to think it is directly on the North Celestial Pole, which it isn't, that it doesn't move, which it does, and that the sky rotates around it, which it doesn't really. However, they think it fits their space pizza idea really nicely. For those who think the flat Earth goes on forever as an infinite plane, the night sky must also be some kind of roughly planar object rotating above Earth, which it would do because reasons. Hey! For those who think they live under the dome of a giant snow globe crafted by an elusive space wizard, the night sky must be constrained by the dome in some way, which also places limits on the distance to the stars. A dome-based night sky also rotates because reasons. Hey! Unfortunately for both varieties of flatard, to test these ideas all they needed was a collection of observers at different latitudes. The double star Sad-el-Melik, or Alpha Aquarius, is pretty much bang on the celestial equator, and so for basic naked eye observations is a good marker for it, just as Polaris is for the North Celestial Pole. These must be the case on the flat Earth too, so Sad-el-Melik will be flying around in a circle above the flat Earth's equator due to some unknown force. And Polaris will circle 40 arc minutes from their North Pole due to some unknown force. Time for the flatard to get his chums at different latitudes. What would they see? This rather depends on how far away the stars are. Unfortunately for us, the track record of flat-earth astronomy is not just piss poor, but non-existent, and they haven't figured that out yet. So what can we say about Sad el-Melik and Polaris in the flat-earth fantasy world? Observers at the centre of the pancake Earth and those on its equator would be able to see both stars, as would every observer in between, and every observer south of the equator. However, reality disagrees. Consider the September equinox when Sad el-Melik will be visible at night. An observer at the North Pole isn't going to see much because at the equinox the sky is still too bright. So let's head further south. Someone 80 degrees north will see the celestial pole 10 degrees from his local zenith and Sad el-Melik 10 degrees above his horizon. Someone 70 degrees north will see the celestial pole 20 degrees from his local zenith and Sad el-Melik 20 degrees above his horizon. Unsurprisingly then, an observer on the equator will see the celestial pole on his north horizon and Sad el-Melik directly overhead. Why? Simple. For an observer at a given latitude, their night sky obviously consists of the 180 degrees that they can see from horizon to horizon, with their zenith directly overhead. Polaris is 434 light-years away, so he's way off the top of the screen. Sad el-Melik is about 523 light-years away, so he is way off the left of the screen. The angle of elevation of the celestial equator when crossing the observer's meridian is the same as the angle between his zenith and the celestial pole, 90 degrees minus his latitude. It's all exactly what you'd expect from observers sitting on a spheroidal planet rather than a giant disk made by an invisible cosmic mage. What does this pattern of observations look like on the flat-earth disk world? Well, we know that Sad el-Melik is overhead at the equator, and that Polaris is overhead at the North Pole. So far, so good. But we also know that wherever you observe from in reality, that they have an angular separation of 90 degrees. Let's put an observer every 10 degrees of latitude and add in their lines of sight to Polaris and Sad el-Melik. Where the lines of sight intersect, the vertical lines of equatorial and polar observers should provide a triangulation of the height of these stars. Unfortunately, what we find is that to match observations, each star would have to be situated at different heights at the same time, including ground level. This not only sheds some light onto why flat-earth astronomy has neither explained nor achieved anything ever, but also presents an unresolvable paradox that leads us inexorably to the conclusion that the notion of Earth being flat is not only geometrically impossible, but also complete bollocks. Observers north of the equator looking north will, depending on their latitude, see stars that never set and that circle the celestial pole. Determining how much of the sky is circumpolar is easy, it's given by your latitude. An observer at 63 degrees north in Tron time will see the celestial pole 63 degrees above his horizon, and so any stars with a declination above 27 degrees will be circumpolar. Simple. But what about the southern hemisphere? What will observers in Australia, southern Africa, and southern South America see when they look south? Well, according to the Flat Earth, observers in these lands are going to be looking in completely different directions, and they're sat below a sky that rotates above them around a single point. And yet, in reality, these observers will find themselves looking at the south celestial pole, and like its northern counterpart, its altitude in degrees above the horizon corresponds with the observer's latitude. Unlike its northern counterpart, the stars will appear to rotate clockwise around the pole instead of anti-clockwise. This is simply because the observer is looking at the same east to west apparent motion in the opposite direction. Flat-earth observers will, like the rest of us, be looking at the constellations of Octans, Hydrus, Mensa, Chameleon and Apus. The only difference in what will be seen by two observers in the southern hemisphere looking south at exactly the same time will be rotational. One observer's view will be a rotated view of what the other sees, and the angular difference will perfectly match their difference in longitude. It's exactly the same as happens in the north, and exactly what you'd expect of observers looking outward from the surface of a spheroid, as is the convergence of lines of longitude to a southern pole in the sky. How, though, can observers on a flat Earth looking south see the same thing when looking in different directions from a flat surface beneath a single spinning sky? They can't. It's geometrically impossible. and that's why flatards have to avoid the topic like the plague. One flatard in the comments to part 1 attempted to excuse this by claiming that the South Celestial Pole isn't a real pole, whatever the fuck that means, and that it moves. Unfortunately, what this laughable ad hoc excuse fails to consider is that you can sit and watch the southern sky all night rotating around the South Celestial Pole, and the pole doesn't budge one bit. It also doesn't account for how two observers looking south at the same time in different lands can see the same things with only a rotational difference. Had flatards bothered to travel a few thousand kilometres and look at the sky, they could have reached a simple conclusion for themselves. Both their ad hoc excuses and their Discworld are bollocks. When the stars are out of sight and out of mind in daylight, things don't get any better for flatwits. Having a universe rotate around their space biscuit like a flat-on version of geocentrism would present the obvious problem of the whole surface changing between night and day at the same time. Clearly this doesn't happen, as it's always daytime for half its area and night for half its area. This perplexed flatards, and they devoted their finest minds to solving this problem.
Blah, 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 blah. Finished!
What they came up with, in the form of yet another ill-considered ad hoc brain fart, was this. In their fantasy universe, the sun flies around above the Earth in a circle every day. Whilst the rest of the world laughed, flatards smugly thought they had this science business in the bag. They were then informed of the obvious problem with this idea, namely that if the sun is above a flat Earth all the time, it would be daylight all the time, and the sun would be visible 24 hours a day from every location on Earth. This perplexed flatards, and they devoted their finest minds to solving this problem. Rather than admit their stupidity, they doubled down. What they came up with was this: the sun behaving like a spotlight. This happens because of reasons. Here we have the flatard sun flying around above the Earth. It's an equinox. At each of the 2 equinoxes per year, the sun skims the horizon at the poles and is directly overhead the equator. On the flat Earth, the same must apply, so the sun is directly above their equator, and night and day are of nearly equal length. So what flatards are trying to say is that a single light source flying around 3,000 miles above Earth somehow illuminates half of the world. And the shape of the illuminated area has to change every day as the seasons drift. But let's come back to that another time. We're already getting a whiff, more of a stench, that flatards can't tell night from day any more than they can tell their arse from their elbow. So what do the transitions between night and day look like at the equinoxes on a giant space pizza? An observer on the equator will still see the sun pass directly overhead at solar noon, so the sun must be over the equator. This means observers on the flat Earth have to observe the sun rising directly northeast. It would appear to rise from a more northerly direction the further south you go, and tend towards a more easterly direction the further north you go, but would never rise in the east. Similarly, when the sun sets, an observer on the equator of the flat Earth would see it set directly northwest, setting on a more northerly heading the further south you go, and a more westerly heading the further north you go. It would never set due west. You'll be unsurprised to hear that reality disagrees. What actually happens at the equinoxes is that all observers at all latitudes see the sun rise due east and set due west, geographically speaking, not magnetically. Flatards have 3 choices at this point. They can accept reality and that their idea simply doesn't work, or they can deny reality and continue living in their little fantasy, or they can detail a mechanism by which equatorial observers see the sun a full 45 degrees off where it would actually be in their world, and that explains why any such mechanism would cause a deviation elsewhere that is a function of the observer's latitude, despite Earth's atmosphere being a homogeneous mix of gases that has no idea where it is. They will of course go for option 2. Having done this, we can expect them to adopt the other flatard stalwart, make up an ad hoc answer, and pretend that that explains everything with no further investigation being necessary, because reasons. A favourite excuse for things in the sky not being where they should be is refraction. In this case, that would not only demonstrate that flatards don't know what refraction actually is, but that they expect refraction to be affected by the observer's latitude rather than by any fundamental properties of Earth's atmosphere. For everyone to see the sun rise in the east on a flat Earth, we re-encounter a familiar problem. The sun would have to be in multiple places at the same time for observers up and down the world. And of course, people on the other side of the world will be watching the sun set and will face the same damned problem. All of this whilst the equatorial flatard in the hat says the sun is directly overhead. Since the sun isn't and never can be in multiple places at the same time, the presence of another simple and utterly irreconcilable paradox leads us to the only sensible conclusion, that the notion of us living on a giant frisbee is bollocks. Azimuthal discrepancies in the sun's position aren't the only problem facing the flying flatard spotlight, though. Flatards set their finest astronomers to the task of determining how far away the sun is. Naturally, doing anything resembling hard work was too much trouble, and since they don't have any astronomers, they were left with only one option: to pull a number out of their jacksies. The number they come up with is about 3,000 miles. However, their error margin is rather high, as some say it is up to 5,000 miles away. Well, let's stick with 3,000 miles or 4,800 kilometres. As we've seen, an equatorial observer at solar noon on an equinox will see the sun directly overhead. The distance from each pole to the equator is a few kilometres over 10,000, so let's just go with 10,000. A margin of a fraction of a percent is still better than any flatard has managed. When we divide that distance by 90, corresponding to each degree of latitude, we can calculate the altitude angle of the flatard flying spotlight above the horizon for an observer at each position as the inverse tangent of 4,800 over d, where d is the distance in kilometres from the equator. When we plot those out, that gives us this graph. Now let's compare the expected flat Earth altitude angles to reality. At the equinoxes, the sun crosses the celestial equator, so like Sad al-Melik in our earlier look at stars, the sun's altitude angle is simply 90 minus the observer's latitude. Let's add that to the graph. Okay, so the flatards are way off. We can see that there are only two latitudes that match the values for a flat Earth. There should be no discrepancy if Earth were actually flat. Once your latitude starts getting above the 50s and 60s, the error gets catastrophic. Everyone in Scotland, Norway, Sweden, Finland, most of Russia, Alaska, Greenland, and Iceland should be seeing the sun at a very different position in the sky that bears no obvious relation to their latitude. Of course, these errors apply both north and south of the equator, so when we include both hemispheres, our graph of discrepancies looks like this. Flatards usually concoct ad hoc excuses involving some new kind of atmospheric distortion, or some crap like that. However, even the most mentally crippled flatwit should be able to see the issue here. Earth's atmosphere is basically homogeneous, yet the discrepancy between their fantasy world and reality varies by latitude. Why do these gases care where the observer is standing? They don't. There are no properties of Earth's atmosphere that cause this. There's a direct and incredibly simple relationship between an observer's latitude and the altitude angle of the sun. If flatards can't even get something as simple as the position of the sun right, we can safely conclude that their sky fairy pancake is bollocks. In part 3 we'll keep our eyes on the sky and see what other problems it can cause flatards. See you then.
my god.
Hi folks, Astronomy Live here. First, I want to warn anyone watching this video that it will be dealing with some very heavy subject material and some very ghoulish claims that I want to discuss and debunk. Also, I want to please ask everyone watching this video to not reach out, contact, or otherwise harass anyone discussed or listed in this video. They deserve to be left alone, not harassed, let alone confronted in real life, which unfortunately, as we'll see shortly, has already started happening. First, a little bit of background. On January 28, 1986, Space Shuttle Challenger had her final, fateful liftoff, ending 73 seconds after liftoff with a catastrophic failure, resulting in the loss of crew and vehicle, claiming the lives of all 7 crew members aboard. Those crew members were Commander Francis Richard Scobie, Pilot Michael John Smith, Mission Specialist 1 Ellison Shoji Onizuka, Mission Specialist 2 Judith Arlene Resnick, Mission Specialist 3 Ronald Irwin McNair, Payload Specialist 2 Gregory Bruce Jarvis, and Payload Specialist 1 Sharon Krista McAuliffe. I'm not going to go into the various reasons why the tragedy occurred. Those reasons are already very well documented elsewhere, and it's outside the scope of this video. But I will say that this video is very tough for me to make personally, in part because I witnessed this in person, watching from my parents' front lawn as a child. I didn't understand what I was seeing at first. It looked unusual, but I was too young to understand. My mom quickly rushed us inside because she was concerned about the potential for toxic gases to blow our way. And it was that moment, seeing the TV across the room as we came inside, that I realized what had happened.
Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Challenger, go at throttle up. 1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles. Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
In the years since, multiple astronauts have come forward saying that there's evidence that the astronauts were not only alive until they hit the water, but that they were actually conscious for at least part of the descent, making deliberate actions to try to troubleshoot the problems with particular switch throws and turning on air bottles to try to troubleshoot the issues that they were facing. But in reality, there was nothing they could have done. They were doomed the moment the SRBs lit and the vehicle took off.
Challenge is fast, launch is fast. It's bang, and then it's a 2-minute ride down. And you're conscious, we know that.
Astronaut Story Musgrave told me the crew survived in that white cloud. It was Challenger's fuel tank that exploded. The shuttle itself just broke apart. The crew compartment with its 7 living occupants was intact.
The initial path of the crew cabin from the vapor cloud carried it across the path of an adjacent contrail, clearly revealing its truncated form and attitude. The left wing became visible at 78.531 seconds. The main engines and crew cabin are also identifiable.
It took 2 minutes and 45 seconds for the crew cabin to hit the water. The impact speed was 207 miles an hour. A NASA statement released after the accident reads, "The forces to which the crew were exposed during orbiter breakup were probably not sufficient to cause death or serious injury." And later, NASA is unable to determine positively the cause of death of the Challenger astronauts, but has established that it is possible but not certain that the loss of consciousness did occur in the seconds following the orbiter breakup. Musgrave, who is a medical doctor and surgeon, is quite certain.
You died when you hit the water. You know that.
You think so? That's always been controversial.
I don't know, sir. There's nothing controversial about that. No. hard evidence. Yeah, he died when you hit the water.
At the bottom of the ocean, investigators found that some of the crew's emergency oxygen masks had been turned on. Said another astronaut, Scobie fought for any and every edge to survive. He flew that ship without wings all the way down. They were alive.
You could have lost consciousness at that altitude if it depressurized for a little while, but then, no, there's all kinds of evidence that you died when you hit the water.
You could hear it in Dr. Story Musgrave's tone of voice, couldn't you? The seriousness of this incident, and how he firmly believes not only did they survive until they hit the water, but they were conscious for part of that descent, and trying to do things to fight the situation on the way down. And he's not the only astronaut who believes that. If you want more on that, you can go read the book Riding Rockets by astronaut Mike Mullane. Unfortunately, there are conspiracy theorists who believe that the astronauts didn't die when they hit the water because they believe they didn't die at all because they were never on board. That's right. What we're here to talk about is a viral video of an individual coming to the Brevard County Commissioners meeting earlier in May of this year and presenting to them a conspiracy theory that the astronauts from Challenger are actually still very much alive and need to be investigated.
Almost all of those astronauts alive and well, many using the same exact names. As you can see here, we have Challenger astronaut Judith Resnick and also a Judith Resnick Yale law professor. Michael J. Smith, the pilot of the Challenger astronaut, and also professor at University of Wisconsin, now retired Michael J. Smith. Commander Dick Scobie, who is now president of Cows and Trees. Now, if you'll notice, they all have the exact same faces 30 some odd years later, the same exact name, and they are the same age.
You can probably now tell why I'm having trouble maintaining my usual degree of civility as we go through this video. But I will endeavor to maintain that civility despite the disgusting claims made by Justin. Let's start here. This is Judith Resnick, professor of law at the time at the University of Southern California Law School, and here she is during a 1987 Senate hearing for the nomination of Robert Bork to the U.S. Supreme Court. The first thing I want you to notice about this video is the date, 1987, less than 2 years after the Challenger accident. So aging is not an explanation for why she looks different from astronaut Judith Resnick. She is very clearly a totally different person. Conspiracy theorists like Justin focus on more recent photos of the people that they claim were the Challenger astronauts. They will not show you this video, and they will not show you photos of those people much closer to the time of the Challenger accident, because it takes away the argument that any differences in their faces are just down to aging. This particular video is excellent because it is a video from a known event in history, the Bork confirmation hearings, so there's no arguing about when it was recorded. We know exactly when it was recorded in 1987. So now that we've removed aging as a factor, let's remove my personal bias as a factor and run an image from this video through facial recognition software to see if this Judith Resnick is the same as astronaut Judith Resnick. The answer is absolutely not. They are two different people. Facial recognition correctly detects Judy Resnick on the right as the astronaut Judy Resnick, but it doesn't put a box around Judith Resnick, the law professor, on the left. It's only been trained on astronauts, and it does not recognize her because she is a different person. Now we're going to test the claim that aging will throw off the facial recognition and make it impossible to detect recent versions of their appearance if trained on younger photos of them taken closer to the Challenger accident. Here we have a photograph of the law professor Judith Resnick taken in 1990, and a high-resolution copy of this photo is available for download, which makes it an excellent choice to train the facial recognition to recognize a young Professor Judith Resnick and test that against both the astronaut Judy Resnick and against more recent photos of Professor Judith Resnick. This version of the facial recognition software was only trained on the photo of young law professor Judith Resnick, not any of the astronauts. That way, if we feed it a photo that contains astronaut Judy Resnick and we get a detection, we'll immediately see that detection, and it can't be masked by also detecting the astronaut photos of Judy Resnick. As we can see, this version of the facial recognition software detects law professor Judith Resnick just fine during the confirmation hearing video that we just watched. It also detects her just fine in other pictures, even pictures where she's much older, but it does not detect astronaut Judy Resnick. Conversely, the version of facial recognition trained on the astronauts detects astronaut Judy Resnick just fine in this photo and does not detect the law professor as the astronaut. Age alone does not explain this difference. The version trained on the young photo of law professor Judith Resnick detects the older version of her just fine in this photo. And even if we look at this picture taken just last year in 2023, it also detects the older version of Professor Judith Resnick just fine. We now return to the picture printed at the top of Justin's poster, and we can clearly see that law professor Judith Resnick is not the same person as astronaut Judith Resnick. Now let's address Justin's claim that the astronauts and their doppelgangers are the same age. Judy Resnick, the astronaut, graduated from Carnegie Mellon with her bachelor's degree in 1970. Judith Resnick, the law professor, got her bachelor's degree in 1972. And I can find no information to suggest that she was the same age as Judy Resnick, the astronaut. In fact, the dates present a real problem for the conspiracy claims, because although they don't seem to be the same age, there is extensive publications made by the various academics that we're going to be seeing in this video, Judith Resnick, the law professor, being one of them. And she has publications that go before the Challenger accident ever happened, such as this publication in November 1982. These facts all demonstrate that astronaut Judy Resnick is not the same person as professor of law Judith Resnick, who now works at Yale University. However, that didn't stop a conspiracy theorist from confronting her on the Yale University campus. And this fact, this incident, is actually cited by Justin in his video.
Miss Resnick was questioned at Yale by a journalist, and she panicked and ran from the camera. Why?
Hey, Judy. How you doing? I'm from the press. I just had a quick question, if you don't mind.
What press? I'm
from a radio station in San Bernardino. I know there's a conspiracy about the space shuttle. No, I want to be polite. Friendly. Just a question. So there's a lot of rumors about you being on that space shuttle. Obviously, you know, if you want to comment, we would really appreciate it.
This is why I think it's very important that I make this video. Because of this right here, you already have conspiracy theorists starting to confront these people in real life, falsely accusing them of being dead space shuttle astronauts. What's going to happen next? In my opinion, it's completely reasonable that she immediately removes herself when ambushed by a person falsely accusing her of being a dead astronaut, and hopefully she went to get security. We have people like Justin who show up to Brevard County Commissioner meetings and demand an investigation of people who had nothing to do with the Space Shuttle Challenger accident. And my big concern is, when this investigation fails to materialize and nothing happens to these people, whether it's Justin or some other conspiracy theorist, who's going to be the next person who tries to confront these people in real life, and what are they going to do knowing that there have already been demands for an investigation by the government and nothing happened? Are they going to try to take matters into their own hands? I think there's real reason to be concerned about something like that. Now, we've already established that Judy Resnick, the astronaut, is not the same person as Professor of Law Judith Resnick at Yale. Let's move on to the next person on Justin's board, Michael J. Smith.
Mr. Michael J. Smith was also questioned, and he said, "Yeah, we look alike, but that's not me." You can see both of these exchanges in a film called Level With Me, and you can be the judge.
Once again, Justin is referring to a video that shows another conspiracy theorist confronting one of these people, this time at their own home. We're going to see here in this clip the professor, Michael J. Smith, from the University of Wisconsin, being confronted by a conspiracy theorist suggesting that he is, in fact, the dead astronaut, Michael J. Smith. Let's listen in.
Professor at university.
Retired.
Retired?
Yeah.
Yeah. Yeah, I just stopped by because there's this room. Are you aware of that there's a rumor on the internet
It's not me.
That people are saying?
Yeah, it's not me, obviously. I mean, anybody that looks at my background, looks where I was born, it's not me. I mean, it's interesting that the Michael J. Smith that was the astronaut looks something like me when we were younger, but really not if you really look at facial recognition.
You never been a pilot, never been in the military?
Nothing like that.
Huh.
No.
Okay.
Yeah.
That's all.
And I don't respond to the emails I get. I get probably an email, maybe 2 a month.
Really?
Yeah, and I got one guy that's been really hounding me, and I turned it over to the FBI.
Really?
You know, yeah. I mean, it's bullshit.
Okay.
You know, another crazy theory.
Okay.
But that's, you know, not me.
All right.
I'm glad I wasn't him, but he was quite a guy.
Yeah.
You know, but if you look at my career, you look at my CV that's online, all the stuff I've published, all that I've done, it's not even close to what that guy was.
We're going to do exactly what Professor Michael J. Smith suggested in that clip. We're going to take a look at his background and his history of publications, and we're going to see if he is in fact the deceased astronaut or not. And we're going to start here so that we can have a baseline to perform facial recognition, because, as he said, although they used to look somewhat alike, perhaps, they really weren't all that close, especially if you look at what they looked like in the 1980s. This photograph from 1990 shows Professor Michael J. Smith hunched over a computer, and there's a watermark across his face, but the original photograph was available for sale for $19.99. And guess who did their research, found this photograph, and purchased it? That's right, yours truly, and I now am the proud owner of this photograph, which will remain as probably one of the strangest pieces in my collection of space-related artifacts, because of course, as we'll find out, it's not actually space-related at all, because this individual is not, in fact, the deceased astronaut, Michael J. Smith. As we did with the law professor Judith Resnick, where we used her photograph from 1990 to verify that we were able to recognize more recent photographs of her, we will use the photograph of Professor Michael J. Smith from 1990 to see if we can recognize a more recent photograph of him. In fact, let's use it on the very photograph that Justin presented on his board. Indeed, we get a match only for the Michael J. Smith on the right, the professor from the University of Wisconsin-Madison, not Michael J. Smith, the astronaut. Conversely, if we only train the facial recognition on the faces of the astronauts, we only get a hit for the photograph on the left side of the picture, the astronaut Michael J. Smith. By using the photograph of Professor Michael J. Smith from 1990, we've already ruled out aging as the reason why Michael J. Smith, the astronaut, is not producing a hit for Michael J. Smith, the professor. But wait, there's so much more. As Professor Michael J. Smith mentioned, his professional history is quite different from that of the astronaut, and it's also well documented, including this paper which he published in 1984. In other words, this paper was published over a year before the Challenger accident. But what's most damning for the conspiracy of all is that at the end of this paper, there's a short biography on the professor himself, including a photograph. Running this through the facial recognition software trained on the professor's 1990 photograph, we get a match. And as you can see, he looks nothing like the astronaut did in the 1980s. And running this picture through the facial recognition trained exclusively on the astronauts, we do not get a match for the astronaut, Michael J. Smith. I want to close out this segment of the video by pointing out that this information was publicly accessible. Anyone could have done this research, and it's unfortunate that I have to be the one to do it after someone has already harassed him in person at his own home. That is completely unacceptable. As he said in the video himself, he receives on average about 2 emails a month, and one person was harassing him so badly that he had already reported it to the FBI. That is completely unacceptable, and it's exactly what concerns me, and it's exactly why I'm making this video. Justin doesn't seem the least bit concerned about the harassment that these individuals have already received in real life. In fact, he's citing those incidents as evidence for his argument, and he's trying to go even further by demanding that the government investigate these individuals, victimizing them further. Justin has already blocked me on Twitter, But his friend, Austin Whitsitt, was at this Brevard County Commissioner meeting as well, and I don't see him calling out any of this behavior either. We're now about to address the last of the astronaut doppelganger pairs that Justin brings up in his presentation, astronaut Francis Richard Scobie and CEO Dick Scobie. But before we get started on that, I have to start by asking the question, do Justin and Whitsitt actually believe this information that they were presenting at this county commissioner meeting? Well over a week ago, as I record this video, I had this exchange with Whitsitt on Twitter. Initially, he was trying to make the argument that the reason I wasn't getting a match between the astronauts' photos and the more recent photos of their supposed doppelgangers was because of aging. As you've seen earlier in this video, we've already thoroughly addressed that question by using much older photographs of the doppelgangers. But back on May 29th, I didn't want to tip my hand too much to Whitsitt just yet, so I used Johnny Carson as an example. Because of his lengthy career, there are high-quality photographs of him both at a young age and at much older ages, and despite training the facial recognition exclusively on younger photographs of him, I'm able to still get hits on photographs of him much later in life. As for Whitsitt's demand that I go on a live stream while he tosses images at me and demands that I perform real-time facial recognition, in reality, the facial recognition neural network that I used has already been validated against the labeled faces in the wild dataset of well over 1,000 faces and achieved an accuracy north of 99%. Despite the redundancy of his request and the insulting accusation that I was being dishonest, I agreed to go on his live stream as long as he honestly answered one simple question. The question I asked him was whether any of the photos that Justin presented of these supposedly alive astronauts had been mirrored horizontally to better resemble the astronaut that they're supposed to be. Obviously, if he can't honestly answer that question, then we have a real problem with the notion that he's supposed to be the arbiter of whether my facial recognition software is working correctly or not. As I record this video on June 9th, 2024, well over a week after I asked him this question, he still hasn't answered me, and we're about to see why. Brevard County, of course, has no jurisdiction over the individuals that we've covered so far. They're not even in the same state. So, Justin and Whitsitt were both kicked out of the meeting. Now, after they exited the building, Justin resumed his presentation outside, and we're going to take a look at what he said about the final individual on his board, Dick Scobie.
As I was saying, before I was rudely interrupted and my First Amendment was violated during a public comment period here in Brevard County, I was saying that Mr. Scobie is the most interesting because not only does he have the same age, same face, same name, same slanted eye in the cheek if you look very closely, same slanted eye in the cheek if you look very closely. Get this, he created a company called Cows and Trees, and the promo video has a cow blasting off strapped to a rocket, leaving a smoke trail eerily similar to that of the Challenger explosion.
Let's tackle the promo video real quick first. This is the original intro to the Cows and Trees website from the Wayback Machine. A few years later, the company's promo changed to feature a cow strapped to a rocket flying around, doing a spiral and then leaving the screen. The spiral smoke then fades into a nautilus, which is the logo for the company that they were now partnered with, called Noble. That company's logo was indeed a spiral, and they merged this with the Cows and Trees logo to make their new promo video. That's all there is to it. But now let's return to what Justin was saying about Dick Scobie's appearance. He pointed out the slanted eye and the cheek that he thinks is identical to the astronaut Dick Scobie, whose full name was actually Francis Richard Scobie. Well, let's take a closer look at that, shall we? The other side of Justin's poster actually kind of gives the game away, but you can't really see it that well in the video because the Brevard County Commissioner's banner at the bottom blocks part of the photo. But if we take a closer look, what's different about this? For comparison again, here's the photo of Dick Scobie that he presents on the back of his poster, next to Dick Scobie, the shuttle commander. Again, Justin made a special point of the asymmetry in his face, but it's mirrored from the face that we just saw on the other side of the poster. Even with it mirrored and altered by Justin, facial recognition still does not detect the astronaut as being the older Richard Scobie on the right. But make no mistake, the conspiracy theorists have indeed mirrored the photo on the right of the older Richard Scobie. Here is the original from his LinkedIn page. If you look closely, you can see his shirt button now, and you can see that it is indeed on the right side of his shirt, as it should be for a men's shirt. This correct orientation picture of Richard Scobie was also run through facial recognition and failed to detect the astronaut Dick Scobie. His other pictures were also run through facial detection and also failed to produce a match for the dead astronaut. Now, unlike Professor Michael J. Smith and unlike law professor Judith Resnick, Richard Scobie is not an academic. He's the CEO of a marketing company, so he doesn't have an academic publication history that we can reference, nor has he given testimony before the Judiciary Committee of the Senate that I know of. But his face does not match that of the deceased astronaut, and he's had a family since before the Challenger accident ever happened. Now, unlike conspiracy theorists, I'm going to respect the privacy of him and his family, but there is no doubt that they are related to him. Just like there is no doubt that the photograph of the older Richard Scobie that Justin presented on the back of his board, where he points out the asymmetry in his face as being identical, that photograph is actually horizontally mirrored to try to make him look more like the deceased astronaut.
Same slanted eye and the cheek, if you look very closely.
That brings us to the end of Justin's video. But there are 3 other Challenger doppelgangers that other conspiracy theorists frequently cite, including in the documentary that he referenced, but he chose not to show these doppelgangers at all in his presentation. As with the others, facial recognition distinguishes them as different people. In this example, we have Krista McAuliffe on the left, the teacher in space, who perished on Challenger. And on the right, we have a completely unrelated individual who has her own private life, and again, I'm going to respect her privacy, and I suggest you all do the same. Lastly, we have 2 examples of siblings. That's right, siblings. Conspiracy theorists accuse siblings of deceased astronauts of being the deceased astronauts themselves. On the left, we have Ronald McNair, and on the right, we have his brother, Carl McNair. Now, I will give Justin the benefit of a doubt that part of the reason why he chose not to include these last 2 examples who are siblings is because it's too despicable even for him to accuse the siblings of the deceased of actually being the deceased and lying about it. And you can also see that Carl McNair has very different teeth than his brother Ronald McNair. There is no doubt about that. So I'm not sure why conspiracy theorists sometimes claim that these doppelgangers all have identical teeth. That is very clearly not the case. Lastly, we have astronaut Ellison Onizuka on the left and his brother Claude on the right. And once again, facial recognition has determined that these are different people. This photograph also has a very young Ellison in the background, and it was not trained on any young photos of Ellison, but it detects him just fine despite the age difference. Now, you may have noticed that there's one member of the Challenger crew left out, Gregory Jarvis. I haven't seen a conspiracy theorist present a doppelganger for Gregory, but if they do, facial recognition is already trained on his face and recognizes him just fine, so we'll be able to put that claim to the test if it ever comes up. In conclusion, my deepest condolences are with the families of the deceased astronauts, and my deepest apologies to the ones falsely accused of being the deceased astronauts. I feel I could have done more sooner. I've been wanting to make this video for years, honestly. But Justin's video and his disgusting display at the Brevard County Commission meeting finally pushed me to going out and making this video, despite YouTube's rules against the use of facial recognition software on their platform. If they strike this video, my hope is that it will be uploaded elsewhere, because this is too important to ignore. By that, I mean to say that Justin's video went viral, with lots of conspiracy theorists promoting it, and my concern is that it could inspire additional people to harass those falsely accused of being the deceased astronauts in real life. I don't expect to change Justin's mind, or Whitsitt, or anyone else who's deep into that rabbit hole, but my hope is that this video will help prevent at least one person from falling into that rabbit hole to begin with. Thanks for watching, and until next time, clear skies.
Guess what a flat earther did? If you guessed that they found something that totally confirms the Earth is a globe, you guessed right. Ben, who runs the YouTube channel Taboo Conspiracy, thinks that the Earth is flat. Ben also regularly posts videos unwittingly debunking Flat Earth. Recently, he posted a video claiming that the island of Crete was visible from Israel, but it was just clouds. I pointed out that his video debunked Flat Earth at least 7 times. He later deleted his video. Then he posted a video claiming that you could see the peaks of the Alps from Wales over 700 miles away. Before I could even respond, several other people pointed out that the angular positions of the claimed mountains were all wrong. They were just clouds. Again, he later deleted that video. Now Ben claims that photographs taken from the cockpit of an airplane don't match globe predictions. I predict Ben will delete that video too. Ben starts out by showing that he doesn't quite understand the dynamics of flight. No surprise for a flat earther.
If we lived on a ball, it's axiomatic that all aircraft must continually dip their noses to account for the curvature of the Earth. If a commercial airline flies at 575 miles per hour, in just 10 minutes of flight, the airplane would have to drop approximately 6,123 feet to maintain level flight. That's a huge adjustment.
Simple geometry is not Ben's strength. Any middle schooler that successfully completed 8th grade science and math can correct Ben here. In order to maintain level flight on a globe, the plane needs to drop exactly 0 feet. Level flight means not changing elevation. Dropping means changing elevation. There is an orientation change that happens to the plane, as Ben's diagram shows. Even his diagram, though, shows that the elevation from the surface does not change. Ben goes on to ramble for a while, showing more of his lack of understanding of flight dynamics. Despite his incorrect terminology about dipping the nose, I will agree that the orientation of the plane must vary during the flight.
What I do want to discuss is whether there is any evidence that the airplane does indeed adjust its nose downward to account for the curvature of the Earth, as it must if we lived on a ball. Because if there is no downward curvature adjustment during flight, then there is no globe.
I agree. That's a great hypothesis. Another great hypothesis is if there is a downward curvature adjustment or change in orientation during flight, then there is no flat Earth. I asked Ben if he agrees with my hypothesis in a comment on the video he posted, as well as sending him an email specifically asking for a direct answer to this question. Ben rejected my hypothesis testing flat Earth. What was his reasoning? He didn't give a reason. Instead, happily stating that he knows that there is a south celestial pole and that there is an angle change. He says this is a mystery for flat Earth. Really? A mystery? And you're happy with this instead of applying the same standard to flat Earth that you apply to the globe. This is an example of the third law of Flurf. Flurfs are pseudoscientists when evaluating flat Earth and science deniers when evaluating globe evidence. No exceptions. In an unexpected twist, Ben comes around and offers a hypothesis that he accepts. However, if you could use an attitude indicator to show both a curvature adjustment and axial rotation, then I would seriously consider that evidence, because this is still a huge flat Earth proof for me. Ben, I accept this hypothesis and endeavor to test it using your video. Let's see how Ben intends to test his initial hypothesis.
But there is another way to make this determination. The stars. We are going to analyze an amazing time-lapse filmed by a pilot on a flight from Munich, Germany to Sao Paulo, Brazil. You can find the unedited version on this website. Please note that this Beyond Clouds website has no association with the flat Earth, which means this evidence comes from an unbiased party. The distance for the full flight from Munich to Sao Paulo is over 6,000 miles, but the recording was only for approximately 3,000 miles. That begins before Palma, located on the island of Mallorca, Spain, and the video ends before the equator after the plane passes Dakar, Senegal, on the western coast of Africa.
This is a great way to test the hypothesis. Before I get into that, we need to appreciate the standard FLIRF process of focusing so much on their imagined globe debunk that they wind up confirming the globe in multiple other ways, like showing the flight route. On Flat Earth, the route would go over France to the Bay of Biscay, just brushing past the north coast of Spain, then over the Atlantic Ocean for most of the rest of the flight. But what did the flight actually do? It skirted the south edge of France and Spain, then over a good section of Africa. That matches a great circle route. You know, the route you would fly on a globe.
Oops.
Secondly, Ben highlights the movement of the stars looking south. When you analyze them, they circle a single center of rotation due south. Ben admits this is a mystery for Flat Earth. It's not a mystery, though. It directly contradicts the necessary observations for a cosmic Tupperware lid, rotating above a moldy dirt pizza. It is required that the stars move laterally when looking south on Pizza Planet.
Oops.
Third, in this video and his follow-up video, the path traced by the stars looking both north and south is a circle, not an ellipse. If the Tupperware lid over the festering pizza were rotating with the stars in it, they would form an ellipse everywhere except directly below the center of rotation. The shape of the ellipse must vary based on your distance from the center of rotation. In reality, we observe circular star trails, just as the globe predicts.
Oops.
Fourth, if the dirt pizza was covered with a Tupperware lid, due to the law of perspective, all the stars must be visible all the time. There's nothing in the way to block them. The stars that are farther away would just get mushed together, and they could never be hidden below the horizon when looking over the oceans, particularly from an airplane flying well above the ocean.
Oops.
Okay, Ben debunked Frisbee Terra enough for now. Back to his analysis of the flight.
Of course, some movement of the stars is expected with any time lapse. Keep in mind that when you're in the north and facing southwest, like in this flight, the stars should rotate in a downward slant to the right and clockwise motion, somewhat like this. For this time lapse, we're going to track these two stars. The one on top seems to have a tail of stars that rise up and to the left. It's easy to spot. For brevity, I'm going to speed up the footage. The plane is going to adjust its heading left and right a few times, but try to keep an eye out for those two stars. There are the two stars again. Here they are over on the right side. They have dropped a little, but here they are again. And that's the end of the time lapse. This is the beginning position of the stars. Approximately 3,000 miles later, here is the ending position. As expected, the stars slightly rotated clockwise and dropped slightly. You can even see how the star on top with the tail looks a little bigger and has rotated clockwise. So, what is the problem with this time lapse for the globe? The problem is that the plane has to be dipping its nose to account for the alleged curvature of the Earth.
Great, Ben. I'm completely with you. Keep going.
For simple illustration, if I had a stunning view of the stars at the beginning of my flight, as time progresses and the nose of the plane drops to account for the curvature of the Earth, the stars should appear to rise up like this. In fact, the nose of the airplane is allegedly dropping while the stars, which are somewhat fixed and allegedly separate from the Earth, should appear to rise up if we lived on a ball. But you don't need to believe my illustrations. Fortunately, Google Earth allows us to model this same flight with the stars in the background and shows us exactly what would happen if we lived on a globe. For this Google Earth model, I used our distance of roughly 3,000 miles on the exact same flight route that I showed earlier. I set the altitude at 10,000 meters or 32,800 feet. Remember, this is how the globe should work. Now, watch the stars.
But does Google Earth model the positions of the stars?
Google Earth allows us to model this same flight with the stars in the background.
Ben, Google Earth does not model the positions of the stars over time correctly. If it did, you would have to enter a start date and time and an ending date and time. Google Earth has no place to input this information. It doesn't model the correct star movements. In order to model star positions, you need something that models star positions, like stellarium or starry night, or any of the hundreds of other options that astronomers use. Unfortunately for Ben, I have a friend that is an astronomer. Astronomy Live. He made a video where he astrometrically solved the time-lapse video. He used software that looks at the patterns of stars in each frame to figure out the celestial coordinates of each pixel. He then used a planetarium program that he wrote to show which stars would be visible based on the globe and the plane's flight path. Then he plotted the celestial coordinates from the time-lapse onto his program's sky chart. When plotting the airplane's position throughout the flight, the stars that are visible and their positions are consistent with the globe. Astronomy Live's full video is a great analysis. I have linked it in the YouTube description. Be sure to watch it and tell him in the comments how much you love his video. For this video, I just need to focus on Taboo Conspiracy's hypothesis and the analysis of it. Here's again what Ben said.
For simple illustration, if I had a stunning view of the stars at the beginning of my flight, as time progresses and the nose of the plane drops to account for the curvature of the Earth, the stars should appear to rise up like this. In fact, the nose of the airplane is allegedly dropping while the stars, which are somewhat fixed and allegedly separate from the Earth, should appear to rise up if we lived on a ball.
Since the plane is changing direction several times during the flight and the star field is rotating over time, it's difficult to identify if the stars have appropriately risen, as they must on the globe, just by looking at them on screen. We need a way to isolate their elevation from rotation and the airplane's direction change. This can be done using the visible stars to identify the location of the south celestial pole. Astronomy Live put some frames from the flight into software that identifies stars and overlays the lines of right ascension and declination from the celestial sphere on the screen. This frame from the beginning of the flight identifies the location of the south celestial pole off the screen to the bottom left. This arc near the visible horizon is 50 degrees south declination. Looking at the flight route, the plane is at about 40 degrees north latitude. That is exactly what you would expect on a globe. To determine the axial rotation for Ben's hypothesis, we remember we're looking primarily south, not north. A rotating Tupperware lid must show lateral moving stars when looking south. A globe must show star rotation the opposite direction of looking north. To test this part, I identified these 3 stars that are visible throughout the flight. Then I drew a line on them and put an angelometer, that's a protractor, on screen to measure the angle. It's 26 degrees sloping up to the right. In the frame from the middle of the video, the south celestial pole has moved up significantly. This shows that there is a curvature adjustment, as Ben puts it. The horizon is somewhere around 70 degrees declination. Measuring the angle of the stars, I put the same line on the same 3 stars and I measure an angle of 0 degrees. The stars have rotated clockwise. The video continues flying over Dakar, Senegal, then the Atlantic Ocean for quite some time. In one of the final frames of the video, the position of the south celestial pole is off screen just to the west, showing more curvature adjustment. And the angle of the stars is now 38 degrees sloping down to the right. That's a total of 64 degrees of clockwise rotation. That's the axial rotation Ben mentioned in his hypothesis. We know there's a 15 degree per hour drift on the globe, so this time lapse covered just over 4 hours of time. Let's remember what Ben said at the beginning.
What I do want to discuss is whether there is any evidence that the airplane does indeed adjust its nose downward to account for the curvature of the Earth, as it must if we lived on a ball. Because If there is no downward curvature adjustment during flight, then there is no globe.
This is exactly what we found, Ben. There was a downward curvature adjustment during the flight. Let's examine the additional hypothesis that Ben emailed me. However, if you could use an attitude indicator to show both a curvature adjustment and axial rotation, then I would seriously consider that evidence, because that is still a huge flat Earth proof for me. Ben, when a proper analysis is performed on the video, we find that the nose of the plane is now pointing down relative to its starting position. This is a fantastic attitude indicator. The rotation of the stars is also an attitude indicator confirming axial rotation of the Earth. Ben, I showed exactly what you said you would consider as evidence for the globe. Be sure to subscribe so you can see if Ben will be honest and accept the results of the testing of his own hypothesis.
Some fresh lemon juice with the lemon that's been sitting there for a while and was like going bad. So I thought, yeah, screw that.
Happy Saturday and welcome back to Conspiracy Cats. Yes, please check out Paul Douglas's YouTube channel. Link is in the description. Anybody interested in playing a musical instrument or who already can, you are going to learn so much from him. He's also one of the nicest guys I've ever met and he's a Conspiracy Cat subscriber. Unbelievable. Antonio Subrats has responded to me. My response to him will be out on Tuesday. He's challenged me to answer a series of scientific questions. We're going to get very, very scientific and technical on Tuesday. At the end of this video, we're going to get scientific and technical with a flat earther called Fuck It World, spelt with a PH. He's a nice guy, so I'm going to be very nice and polite with him, which means for the next 5 minutes, it's time to get really daft. So please welcome some of my favourite people on the planet, starting with Del.
Hi there, people.
And it doesn't stop there. Peter and Pete.
But hello. But hello.
Yeah, all right, boys, don't milk it. And if this wasn't exciting enough already, please welcome for his first time on Conspiracy Cats, Flat Earth sensation, D Marble.
All right, what's up, folks?
At least pretend you're excited. Anyway, a couple of weeks ago, I let go a massive fart when I was speaking to allegedly Dave. And I know this is the third week on the trot, but I just want to mention it one more time.
Yet again?
Yeah, sorry, Del. But the reason I've got to mention it is because Peter and Pete got in touch. They were that impressed. And Pete has been practicing his impression of what that fart might have sounded like. Now, I know he's a little bit nervous, but he really wants to do it. Are you ready, Pete?
Now this is the first time that we've actually done this.
Don't worry about it, mate. You don't have to be spot on. Let's hear your impression. No! That is brilliant. D Marble was actually sat next to me when it happened. What did it really sound like?
Loud sucking noise, maybe a whistling sound with all the air rushing out.
Well, I'm not sure about the whistling sound, but definitely you were right about the air rushing out bit.
Air's going to be rushing out, period.
Yeah, okay, don't labour it. Anyway, before the show, we came up with a plan as to what you might be able to do if I was about to fart again.
Look, there's not going to be any sticking a finger in the hole.
All right, I won't make you do it. But Peter, if somebody did do it, can you imagine what that finger might say?
I'm stuck. Can't go anywhere.
I am embarrassed.
Oh, come on, Del. It was a decent enough impression. D Marble, any more thoughts on this?
The whole idea of being able to just plug the hole with your finger, that's like terrible.
All right, fair enough. But as luck would have it, I'm about to fart now, and I don't know what to do.
It's a dangerous situation.
Yeah, it is. Del, any help?
Must be contained.
Right, I'll lock the doors. I'll be back in a second. Okay, now that situation's under control, we're going to continue looking at the idea that the practical demonstrations presented by conspiracy theorists don't really have any scientific substance to them and are often a product of the misunderstanding of the actual heliocentric model. Now, this is something Peter and Pete, as flat earthers themselves, are really, really interested in. What do you say, Pete?
A lot of flat earthers like to have evidence.
Yeah, they do, but the problem is the evidence that we've been seeing, in fact, just in last week's video, looks like this. And this. And And this one's my favourite.
Curved water on a flat surface.
But before we get to a slightly better demonstration with Fuck It World, we've got a new cat in town. Let's check him out.
Hey YouTubers, let's get ready for a science lesson. This recent flooding in Houston has really gotten me thinking about how many people still think the Earth is round.
About 99.9% of the world's population.
Here I have a normal lemon.
Me too.
Now when I pour water, like it's raining, the water just falls off of the lemon.
No, it doesn't. Oh, not again!
Now, I have here a plate. A flat plate.
Ooh, show off.
Now if I pour the water onto the plate, interesting.
Oh, I see where this is going now.
Curved water on a flat surface.
As you can see here, the water pools up. Try me.
I think we'll leave that there.
Conspiracy cats, I don't think you can actually play those guitars, can you?
Listen, pal, I'm about to do some proper science with Fuck It World. I haven't got time for this. Right, that's it. Guitar battle, now. Actually, let's not be hasty. I've got a video to make. I'll see you later, Paul. Alright! Just get some more practice before you're ready to take me on. Now, we're about to get very serious, but before I do, really check out the link for Paul Douglas's channel in the description. He really is the best musician I have met in real life, period. Even Peter and Pete thought so. Check out their reaction while he was doing his stuff.
Cool.
But now it's time for Del, D-Marble and Peter and Pete to go home. We're going to look at Fuck It World. I keep calling him Fuck It World, but it's called Fuck It Word. Sorry. We're going to look at his video and how he tries to distinguish between density and gravity. Now, Fuck It Word I've met numerous times in the comment sections around YouTube. He really is an extremely polite individual. So I hope you don't take this in a disrespectful way, and I'd love to hear a response from you. Let's hear what he's got to say.
Hello, Flat Earth researchers, debaters and debunkers. I'd just like to use this Cartesian diver here to show how gravity based on the mass of the Earth is a complete fallacy, and that we do not even need to consider how things get drawn to the Earth if we are not concerned whether we are on a spinning ball and we might fall off or get spun off. Everything depends on the density and pressure of the element that we are in.
So, a Cartesian diver is a toy that I often make with my Year 7 classes around about Christmas in those Christmassy lessons. And it's a really good model to demonstrate how a submarine actually works and controls its height. But let's see what Fuck It Word does next.
So if I add some pressure to the bottle by squeezing it, what will happen is the lid goes down. Alright? Yeah? It wasn't suddenly affected by gravity, it was just a change in the pressure around it and the equilibrium of the two being put out of balance. So if I release the pressure again, it rises up. Okay, so it's all to do with the amount of space that the medium is taking up, its volume, and the volume of the air inside here, and the density of the different mediums and the object.
Okay, so Fuck It Word. Again, please take this in the respectful tone it's meant. You are taking the Nathan Oakley route of looking at an independent variable, a dependent variable, and then there is your conclusion without asking any further questions. So here, your independent variable is increasing the pressure and therefore the density of the Cartesian diver, and we'll look at that science in a minute. Your dependent variable is the movement of the Cartesian diver, and the conclusion you're drawing is that as I increase the density, the Cartesian diver falls, therefore no need for gravity.
Okay, so we can also make a new equilibrium where we have the lid kind of halfway. If I just adjust the pressure a little bit, we can keep it suspended there. Okay, all right. So of course this is by me artificially adjusting the density, because I've slightly reduced the volume that the water takes up and put it under more pressure. Okay, so the same thing happens in the air.
Okay, so let's look at the science we agree on before we talk about the science we disagree on. We agree that a Cartesian diver is a little device that has some air trapped inside it. Now, when you squeeze the bottle and you increase the pressure, some of the water is forced inside the Cartesian diver, and that compresses the air inside. So now we have the Cartesian diver with the air that it had before, plus an extra bit of water that's been forced inside it by the pressure. What that does is that increases the mass of the Cartesian diver. Now, density is mass divided by volume. So if I increase the mass of that diver, of that volume, I'm going to increase the density. And a Cartesian diver works because when you set it up, the density is only a little bit more dense than the density of water. So just squeezing it a little bit and putting a little bit of water in very easily makes it more dense than the water, and the water and the Cartesian diver sinks. That's the science that we agree on. So what we actually disagree on is when you stop asking why. You've seen an increase in density causes the object to fall, and you've stopped asking why. Let me give you an analogy. If I knew a 400-pound, 3-foot tall woman, morbidly obese, if she said to me, I've started losing weight since I went up to 10 meals a day, I wouldn't draw the conclusion that eating more meals a day would lose weight. I'd ask why. And then when I did that little bit of research, I might find out that the 10 meals a day she was eating was all salad and fruit. And then I'd be questioning, well, it's not the number of meals, maybe it's the amount of calories you're taking a day, etc. You're not asking that question. Now, to delve into this a little bit further, into your thought process, I've brought up another video of yours. Here it is.
Hello, Flat Earth researchers, debaters and debunkers. We're told that this object falling to the ground is because of gravity, and I'd like to try and explain how that is a complete fallacy.
Okay, we're listening.
Let's just say this is 1 kilogram, and it's said to have a force of 1 kilogram of force, which is 10 newtons of force. So all of a sudden this 1 kilogram object becomes 10 newtons, and it's apparently exerting a force just to be resting on this table.
Okay, I'm listening, but that isn't an apparent force. If you were to put that on your head, you would feel it. You know, it is real.
But it's just 1 kilogram. Whatever mass it has, in whatever volume or density it is, makes its weight. You don't need to talk about its mass, and you don't need to talk about its mass being pulled or pushed towards the Earth by some force.
But that's just it. You can't move something without applying a force to it. You know, I'm not a Jedi Knight. I can't look at something and make it just move. If I put an elephant on my head, it is going to move towards the Earth and it's going to crush me. But what is making something the size of an elephant move if it's not a force? How can an elephant be forced to move without a force making it? It doesn't make sense.
Some external force apart from the object's own weight.
And at this point, I'd love to ask, what do you think actually makes weight a force? Something doesn't have a weight unless it's trying to move down on those weighing scales. You know, or that elephant I was talking about trying to move down on my head. What makes those things move? What actually is it that gives them weight? This is where you're stopping to ask the question, why? Right? Why do those objects move?
And then with this idea that we're spinning, we have to have a way that we stick on the earth despite our weight.
Again, you just seem to be dismissing this whole idea. What gives us our weight? Why does weight make us move? You can't just say, oh, our weight is why we stay on the ground, therefore we don't need gravity. It doesn't make any sense.
So, what's giving this can of mackerel its potential energy right there on the floor, on the desktop?
Okay, it sounds like you're now going to address the question I've been asking.
Energy is required, often in the form of a force, to lift an object, to give it that potential energy that it will have when it's dropped. Hence the sound and possibly a dent in the table or the can if the towel wasn't there. Extra force has been applied by lifting it up into the air. But once it has done its job and hit the floor or settled in a state of rest, there is no more force happening on the can. It is just weighing what the can weighs.
Okay, so this is where I'm going to stop the video because we've got to the point where we're raising more questions than we're actually answering. You've just told me if I pick something up and let go, it falls because I've put energy into it as I've lifted it up. So therefore that energy is going to return it to its starting point. But you're not explaining why if I move something to the left or right or forward or backwards, why doesn't it leap back to the starting point then? I'm still putting energy into it. Why is there this directional component? Now you'll probably answer, well, it's density. If I move something up, there's a density difference, which debunks the energy comment you've just made. But if we look at the density difference, then let's ask another question, why? Why do objects of different densities, different sizes and masses, why do they fall in a vacuum chamber at the same speed? And in fact, why do they even accelerate in a vacuum chamber? Where does that acceleration come from? You see, you've adopted a very simplistic model that answers very little questions and stops you asking the questions why. Whereas the heliocentric model answers all these questions. There are no questions that can't be answered by the heliocentric model. Whereas the flat earth model has so many questions that just can't be answered. Star trails, moon phases, SP and surface waves from an earthquake, they're off the top of my head. You can't answer so many questions with a flat earth model, yet the heliocentric model answers everything. You seem like an intelligent guy and I'd love a response. This isn't a dig at you, it's a reaching out, if you like, for a bit of dialogue. Now, Tuesday I will be responding to Antonio Subirats, but before that, please, to play out the show is Paul Douglas with his own piece, and it's absolutely fantastic. Again, if you're a musician or into music in any way, please check out his channel. It's in the description and subscribe. See you Tuesday.
I'm knackered.
Hey guys, today we're going to be discussing a video I came across by Flat Earth Neurotard Nathan Thompson. In this video, Nathan Thompson attempts to provide proof that the Earth is flat while bouncing a golf ball on a sledgehammer. I believe it's worth noting that Mr. Thompson is the founder of the official Flat Earth and Globe discussion page on Facebook. With 88,000 members and this video having 21,000 views, how is it that you only have 470 likes and about 870 dislikes? Either flat earthers have stopped believing you or you are an idiot.
Strength, intuition, to keep the ball on top of the sledgehammer. Alright, here we go. Alright, astrolabes prove flat Earth because on a globe everything's supposed to be spinning and orbiting around in space and we wouldn't see the same thing year after year.
So I can count 3 problems with his first argument already. 1. Nathan Thompson does not understand how humongous the universe actually is. Alpha Centauri, which is the star nearest to our sun, is over 4 light years away, and each light year is almost 6 trillion miles long. At these distances, to measure an observable difference in direction, you would not only need an advanced degree in astronomy, but you would also need powerful and precise equipment. And astronomers have been using powerful and precise equipment to make these observations for decades. 2. The size of the Earth's orbit when compared to the size of the entire Milky Way galaxy is minuscule and therefore would not result in any additional apparent motion of stars throughout the sky. It should be noted that the orbit of the Earth around the Sun is directly responsible for stellar parallax though. And 3. The year-to-year timescale at which you're comparing your observations is simply too small. You would need centuries, if not millennia, of observations to notice an observable change in motion. Nathan Thompson, you are an idiot.
Compasses prove the Earth is flat because you have to hold them flat for them to work. A compass in the southern hemisphere would actually be pointing off into outer space, not at the North Pole, so I don't know how that works.
Well, at least you can admit that you don't know what you're talking about when it comes to compasses, because you are wrong on both accounts. Number 1, not every compass needs to be held perfectly level to get it to work. Global needles, for instance, can be tilted up to 20 degrees and still point to the North or South Poles. Number 2, compasses that work in the northern hemisphere only work in the northern hemisphere, and compasses that work in the southern hemisphere only work in the southern hemisphere. If you are going to be making scientific claims about the functionality of compasses, I suggest you do your research because you are an idiot.
We'll go with a really simple one. Water has no convexity. Water's flat. Bedford level proves that.
The Bedford level experiment is a staple to any flat earther's argument. This experiment was conducted by Samuel Rowbotham around 1838. In this experiment, Mr. Rowbotham had his friend paddle down the Bedford River 6 miles. The Bedford River is a completely flat river, and according to globe Earth calculations, there should have been an observed drop of approximately 24 feet due to the curvature of the Earth. Mr. Rowbotham could see his friend and the rowboat in its entirety. Therefore, Mr. Rowbotham concluded that the Earth must be flat. However, Mr. Rowbotham did not take into account atmospheric refraction. When taking into account atmospheric refraction, it is not only possible on a globe Earth, but it is proof for a globe Earth. You, my friend, are an idiot.
The laser experiments that I've been seeing prove that. Sight distances prove that. The fact you can zoom in on ships that have gone in past the horizon, that proves that water's flat. So
Yeah, well maybe you can explain why you or no other flat earther ever has gone out to the beach with a telescope and observed a ship going 50 miles out to sea. This observation should be cheap and easy to make and would 100% debunk the globe Earth model. However, due to the Earth being a globe, there is a point at which an object will travel that no telescope, no matter how strong it zoom in, can pull it back into view because it has traversed the horizon. Mr. Thompson, you are an idiot.
Also, corpuscular rays from the sun prove the sun is close and not 93 million miles away.
Actually, corpuscular rays do not prove the distance of the sun whatsoever. All rays of light, by nature, will appear to an observer to move parallel to one another. Due to perspective, these rays will appear to diverge from one point as they approach an observer and converge to a similar point as they leave an observer. This is completely due to perspective and has nothing to do with the distance of the sun from the observer. You are an idiot.
The drastic variations in temperatures throughout the day, from sunrise to high noon to sunset, whew, those are difficult.
Like most flat earthers and most flat earth arguments, you're only about 10% right. While the presence of sunlight is generally responsible for the differences in daytime versus nighttime temperatures, local temperature conditions are affected more by atmospheric conditions around them. That's why if a wind current from the north blows in, it all of a sudden feels cold. So I'm not going to call you an idiot because you're not educated on weather phenomenon, but since you acted like you were, you are an idiot.
Another proof the Earth is flat is they throw it in our face with the UN logo. Boom, divided into 33 sections.
I'm not going to spend a lot of time disproving this claim. The UN's logo is simply a two-dimensional representation of the three-dimensional globe Earth. What I will say is that if the shape of the Earth is the greatest secret and the greatest lie ever told to the human population, then why would the world's largest international organization use it for its logo? You and flat earthers are idiots.
Another proof the Earth is flat is, alright, star trails. Star trails have no progressive motion through space.
We covered this one earlier in the video. The stars are simply too far away and you don't have enough time to make comparable measurements to observe progressive motion of stars.
So, what else we got? Another proof the Earth is flat is airplanes. They don't adjust for curvature.
Airplanes don't have to adjust for curvature. Thank you, gravity.
So the FAA trains pilots on what's called a TGF. It's a target generation facility. The TGF is a flat Earth simulator they spent millions of dollars to develop. And it also states in the software that there is no accounting for gravity or the Earth's spin.
I must admit, before debunking this video, I had no idea what the Target Generation Facility, or TGF, actually was. However, after doing a little bit of research, I have found out that the TGF is in no way a flat Earth simulator. It is actually a two-dimensional representation of objects flying through a three-dimensional space, and is not used by the FAA to train pilots, but is used by the FAA to train air traffic controllers. And since it is simply a simulation, there is no need to take into account gravity or the rotation of the Earth. You are an idiot.
So the Earth's stationary. That's another proof Earth's not a spinning ball, is the Earth's stationary. Every test ever performed and everything you can see with your eyes confirms that. Michelson-Morley proved that we're not moving through space. Sagnac proved that, we're not moving through space. Airy's failure proved we're not moving through space. That's why it's a failure.
All three experiments that you have provided as proof for a flat and stationary Earth all failed due to one key aspect: the assumption that an ether was not only present, but absolutely necessary for light to travel through. And Einstein disproved this theory with his paper on special relativity. In fact, not even one of those three experiments were even designed to test if the Earth is flat or not. You are an idiot.
Here's another one, a really big one. The marine horizon is always flat and rises to eye level. How about that?
Catch me outside, how about that?
Actually, you're factually incorrect. Most smartphones have access to theodolite apps that can accurately measure the drop in horizon with the increase in elevation on an airplane. It is because of this fact alone that most intelligent flat earthers, if there are such things, have completely abandoned the horizon rising to eye level argument. However, you are an idiot.
Sight distances on land prove the Earth is flat. So if you stand on the other side of Lake Michigan, you can see the Chicago skyline when the entire thing should be underwater. Not a portion of it, the entire thing.
The only problem that I see with your argument here is that you are not taking into account atmospheric conditions that lead to atmospheric refraction and reflection. This is completely why sight distances, especially over water, are completely dependent upon the atmospheric conditions when the observations are made.
What else we got? Another thing, all the NASA astronauts are Freemasons and liars.
According to multiple online sources, of the 536 people that have been to space, only 7 have actually been Freemasons, and another 5 had fathers who were Freemasons. Even if I give you all 12 of those astronauts as having direct ties to Freemasons, that still only accounts for 2.2% of all the people that have been to space. You are a liar and an idiot.
They all take blood oaths to lie to you guys, and then you defend them on the internet when I confront them at Starbucks like a fool.
Yeah, well, most honest people do not appreciate an uneducated, unintelligent, dishonest, disingenuous jackass like yourself maliciously confronting a NASA employee while he's at Starbucks getting his coffee about the lies of which you have no proof even exist. Nathan, you are an idiot.
Oh yeah, occult pendulum. Occult pendulum? Now please, tell me, if a pendulum that proves the Earth is spinning, if that's proof the Earth is spinning, how come anything that's hanging doesn't start doing one of these mothers right here? Anything hanging, if occult pendulum proves spinning Earth, should be doing one of those.
Foucault's pendulum was a device invented by Léon Foucault at the Paris Observatory in 1851. The pendulum was designed to accurately and repeatedly demonstrate the rotation of the Earth. The engineering design of the pendulum allows it to swing freely without any force interference due to this rotation. So when constructed properly, a free-swinging pendulum will also precess 360 degrees over the length of a day. However, any application of any force to the pendulum will alter its motion along with its precession. Do you really think that by hanging a sledgehammer from your hand, you are actually recreating the Foucault pendulum experiment? You are an idiot.
Another proof the Earth is flat is you don't get heavier the farther away you go from the equator. So if Earth's a spinning ball, centrifugal force is still a thing. The spinning ball Earth is going to be attempting to hurl you off. I know we have, magic pseudoscience gravity, but even if gravity were real, as you leave the equator, you should get heavier and heavier and heavier. Same way if you're on a merry-go-round and you're going around the outside, and then you move towards the inside, you're going to notice less and less centrifugal force, or less and less outward pull. So that's another proof the Earth's flat.
Actually, Mr. Thompson, you are almost correct here, but like most flat Earth scientists, you've made some pretty big assumptions instead of doing some fairly easy calculations. As you get further away from the equator, you travel less linear distance in the same amount of time as someone who is on the equator. These differences in latitudes directly result in a difference of centrifugal forces. So let's calculate these differences ourselves. You look like you weigh about 50 kilograms, so we'll use that to estimate the change in weight from the equator to 1 degree south of the North Pole. Given that the gravitational pull is fairly consistent around the globe with minor measurable differences in certain places, we can assert that the gravitational force acting upon you would be approximately 490.33 newtons everywhere on the planet. The centrifugal force trying to throw you off varies at different latitudes due to the linear velocity slowing down to 0 as it approaches the pole in either direction. The linear velocity at any latitude can be calculated as follows: 2 pi times the radius of the Earth times the cosine of the latitude divided by the number of seconds in a day. For our example, your linear velocity at 89 degrees north latitude would be approximately 26.49 meters per second, and your linear velocity at the equator would be approximately 463 meters per second. Calculating for centrifugal force is easy. It's simply the mass of an object times its linear velocity squared divided by the circumference of the Earth. At the equator, you have a centrifugal force of approximately 1.681 newtons pushing you outwards, and at 89 degrees north, you have a centrifugal force of approximately 0.006 newtons acting against gravity. Can you see a problem with your argument yet? While the centrifugal force is 1.7 newtons at the equator, there is 490.33 newtons of gravitational force pulling you down. Calculating further, we can determine that you at 89 degrees north would weigh 1.003 times your weight at the equator. In other words, if you weigh 50 kilograms at the equator, at 89 degrees north, you would only weigh 50.17 kilograms. You really should math check yourself before making these wild assertions because you look like an idiot.
So yeah, pictures from space. They're all fake, so that's cool. Can't find a legit one.
The fake pictures from space argument is probably the most idiotic claim that all flat earthers consistently make. First, most pictures of Earth are taken from low Earth orbit and aren't far enough away to make a complete photo of the entire globe in one snapshot. For those pictures, a complete Earth is created using composites of actual photographs. This method sometimes results in patches of the Earth that unfortunately don't get pictured. Space agencies do their best to make up for these small errors, but in general, the photograph is legitimate. Second, even if you were presented with an actual photo of the globe Earth, like for instance the Japanese Himawari 8 satellite that takes a full globe Earth picture every 10 minutes that is 100% verifiable with local weather patterns, you would not accept it. Flat earthers are known for their selective acceptance of observable evidence because flat earthers are idiots.
Countries, I don't even care if you say, oh, how would you know what a real picture looks like? The countries are changing sizes, guys. United States is this big in one picture and it's this big in another picture. That doesn't make any sense, okay?
Well, obviously, when an object moves towards or away from an observer, they change in apparent size due to perspective. Compound that with the fact that the objects are also on a spinning globe, and then really confuse your observations by taking the photo from different cameras at different distances and at different times, and you will obviously notice a considerable difference in their apparent size. What doesn't make sense is that flat earthers like yourself prescribe perspective when an observation supports their claim, but willfully ignores perspective when it contradicts their belief. Nathan Thompson, you are intellectually dishonest and you are an idiot.
Marine snipers do not adjust for the Coriolis effect. Miguel Michael Angel can confirm that. He posted his exit paperwork from the military yesterday.
The Coriolis effect on a sniper's accuracy is very minute and considered intangible on shots of less than 1 kilometer. However, shots of over 1 kilometer in distance will be affected slightly by the rotation of the Earth. The Coriolis effect is most notable on weather patterns, as all hurricanes in the northern hemisphere rotate counterclockwise and all hurricanes in the southern hemisphere rotate clockwise.
Rex Harrison is a Marine sniper and a stuntman. When he shoots a bullet or he jumps out of a moving car, he does not adjust for the Coriolis.
Wait, what the? Did you just say that a stuntman jumping out of a car and not having to adjust for the Coriolis effect is actual proof of a flat Earth? You are an idiot.
So, all the physicists can tell you, if Earth was a spinning ball orbiting around the sun, we would have 3 types of angular momentum. So,
while actual physicists will agree with you that all 3 forces of angular momentum should be felt, only YouTube physicists will agree that this is actual proof of no cosmic motion and a flat Earth. You are an idiot. So we're going to end this video on this argument right here. And if you stayed till the end, I truly appreciate it. Because Nathan Thompson is an idiot. I'd like to take the time out to thank Nathan Thompson, his little sledgehammer, and tiny golf ball for this moderately tolerable video he provided for me to debunk. Every time you put out another ignorant flat earth video, you will be watching over your shoulders, waiting for me to debunk it, because Nathan Thompson, you are an idiot. I'm Father Skeptic, and I'm out.
Hello again, lovely viewer. In the last part, we saw how flatards can't even get basic naked eye observations of the positions of the stars right, and how they think the sun is a flying spotlight. We also saw how, as with the stars, flatards can't get the altitude angle of the sun right either, nor where it rises and sets at the equinoxes. In quantifying their altitude angle errors for solar noon at the equinoxes, we also found that maths itself offers striking clues as to which orifice flatards get most of their ideas from. In this part, we're continuing our examination of the flying spotlight idea, which flatards seem to think is plausible due to a crippling lack of basic mental faculties. Let's go. So we looked at the flatard flying spotlight circling above the flat Earth using the equinoxes as an example. But what about the solstices? At the June solstice, the sun reaches its most northerly angle for all observers, giving the longest summer day for northern observers at mid-latitudes and the shortest winter day for those in the southern hemisphere. At the December solstice, the opposite is the case. You don't need to be told why, but flatards do, so let's run through it. At each solstice, Earth's rotational axis is aligned towards the sun. Since the tilt of said axis is 23.44 degrees to the orbital plane, the most northerly latitude at which the sun can be overhead is 23.44 degrees, being the Tropic of Cancer. And if flatards have been paying attention, they'll be unsurprised to hear that this occurs at the June solstice. Correspondingly, the most southerly latitude at which the sun can be overhead is 23.44 degrees south, and we're unsurprised, even though flatards may be baffled, to hear that this occurs at the December solstice. A simple conclusion arises from this. At the December solstice, everyone outside the Arctic and Antarctic circles can record the noonday sun at an altitude angle appropriate to their latitude. 6 months later at the June solstice, they can do the same. The difference will be 46.88 degrees. But what should happen on a giant communion wafer created by a pan-dimensional thaumaturgist and illuminated by a flying spotlight if its inhabitants were to try this simple observation? Well, let's find out. They'll have to agree that the most northern and southern latitudes at which the sun can be directly overhead are the tropics of Cancer and Capricorn. And they've told us that their flying spotlight is 3,000 miles, or 4,800 kilometers, above their space biscuit. First up, we'll need to know how far away the tropics are from the equator, so we know where the sun will be overhead at the solstices. As we found last time, the distance from the poles to the equator is basically 10,000 kilometers. We divide that by 90 for each degree of latitude on the flat Earth and multiply by 23.44. For flatards, the tropics, then, are 2,604 kilometers from the equator. Our equatorial observer will see the December solstice sun 4,800 kilometers above the Tropic of Capricorn, 2,604 kilometers away. The alert among you will already see that this isn't going to end well. Using our old chum the tangent formula, we find that Mr. Flatard should see the noon sun 61.5 degrees above his horizon, or 28.5 degrees from his zenith. This is already wrong, as we know that he should see the sun 23.44 degrees from his zenith. Since the Tropic of Cancer is the same distance from the equator, our feckless flatard will also see the June solstice 28.5 degrees north of his zenith. So the angular difference between his observations should be 57 degrees, rather than the 46.88 that reality prefers. We don't need to do any more to show that flatards are imbeciles, but if you're going to do a job, you should do it properly. Let's calculate the angular difference flatards should expect to see for every degree of latitude on their space pizza. We use the tangent formula every time. The only thing to watch out for is that between the tropics the angular difference is the sum of the angles from the zenith, and beyond the tropics the angle is simply the difference in altitude angles. Don't blame me, blame the flatards. Crunch the numbers and we end up with this graph. Now would be a good time to remind ourselves that in reality, wherever you are, the difference is always 46.88 degrees. So let's add reality to the graph. Oops. Nobody familiar with tangents of angles, which is simply the ratio of the opposite and adjacent sides of the triangle, should be surprised at this. It can never give a straight line. It is simply fundamentally impossible for the flat Earth to match what is really observed. The explanation favoured by those of us who aren't wedded to their conspiratorial insanity is that Earth isn't flat, and that the very idea is complete bollocks. Let's go back to an equinox. We saw in the last part that to match basic observations of sunrise and sunset at equinoxes, the flat-width flying spotlight must create an illuminated area that nicely divides the flat Earth in half. This immediately tells us that the flat-arc flying spotlight has a lampshade. The equinoxes only happen twice a year, and strictly aren't days, but moments in time when the sun crosses the celestial equator, which is why day and night aren't quite of equal lengths on the equinoxes. For the purposes of this discussion, that simply doesn't matter. There will be 2 times per year when the flying spotlight has to illuminate Earth this way. Every day, though, it's daylight for essentially half Earth's surface and night for the rest. That leaves us with the question of what the flatard flying spotlight does for the rest of the year. Let's start with the June solstice. We've already seen that at this time the sun appears furthest north of the celestial equator. Due to Earth's tilt being 23.44 degrees, everywhere north of the Arctic Circle will have 24 hours of sunlight. The North Pole will be halfway through its 6 months of constant daylight, and locations on the Arctic Circle will be getting their only day of 24-hour sunlight. On the opposite side of the world, locations in the Antarctic Circle get their only day where the sun doesn't rise, and the South Pole will be halfway through its 6 months of darkness. On a spheroid, these things are easy to understand. Half of Earth is illuminated, half isn't. What does this illuminated area look like on a turtle-mounted space pizza, though? Let's unwrap a spheroid illuminated per the June solstice back out onto a flat Earth and see where night and day are. It's clearly different to the half-and-half illumination of the equinoxes that we looked at earlier. What does this mean for flatwidths? It can only mean one thing. The flatard flying spotlight's lampshade changes shape. For day lengths at different latitudes to match reality, this is the way the giant frisbee flatards think we live on would have to be illuminated. The magic lampshade changes shape to give us the changing seasons because reasons. Inscrutable reasons. Hey! As the June solstice passes, the lampshade returns to its equinox shape over the next 3 months, and then for another 3 months the sun heads south until we get to the December solstice. In reality, this is dead simple to understand because on the other side of Earth's orbit, its axis is facing the other way to the incident sunlight, so we have the opposite situation to the June solstice. This of course means that everywhere south of the Antarctic Circle has 24 hours of daylight, and the South Pole is halfway through its 6 months of continuous daylight. So let's watch the change in illumination from the September equinox to the December solstice on a flat Earth. You can see where this is going. It presents a problem for flatards because for them, the far south is a ring around their king-size god biscuit. That means that a single light source has to illuminate this ring thanks to the magic shape-shifting lampshade. Naturally, flatards have an explanation for this, and by explanation I mean a haphazard collection of blustering expressions of outright denial. They claim there is no 24-hour sun in the far south. Quite how they know this is still unknown because, according to them, nobody can go there, and since none of them have left their trailer parks, they haven't been there either. But they know there is no 24-hour daylight in Antarctica because reasons. If there really were no days in the year with 24 hours of daylight south of the Antarctic Circle, that leaves flatards fumbling to explain another aspect of their special little terrarium. How exactly does the flatard flying spotlight, with its magic lampshade, illuminate Earth between the September and March equinoxes? And what specifically happens when the sun is directly overhead the Tropic of Capricorn at the December solstice? Well, this is where they reach for their special pleading playbook, whilst pretending that ad hoc explanations have any value whatsoever. What they need to do is pull their fingers out of their arses and present a coherent physical model that explains the existence of a flying spotlight with a shape-shifting lampshade in the first place. It needs to be one that always produces a pattern of illumination, and hence sunrise and sunset times, at all locations on Earth and at all times of the year, that, by sheer god-bothering coincidence, are exactly what you'd expect from a spheroidal Earth with an axial tilt in orbit around the Sun. A simple system that any sky wizard worth its salt would have made in the first place.
Hey!
Until they have a model that can make the kinds of predictions that the rest of humanity has been capable of for centuries, there is no reason whatsoever to conclude that the idea of Earth being flat is anything other than delusional bollocks. In the next episode, we'll look at more ways that the idea of a magical flying spotlight doesn't hold up to basic scrutiny, as if being reliant on a magic flying spotlight wasn't enough of a clue in that regard in the first place. See you then.
Help me, Superman, help me! I'll save you. Wait, you can't fly. What about gravity? Oh no.
Maybe tomorrow I wanna settle down. Until tomorrow I'll just keep moving on. Ba-da-ba-da-ba.
Welcome back, and we will start straight off the bat with Chatbox Travels. Do you remember last week when we made a video where we said rockets can definitely fly in the vacuum of space? David Ray didn't believe that. Watch.
My name is David Ray, and I'm really smug when I'm on Facebook.
Yes, David Ray had obviously done hours of research. And he found this equation about rockets. Same joke 2 weeks running. This equation tells us the force of thrust that a rocket will feel. And in that equation, we have these two letters, PO. Now, David Ray Googled and found out that PO meant the pressure of the medium the rocket was in. And he said, well, why is that in the equation? If we're flying in a vacuum, then PO should be 0. So therefore, rockets can't fly in a vacuum. I would say to you, David Ray, let's improve your maths. Let's say PE is 10 and PE, or PO, is 0. Then 10 minus 0 gives me 10. Woo! Looks like the equation does work. Thank God for that.
My name is Captain Wes Starwind, and I'm one of Conspiracy Cat's favourite subscribers. Here he is to tell you why.
That's right. Now, not only is he a regular commenter, but his comments are always interesting, sensible, and in this particular instance, very, very useful. You see, he sent me a link that takes me to a video where we can actually see a rocket working in a vacuum. Now, what I did when I saw that video is I actually clicked on a link in the suggested videos next to it, and that's the video I'm going to use. But you still get the credit. Thank you very much. Roll the tape.
Whoa!
Okay, so Action Lab is definitely one of, if not the best channel on YouTube. What the man's done here is he's taken a can of fizzy drink and he's suspended it in a chamber as he's sucked all the air out and created a vacuum. When he's done that, the can isn't able to handle the pressure and the can explodes. Now that acts like a rocket because when it explodes, and the liquid comes out one end, the change in momentum I talked about last week forces the can in the opposite direction. Now, if conspiracy theories are correct, the rocket, or the can in this case, should only move when the lemonade or the pop or whatever touches the side of the container and has something to push off. But he recorded this in slow motion. Let's see what he found. I wonder if he found rockets can work in a vacuum.
See the can moving back and forth? I'm toggling back and forth between frames. But the liquid is still contained right here. The wall's clear over here. So you can see it moves before any of the liquid, which means any of the expanding gas in the liquid, has even hit the wall.
In your face, David Ray. But at least you brought some sort of argument. Not like this guy.
I just stopped off to tell you, your videos are shit.
Thanks, Dad.
Maybe tomorrow I wanna settle down. Until tomorrow I'll just keep moving on. Ba-da-ba-da-ba.
Now, before we move on to the main event of this video, any regular contributors to my comment section will know that we have been spammed ridiculous for the past couple of weeks by this guy.
Nathan Oakley.
So, for those who don't know, this man hosts a really boring show every day where he talks about the flat earth and shows us his scientific ignorance, like his inability to convert kilometres to metres, for example, and I'm not even joking. Check out one of my previous videos. Now, when I went on his show, he decided he was going to hit the mute button, not let me speak, and start screaming over me. So I left immediately, made a response, and this is what he left on my channel.
Please don't take my mute button away from me, please. I love it.
So, if you pause that and actually read it, and I recommend you do because it is brilliant, then you might be surprised to hear that after only 2 weeks, he's given up and he's ran away.
I've unsubscribed because you're not giving me the attention I crave and I'm losing subscribers and my channel's shit.
So, Nathan, in the message you sent me, you sounded so brave and fierce, and it seems like you've all given up. Can I ask, what are you really scared of?
I'm not gonna lie, these steps are terrifying.
Is there anything else that terrifies you, pal?
Pirate ships and barrels.
Anything else?
A medieval fridge.
Well, I can see you've got some issues. When you're willing to step away from that mute button, let me know, pal. Now, before we get into the serious stuff, have you got one last comment?
We live on a ball and boats go over the horizon.
The serious stuff! Oh man, I should be a singer. I'm amazing.
Called Sink or Float. There's 3 different sections on here. And what the child would do is they would take an object and either draw in what the object is or write the name in or do both and then see if it sinks or float. And
so now we're going to get on with the main event, which is comparing primary school, really young child science with flat earth science. We're going to start here. This is what children look at maybe when they're 6 years old. It's a floating and sinking experiment. The lady's already described what she's going to do. She's going to put an object in the water and see if it floats or sinks. Let's watch.
a rock, so you'd put that in, just kind of gently drop it in to see if it sinks or floats. And this one sinks. Foam block, does it sink or float?
So as an adult looking at that investigation, you could be forgiven for thinking, well, it's incredibly simple and incredibly pointless. But as a 5 or 6 year old child, somebody who's mentally developing as a 5 or 6 year old child, you might be forgiven for thinking that that rock sinks just because it's heavy. That's the kind of thinking a 5 or 6 year old would have. But then as a teacher, you coax them and you say, well, okay, the rock is heavy, but so is a big boat. The big boat is heavier than the rock. And then the child starts to dig a little bit deeper and ask, well, why does the rock sink if the boat doesn't? And it's about getting the children to ask the question why. Let's have a look at the next experiment. So this is the famous flat earth gravity debunking egg in salt water experiment, where we find that if we put an egg in liquids of different concentrations of salt, it will float at different places. And we use this for 7-year-old children So they can understand that floating and sinking just isn't about the object that's in the water, it's about the liquid itself, it's about the medium itself. And we start to introduce the idea of density. We don't expect them to understand what density is, but we start to introduce that idea. And we always encourage them to ask that question, why? Why does density affect how something floats? But then we move on to something else. So here's the next stage up. So maybe we're 8 years old now, maybe 8.5. And we see raisins put in lemonade and they are bouncing up and down. And we know deep down that the raisin is more dense than the lemonade, but sometimes it floats and sometimes it sinks. And maybe we ask that child, why might that be? And they might come to the conclusion that it's something to do with the bubbles. And we say, well, yeah, the bubbles form on the raisin. And that somehow makes that whole volume of the raisin less dense and that makes it rise, etc. But we still encourage them to ask the question why, because after all, they're only 8.5. But what would happen if we stopped here? If we were only 8.5 years old in our cognitive development and we stopped here? As an adult, what kind of experiment would we think was valid?
Hello, Flat Earth researchers, debaters and debunkers.
Hello again.
So, we know that, of course, if we drop the ball through the air, it's going to fall.
Yes, it will. We learnt that when we were 6. Carry on.
Okay, we know this will fall through the air because it has a mass that is more dense than the air. If this was a helium balloon, then we create an upward force.
Yes, and again, we learnt that when we were 6 years old.
Now, what happens when it hits the water? Of course, it floats.
He's blowing my mind.
We have this idea that you still have this constant force of gravity pulling the ball down towards the center of the earth. No, now that it's on or in the medium of water, it now is relative to the medium of water. So you cannot measure this continuing downward force.
So Puckett is claiming that when I put this ping pong ball into that water on this balance, we shouldn't see an increase in the force or an increase in the mass down here. So there's our number without the ping pong ball. There's our number with the ping pong ball. Clearly, this is still adding a force to the beaker. There is a downward force because I put the ping pong ball in there.
Phuket World, your mistake was stopping at the cognitive development of an 8.5-year-old and stopping to ask the question why. Why does density cause things to move downwards? You just stopped asking. Just like this guy.
Today we're going to talk about gravity. When people come to me, they say that I don't understand gravity, how it works. I don't understand science. I don't understand physics.
Hi, D-Marble, how are you doing? By the way, I just wanted to stop by to tell you that you don't understand gravity, how it works, or science, or physics. So let me answer 6 of your points. Let's get cracking.
If I understand correctly, as far as an object creating so much mass that it creates its own gravitational pull, that cannot be tested in a lab. That can't be duplicated. Therefore, the whole mass creating its own gravitational pull, that falls under the category of pseudoscience, in my opinion. Correct me if I'm wrong.
And of course you are wrong. The LIGO detector has detected gravitational waves as predicted. Now, many flat earthers like to dismiss the findings of the LIGO detector by claiming that it's built on a fault line and somehow, without going into any specifics, somehow that affects the results to make it look like there are gravitational waves. But the same flat earthers like to ignore the fact that there are 2 other such detectors on the planet not built on fault lines that give us exactly the same results.
Now, another thing that gravity is supposedly responsible for here on Earth is holding vast amounts of water to the bottom of a spinning ball. Once again, gravity is supposedly responsible for holding trillions of pounds of water to the bottom of a spinning ball. People walk around believing this. They don't really give it a whole lot of thought, but you and I both know what happens when a ball is spun that has water on it or attached to it. And I'd have to ask a question. How is it that gravity is so strong that it can hold trillions of pounds of water to the underside of a ball, yet it's so weak that it can't pull a butterfly downward?
Not this one again. Right, first of all, every time I'm out in my garden and I taser a butterfly and it stops flapping its wings, it does fall to the ground. But if you want a more serious answer, here's the equation that literally everybody knows apart from you. The force, the gravitational force felt between two masses, depends on the mass of the planet. So this, M1, is the mass of the Earth, and the mass of the object in that gravitational field. So if we are talking about thousands of tons of water, right, then M2 is going to be a massive number, which means the gravitational force holding it down is going to be enormous. If we are talking about a butterfly, then M2 is going to be a small number. So therefore the force is going to be much smaller, which is why a butterfly can overcome it by flapping its wings and pushing on the air, blah, 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 change of momentum, force upwards. I'm sure you understand it. I know, he's thick as...
Once you hop in a rocket and you go out beyond the atmosphere, okay, you go out into space, everything just turns into magic. Light doesn't work the same, time doesn't work the same, there's gravity to justify all this other stuff, but none of it can be placed in the realm of absolute scientific fact because it cannot be experimented upon. Do you get that?
Except it has been experimented on by these two guys here. So Hafele and Keating put atomic clocks in planes and they flew them around the Earth and compared them to atomic clocks that were stood on the ground that didn't move. And when the atomic clocks that were moving around the Earth came back, they found there was a time difference between the two. But not only was there a time difference, but the time difference was exactly what was predicted by the time dilation mathematics before they set off. What more do you want?
Now, Newton came up with this idea after an apple fell on his head. He's sitting next to a tree, apple falls on his head, and this guy gets a brilliant idea, says, we're just going to say that there's this force pulling everything downward, not really accounting for the leaves that were still on the tree, but we'll move on from there. Now, personally, I wish that someone would have been around to explain buoyancy and molecular density to this guy.
And I wish someone had been around to explain it to you.
If you take your phone and you accidentally drop that phone in water...
Hi. Hi, how you doing? Yeah, I'm good. Oh, shit!
Is that experiment, supposedly, in a vacuum, where the guy got up to a high point in this lab, drops a feather and a bowling ball. And it would seem that the feather and the bowling ball hit the bottom at the same time. And people will use that as justification to say, yep, gravity, boom, there it is. But let me ask you a question. What percentage of the Earth's surface is a vacuum?
The percentage that makes up the vacuum chamber you've just seen that experiment in.
That's called density.
The only response I've got to that is to put you right back here.
Called sink or float. There's 3 different sections on here. And what the child would do is they would take an object and either draw in what the object is or write the name in or do both and then see if it sinks or float. And
Thank you so much for watching. I'll be back on Tuesday. And if you have made it this far, please leave a comment and say, hello, Mr. Potato Head. I'll see you later. Bye-bye.
Hello, we are back.
Oh no. It's that South African flat earther, Flatzoid's perspective. I wonder what he has for us today. Go ahead, Zoid.
So this is Leslie Roy's argument number 4.
Yes, Flatzoid received an email from a chap called Leslie Roy and has been trying to pull this email apart piece by piece. So let's join him discussing atmospheric gradient.
Fourthly, the overwhelming evidence this gradient is entirely due to gravity.
What is gravity?
I have no idea. Okay, next question.
According to the general theory of relativity, gravity is not a force. Gravity is kind of an illusion.
Ah, the Flurfers debunk clips of choice. Well, Neil deGrasse Tyson is correct. Gravity. We don't know exactly what it is. We know the effect it has, we can measure it, we can make calculations, we can make predictions, but the actual mechanism we don't know yet. I don't see that's a problem. And the second guy is correct as well. It's a bit like centrifugal force. It's not a force. For instance, if you're driving along at a great speed and suddenly the car is steered violently to the left or to the right, you'll get flung to one side. You are not being pushed to that side. Your body's actually trying to carry on in a straight line, but the car is moving in the opposite direction, making it feel as though you're being forced to the side. It's an illusion.
Professor Dave again. I want to tell you about Newton's second law. We learned about Newton's first law of motion, which tells us that an object will continue its state of motion unless acted upon by some net force.
Oh, it looks like Professor Dave's just learnt something from me. In my example in the car, my body is trying to carry on in a straight line. I'm not being pushed against the car door. The car door is pushing me off of my straight course.
The second law continues from there, describing what will happen if some net force is indeed present.
The mass of my body moving in a straight line has inertia. In order to change the direction I'm moving, a force must be applied to overcome that inertia. That force is being applied by the car moving violently to one side and the door pressing against me. So we have two forces. We have my inertial force going straight forward and the car applying centripetal force. That's a greater level of force, so my body moves to the side with the car.
Gravity is not a force.
Shut up! This law tells us that force is equal to mass times acceleration. This is summarized in the following equation, F equals ma.
So let's change my example. Let's assume we've got a very high-sided vehicle and it's carrying a lot of weight, a lot of mass, high up. If we suddenly veered that vehicle to one side, that great mass and its inertia could overcome the force trying to turn the vehicle to the left or the right. The mass wants to carry on and the vehicle tips over. Or if it's a sports car and you take a corner way too fast, not only the mass of your body but the mass of the car could overcome that turning force and you would spin out.
Gravity is not a force. Gravity is kind of an illusion.
Your obtuse obfuscation notwithstanding is nonetheless irrelevant to the fact of the gradient. If you want anyone with even a lick of sense to agree with you, then you need to provide a vastly better empirically supported explanation.
And Leslie Roy is absolutely correct, Flatzoid. You are quite welcome to come up with an alternative explanation for the atmospheric pressure gradient than the gravitational pull of the Earth. But your explanation is going to have to explain things more accurately. It is going to have to make predictions. It is going to have to explain all the observations. Let's see how you do.
Let's just say this is the density, and then it's getting a bit less dense as we go up and a bit more less dense as we go up.
More, less dense.
Blah, 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 blah. Why is this happening?
A good question, Zoid, and one that has been much on my mind in recent weeks. Please, explain.
Remember, gas is unbonded. It's homogeneous. It has elastic collisions, Bob. Every single mole is bouncing into each other in every single direction.
Okay, so the standard view is that all the atoms and molecules are bouncing around in any direction they wish with a bias downwards because of gravity. You're ruling out gravity, so we just have all the particles moving around at random. Carry on.
So, let's make it this way. Brush. If a gas mole has bounced off the ground and goes in this direction, tell me, Bob, why is it coming back?
Well, I don't know, Zoid. Since we've ruled out gravity, what could it be? Homesickness?
Because it is coming back because we actually are breathing. That means it's hitting something and coming back. You get that? It requires containment to bounce off and come back.
Really? Well, if we go for your container idea then, Flatzoid, and that it is the container that's causing the gas molecules to bounce back, why aren't there an even number of gas molecules throughout the container? We still have a gradient, and you still haven't explained that.
Now, because we got the most concentration of gases lower down, means there's more bombardments per cubic centimeter.
I'm concerned, Flatzoid, that you're about to make some sort of a circular argument, because we're trying to get to an explanation for why we have more atmosphere down low, and you seem to be saying that the gas molecules down low have more gas molecules to hit than the gas molecules up high, and so therefore we've got more gas molecules down low than we have up high.
Means there's more bombardments per cubic centimeter compared to there, or compared to there. Doesn't mean that there's no gas up there. There's the same gas here as there is here. Just the concentration of gas is more down here than there is there.
He said it. We've got more gas down here than up there because we've got more gas down here than up there.
Santa Maria! It's very simple stuff. It's called gas behavior.
No, it's called being a smeghead, you gangrenous truffle. Please show us the gas law that describes gas behaviour, that explains that the reason we have more gas in one location is that we've got more gas in that location. Perhaps, my friend, I've been a little hard on you. I understand that right here, right now, you are actually going to explain the big question, the answer to the big question. Why? Why do we have higher pressure down low than we do at height? And here it is, Flatzoid's explanation. Go ahead.
Now, the surface of the ground means there's more for the gas to hit off of.
Maybe there's a biblical explanation. Consult the Book of Armaments.
Armaments, chapter 2, verses 9 to 21.
And at the ground, there's usually rocks
and sloths,
mountains
and carp,
trees
and anchovies,
people
and orangutans,
farting
and breakfast cereals,
cars
and fruit bats.
Gases produced at ground level.
And large... Skip a bit, brother.
That is why we see the most concentration of gases lower on the ground.
Oh, dearie dear. Well, okay.
Zoid, your idea is about the worst idea since Abraham Lincoln said, "I'm bored, let's go out and take in a show." Are you really, really trying to explain the atmospheric pressure gradient by saying there's lots of stuff for the air molecules to hit off down low? I think we should have a look at the actual pressures and what's there.
Come back! Come back!
So here is my Mage balloon probe, and here, low down near to the ground, is where we have all your rocks and people and trees, etc., for all the air molecules to collide off of. The atmospheric pressure here is a little over 100,000 pascals. Let's go up higher where there's not so many anchovies and orangutans, etc., and see what it's like there. 8,848 metres. This is the height of Everest, the highest point on Earth. Our atmospheric pressure has dropped from just over 100,000 pascals to around 32,000. We're down to 1/3 of the atmospheric pressure, so why has the pressure been dropping? I suppose if you're in the vicinity of Everest, you could say there's less and less mountain for the air molecules to fit off, because mountains tend to be quite pointy. But then why should we have this same gradient on the other side of the world with a distinct lack of Mount Everests, and yet we get the same gradient of atmospheric pressure decreasing to this height? Well, let us not be downhearted, siblings. The total failure so far of your explanation, Zoid, is just the beginning. Let's carry on. Above this height there are no more objects, no more anchovies, no more breakfast cereals, no more orangutans, nothing, zilch, nada, nothing for the atmospheric molecules to hit off of until we reach your fabled dome. So therefore, above this point, the atmosphere should be at the same pressure. So we've come up to over 38 kilometres high. The pressure is down to less than 300 pascals. It started off at ground level at 100,000 plus. The pressure at this height is 0.003% of what it was at ground level. 99.997% of the atmosphere is below this height. It's staying down there despite not hitting any sort of container. I'm afraid, Flatzoid, that your upturned goldfish bowl theory of gas pressure has just gone pop. Like this balloon, but with a lot less style. Enjoy. Zoid, I think that coming up with an idea like your anchovy breakfast cereal theory of atmospheric pressure gradient is ridiculous. It should be a criminal offence.
I'm a South African. You can clearly hear I'm a South African.
Diplomatic community.
It's just been revoked.
In over 55,000 comments on the Testing Flatard series so far, no Flatard has shown themselves capable of even beginning to discuss the specific geometry presented. Part 3 is on the way, but as an offshoot of the series while we wait, it's time for questions for Flatards. On the 21st of August 2017, another total solar eclipse will occur. This one will be special insofar as the path of totality will cross North America, the developed country with quite possibly the highest number of backward simpletons who think the Earth is flat and who have somehow found themselves in the 21st century taking advantage of potable water, electricity, healthcare and advanced communications. Because Earth isn't flat and the motions of celestial bodies can be predicted many years in advance, this event has been known about for, well, many years. And not just known about, but exquisitely predicted. We know when every eclipse this century will be, what type each eclipse will be, how long they will last, where they will be visible from, and so on. Amusingly, the aforementioned primitives will accept the prediction that this event will happen, and will go and see it, even though Flatards have not yet got around to developing any predictive capabilities of their own, whilst declaring the rest of the world to be part of a conspiracy against their fevered delusions. For flat earthers, this event, like all partial and total solar eclipses, presents something of a problem. It is undeniably the moon that blocks our view of the sun, yet the best these unmitigated dullards have managed to come up with is the idea that a dark disk, which is conveniently invisible the rest of the time, hides the view of the magic flying spotlight that they call the sun. This event then, and those like it, present our first set of questions for flatards. Question 1. Why don't flatards have the ability to predict these events? And by predict, I mean perform calculations as to when they will occur, where they will be seen from, how long for, and so on, that are based on their pitiful delusion that the Earth is flat. Question 2. Why does the ability to predict eclipses and the predicted path of the Moon's shadow correspond precisely with Earth being an oblate spheroid rather than a giant frisbee? Question 3. Since you flatards can't seem to make up your minds as to what the Moon is, it's about time you caught up with the rest of humanity and settled on an answer. So, what exactly is the Moon? Do you even know what shape it is? Is it a sphere? Is it a disk? Is it transparent on a part-time basis? How precisely do you know any of these things? Name your finest astronomers and try to make your answer more sophisticated than "But my holy book!" Question 4, and this is for the indolent fools who think the moon is transparent on a part-time basis because it looks blue in daylight, or who think they can see stars through it. How does your transparent moon block light from the sun during a solar eclipse? Question 5. Since you reality-denying buffoons will be incapable of answering these questions with anything more than feckless assertions pulled out of your backsides or copied from other flat earthers, will you, on the 21st of August 2017, be shouting at the sky and shaking sticks at the moon to scare it away and make the sun come back? If you're a flatard in North America and you fail to produce comprehensive answers to these questions before the eclipse of the 21st of August 2017, your next opportunity to see one without having to get a passport will be on the 8th of April 2024. Perhaps you can work on how to predict that one. Good luck!
Well, I've been travelling around Flurfia for a while now and I came across this guy. He seems to have a penchant for completely failing to understand magnetism. In a prior video, he challenged people to demonstrate that a bar magnet inside a ball could reproduce the magnetic field that we observe on Earth. Now, firstly, this is silly because it's not an accurate representation, as the current established view within the scientific community is that the Earth's magnetic field is caused by rotating molten metal. But ignoring that, I suppose that a bar magnet inside a ball could be considered a reasonable approximation. Enter MCToon, who obliged by taking a stack of disc magnets and putting them inside a ball and demonstrated with a compass that the field is pretty close to what we observe on Earth. In typical Fleur fashion, this fellow rejected a very simple demonstration by asserting that a stack of magnets is not the same as a single bar magnet.
Guys, another little lesson on magnetism and how magnets work. This would be a bar magnet. Big positive, big negative. North-south, large and large. You can cut it in half and create two bar magnets. Yep. North-south, north-south. But when you put them on top of one another, you do not have one magnet again. When you put these two together, it doesn't become this again unless you weld it or create, fuse it together, like weld it and create one piece again. Stacking two magnets together doesn't make one again. You can cut one in half and make two, but you can't stick two magnets together and make one again. Okay? Unless you weld it. Create one piece. This is the field of the stacked magnets. Positive, negative, positive, negative. Yes, it will be positive at the top of the stack and negative at the bottom, but it will not be this. A fucking bar magnet is one magnet.
Now this came onto my radar and passed my what can we learn from this mistake test, and figured that this would be a great opportunity to talk about my favourite subject, which is magnetism. We start with considering what happens to a magnet which has a north and a south pole when we cut it in half. The result is that we have two magnets with both north and a south pole. We then continue chopping them in half and find that every time we end up with more magnets which have north and south poles. Eventually we have cut the magnet down to the smallest unit and we find that it still has a north and a south pole. Turns out that you can't separate the poles. Magnets are dipoles, meaning that they always have a north and a south pole. Unlike electrical charges, magnetic monopoles cannot exist. This is embodied in Gauss's law for magnetism. So what is a dipole? Well, let's consider a monopole which looks like this. We'll call this the north pole with the field radiating outwards. We can then also take a south pole with the field radiating inwards, or the other way around. It doesn't actually matter as long as we understand that they do the opposite thing. We then add the two together to get a dipole, and the key point here is that the fields created by each pole obey superposition. That is, the vector sum of the fields at each point gives the total field. So time for a quickie around vectors. A vector is a quantity that has both magnitude and direction, and we can take this vector, which has two components. It has some direction along the x-axis and some direction along the y-axis. The magnitude is then given by Pythagoras' theorem. We then take another vector which has some components along x and along y, and if we were to add the two, we add the two x components and the two y components separately to get the x and y components of the new vector. Now when we do this for the two monopoles, we get this field, and then we bring them close together, so we get this, and we bring them infinitely close together to get the magnetic field produced by a single magnetic dipole. Now this dipole in essence is a tiny bar magnet. Bar magnets are made up of a very large number of these dipoles, so we can add them together, and this gives the field for this larger bar magnet. So we can see that the field of a bar magnet is the vector sum of the field due to each fundamental unit in a material. Please note that I use the word unit rather than atom because a lot of the times the magnetic properties of a material are due to slightly more complex configurations. But it then stands to reason that when you stack two magnets on top of each other, the resultant field is the vector sum of the fields of the individual magnets. So let's see if that is the case. And yet, that seems pretty reasonable to me. However, some people have bemoaned my lack of practical demonstration, so I have dug up a compass and some magnets and figured out that I would try the magnetic field of a single bar magnet and then a pair of stacked bar magnets. And yep, that all checks out. The fields look pretty similar. Now, that chap also insisted on demonstrating the field lines around a ball. Now, I can't be bothered to try and find a ball to determine the field directions along each point, but I'm very busy at the moment, so we can just settle for a cross-section of a ball and assume that the system is rotationally symmetric about the long axis of the magnet. Now these results are pretty consistent with the Earth's magnetic field, which also leads to a fun fact. Compasses need to be balanced for the range of latitudes in which they are used due to the fact that there is a varying downward component to the magnetic field. Now, that person is not going to accept this demonstration because of, well, reasons, but I'm sure that MCToon will persist and try his best to make sure that we stop hearing from that guy.
Hello and welcome back to Baldy Cats. Now, you might remember that last week I made a video about this guy who's actually a flat earther who goes by the YouTube name of That Guy. Now, since I made that video, this guy, or that guy, has deleted a whole load of his videos and failed to respond to any of the points I made in my Flat Earth Defense Kit, which says to me that that is slowly sinking in, and in a few weeks, hopefully, he'll start to see sense. Anyway, this week I'm going to help somebody else. This time, a really nice and polite Flat Earther. So let's get started.
Stop, look and listen, for Baldy shorts you'll be missing.
Hi everybody, Harry here in Sydney, Yesterday I did a simple couple of experiments trying to establish something that I've been working on the last couple of days.
So this is a YouTuber called Harry Bird, and he's been doing some observations to test the idea that on a flat Earth the horizon should rise, and on a globe Earth the horizon should drop as you gain in elevation. And in order to do that, he's taken two observations of the same tower, one of those observations being 20 foot higher than the other. Now, at first glance, his images certainly do back the idea that as you gain in elevation, the horizon will rise with you. If you look at the waterline behind, we can see that on the lower picture, it is way below the top of the tower, but as it gains in altitude, there we go, it's right above the top of the tower. Something that is impossible on a globe, but only possible on a flat Earth, leading him to make this conclusion, which is, of course, that the Earth cannot be a sphere. So let's see if we can help Harry out, because on the surface of it, those pictures do seem to back up his assertion, and I can see how, if you already believe in the flat Earth or there's a chance of it, that pictures like that might convince you. So let's take a closer look at the picture taken at the lower elevation. And we can certainly see at the lower elevation that the horizon is well below the top of the tower, compared to this picture where we're 20 feet higher, where we can see that the horizon has clearly risen. Now, obviously, I wasn't there when these observations were taken. I can only stalk one person at a time, what can I say? However, the first thing that jumped out to me was the fact that the top of the tower, that box, that cube at the top of the tower, seemed to be in the center of both images. Let's take another look. Now that suggests to me that either on the lower picture, the camera was ever so slightly tilted upwards, or on the higher picture, the camera was ever so slightly tilted down, or both. So I took a closer look at the pictures, and I identified these things here that I've labelled with the black arrow, these horizontal frames on the tower. I'm going to call them steparunas. Now if I look at the picture that was taken at the lower altitude, I can count 7 steparunas. But if I have a look at the picture that was taken at the higher altitude, I can count 8 steparunas. Now, of course, the only way you can see more of the bottom of the tower when you climb in elevation is if you tilt the camera downwards. So, however honest Harry was trying to be with these pictures, and I do believe he was trying to be honest, there is no way at all that he could have had that camera level on both of those shots. And that is your reason, Harry, that your horizon has risen in the background. Now, this is the second video I took off Harry's channel, and here he's trying to show us that boats don't disappear from the bottom up because they're going over the curve of the Earth, but just simply because they're getting further away. And the angle between the floor and the bottom of the boat is getting so small that it gives the illusion of things disappearing from the bottom up. Now, just like with the first video we've just seen of his, he has some early success, but can you spot why? So I can see the bottom of the boat, and I'm going to remember that the surface of that table represents the surface of the water, which I'm getting closer and closer to now. I can still see the bottom of the boat. I'm getting very close to the surface of the water. I'm getting even closer. I'm getting a little bit worried. In fact, oh, help me, I'm drowning, help me, I can't swim, I'm under the water. So there are literally dozens of this type of clip on the internet where people are moving a camera up and down to try and show that objects will disappear from the bottom up due to this weird sort of perspective thing. But they've all got one thing in common, and that is always the camera has to go below the table that the object is sat on. In fact, the only time a flat earther left the camera on the same surface as the object he was looking at was when Ranty Flat Earth himself went down to a 100-metre racetrack, and he proved that things don't disappear from the bottom up just because they get further away. Do you remember this?
Well, we're not losing any of the actual target.
Now, the third and final video I look at on Harry's channel is the one that really gives me hope for him. Take a look.
How do you explain perspective and and compression to a globe believer when you get evidence like this?
So clearly Harry has filmed something which does appear to contradict the beliefs or the predictions made by Flat Earth, but he's been honest enough to put it on his channel and open up the comment section asking for civil discussion. But unsurprisingly, civil discussion is something that a lot of Flat Earthers really aren't capable of, and now this video has comments disabled. So the video begins with Harry filming a boat which is approaching him. Now you can't see all of the boat, some of it is blocked by the curve of the Earth, although Harry uses the excuse of perspective, even though perspective for some reason isn't affecting the angular size of the width of the boat.
There we go. See how compressed that is? Okay. I think it's about a 1 metre swell out there, but I'm still calling perspective.
But then in what was quite an honest move, he showed us what the boat looked like a little while earlier, while it was even further away.
You can imagine how I felt. You can still see the top of the boat. There's absolutely cannot see the hull. Now, whether that's the waves, from my perspective, I could say the waves are getting in the way. But it's got me thinking anyway about I can understand how we can get photographs like this, and I'm still not completely convinced.
Okay, Harry, let me see if I can help you. The whole reason flat earthers seem to think that things disappear from the bottom up due to perspective is because of a misrepresentation of something called the Rayleigh criterion. Now, the Rayleigh criterion tells us a minimum viewing angle at which we can look at 2 points and still resolve them. Essentially, whenever light passes through an aperture, it will diffract and cause a diffraction pattern. Now, there is a minimum separation distance that the diffraction patterns from two objects can get before we cannot resolve them and before they look like one object, as shown by the diagram here. And this equation here will tell us the minimum viewing angle that we need in order to be able to resolve two objects that are close together. But what you'll notice is that lambda sign on top of the equation. This stands for the wavelength of light. Now, why is this important? Well, normally when we do calculations with the Rayleigh criterion, we use an average wavelength of light. But actually, the wavelength of light does make a difference to that viewing angle. And if you were to take a red filter or a blue filter and put it in front of your camera when you're making observations like this, what you should notice is a different amount of the bottom of the boat will become visible depending on the colour filter you use if that boat is disappearing due to perspective. Now, this is really easy to do. You simply go to a shop and buy a piece of red plastic or buy a piece of blue plastic. It's ultra cheap way. And when you analyse those photographs properly with a red filter and a blue filter, you'll see that no difference is made to the amount of boat that is lost. Therefore, ruling out the Rayleigh criterion and ruling out perspective. And once you've done that, feel free to get in touch and we'll have a chat. Good luck.
Greetings, dear viewer. Testing FlatArts 5 is underway, and I've got about 2/3 of the visuals done. For now, let's recap the remarkable failures of FlatArts since testing FlatArts began. In over 127,000 comments on the series, not one FlatArt has been able to provide A working map of Flatardia. B. Any explanation for how a worldwide transportation network for goods and people has worked for centuries without such a map. C. Any refutation of the basic geometry shown in the series, even though kids can handle it. D. Any reconciliation of the geometric paradoxes that Flatardia presents. E. Any reconciliation of their disk world with the basic naked eye observations shown in the series. F. A description of the image analysis method used by FlatArts to test whether any given image of anything is real or not, and what the error margins of that method are. G. A formula to calculate the acceleration of a falling object based on density. H. The locations of the radar stations they claim are used to protect Antarctica. I. The location of the harbours and airfields where the Antarctica Defence Force are based. J. Any explanation of how the South Celestial Pole works in their fantasy world. K. Any useful way of navigating from one point to any other point on Earth. L. Any useful way of calculating the correct distance between one point and any other point on Earth. M. The names of any active commercial or military pilot who is in on the conspiracy. N. The top 5 contributions made to mankind by FlatArts that depend on Earth being flat, and for which the rest of humanity owes them any thanks whatsoever. In addition, no sensible answers were received in response to the first set of questions for FlatArts, so these irredeemable fuckwits clearly have no way to predict eclipses with anything like the precision available by accepting how reality actually works. Also, recently Wolfie6020 ran another one of his competitions where any entrant could win $1,000. Based on a simplified search and rescue scenario, all FlatArts had to do was provide a flight plan for a search and rescue operation off the coast of Australia. Not one of them even submitted an entry. The ongoing failure of FlatArts to do anything of use apparently remains total. Some are so batshit insane that they think Australia doesn't exist, and that people from there are, you guessed it, paid actors pretending to be Australians. Others simply claim that Australia isn't where we're told it is, but they remain incapable of saying where it actually is, which presumably means they've also managed to lose the entirety of the Australian continent. This brings us neatly onto round 2 of questions for flatards. Question 1. This is the Sydney Opera House. Opened in 1973, the site welcomes over 8 million visitors per year. The question for flatards then is simple. Where exactly is the Sydney Opera House? Consult your best flatard cartographers and provide distances to the Opera House from 3 locations outside of the Australian continent. Question 2. Where do those 8 million visitors a year actually go, and why do none of them notice that they aren't in Australia? Question 3. This is Uluru. It is a World Heritage Site. It is visited by over 400,000 people every year. Millions of people have seen it since tourism to the site kicked off in the 1950s. Where exactly is it? Consult your best flatard cartographers and provide distances to this rock formation from 3 locations outside of Australia. Question 4, and this is for the ones who think Australia doesn't exist. This is a kangaroo. Where do they live? Question 5. This is Sydney Harbour Bridge. It was opened on the 19th of March 1932. Given that people have been navigating to the harbours of Port Jackson for more than long enough for flatards to have figured out how to get there using their own maps, the question for them is simple. Where is it? If you're a flatard and you're struggling to understand why your kind can't navigate their way out of a paper bag, perhaps you'd like to make the link between having no working map of the world and being unable to answer basic questions about where things are. And if that sounds like it might be a little too intellectually challenging, perhaps you'd like to do your bit to improve humanity by following this simple 3-step guide. Shut up, piss off, and when you get there, piss off again.
Throughout the past year that I've been involved in the Flat Earth debate, anytime someone asks about how the sun sets and rises, it's always the same response from the Flat Earth side of the argument. Perspective and the vanishing point. They all claim that the sun gets to a certain distance and can no longer be seen because it goes beyond the vanishing point. What they never answer is, at what distance is the vanishing point? In this video, we will examine what distance that should be at. With it being the equinox, it's the perfect time to take these kinds of measurements. Basing it all off the equinox, it's very easy to make a model to find out what that distance is. After all, we know the exact position of the sun over the disk, and we know the locations of any observation points. Let's look at the model they propose most often, the circular disk. As you can see, on the equinox, the entire Earth gets 12 hours of daylight and 12 hours of darkness, give or take up to 4 minutes depending on topography. Let's put the sun into motion to show its path over the disk Earth on the equinox dates. As you can see, it is always directly over the equator. What this means is it's always the same distance from the North Pole. Now, let's stop the sun on the right side of the video and look what the model would look like if you were able to place a camera locked to the sun. From the sun's perspective, the Earth is rotating underneath it. Nothing about the model has changed. This is just a way of showing the measurements easier later on in the video. Now we can pick 3 observation points. For this demonstration, I'm going to choose Long Beach, New York, Chavez, Brazil, and Ushuaia, Argentina. We know the distances of each of these points from the North Pole. Long Beach in New York is 3,422 miles from the North Pole. Chavez, Brazil is 6,226 miles from the North Pole. And Ushuaia, Argentina is 9,986 miles from the North Pole. We also know the distance from the equator to the North Pole is 6,215 miles. If perspective in the vanishing point really is the cause of the sunrise and sunset, all these distances should be the same, as the laws of perspective apply to everyone in the world in the same way. Let's go ahead and stop the rotation of the disk at each of these points in turn to see how far away the sun is at dawn at each location on the same date, March 20th. First, we'll take a look at Chavez, Brazil. To find out how far away the vanishing point is, we'll make right triangles. The first leg of the triangle will be from Chavez to the North Pole. The second leg of the triangle will be from the North Pole to the equator at the sun's location. To find the distance to the vanishing point, we'll need to make use of the Pythagorean theorem. First, we need to make a line from Chavez to the North Pole with a distance of 6,226 miles. We will call this leg A. Next, we make a line from the North Pole to the Sun with a distance of 6,215 miles and call this leg B. To find the distance between each of those 2 endpoints of the legs, we need to use the formula to find the hypotenuse. To get our distance to the sunrise, it is the square root of A squared plus B squared. So from Chavez, the vanishing point is 8,797.12 miles away. Now that we have our baseline, let's move on to Ushuaia, Argentina. We know that Ushuaia is 9,989 miles from the North Pole. So we just run through the calculations again. We draw a line from Ushuaia to the North Pole with a distance of 9,986 miles. Then we just draw another line from the North Pole to the Sun, which we already know is 6,215 miles. Now we just run through the same calculation and end up with a vanishing point distance of 11,762.08 miles. Uh-oh! We have a problem here for the vanishing point. Let's go ahead and test our last location to see if the problem fixes itself. Moving on to Long Beach, New York. We already know that it's 3,422 miles from the North Pole. So again, we draw a line from Long Beach to the North Pole with a distance of 3,422 miles. Now we draw our line from the North Pole to the Sun's location with a distance of 6,215 miles. Now we solve our equation one last time to get a vanishing point distance of 7,094.81 miles. So, as you've just seen, unless the laws of perspective change based on your latitude, all on the same day, the entire perspective and vanishing point arguments are complete rubbish. I would like to thank 5 Red Pears and M. Goudsmits for inspiring the idea to make this video with ones they touched on the topic but didn't go into a whole lot of detail on the math. And I'd like to give a very special thank you to Halsoy for actually doing the animations for this video.
Welcome back to Baldy Cats. Now, it's 2019. So how did the world get to this?
People really struggle to understand. So we come towards the door, we open the door, and we bring it inwards. As we bring the door inwards, we see we pulled the door. Okay?
So this is Del from the YouTube channel Beyond the Imaginary Brain, and would you believe me if I told you he's right now in the process of debunking gravity by teaching us how to open a door. I mean, just when you thought you'd heard it all. So let's have a little bit of a listen to his logic, shall we?
Gravity is said to be a pulling force. So what I'm going to do is I'm going to start off showing some simplistic aspects of where people misunderstand and get confused about the mechanics of motion.
That's right, Dell has actually decided that because people refer to gravity as a pulling force, if he can show us that we're using the word pull incorrectly, then gravity cannot exist. It is absolutely incredible. Now, what other situations do we use the term pull? Well, for example, if I want to pull open a drawer.
You open a drawer and you pull.
Thanks, Dell. Now, according to Dell's logic, because we use the term pull when we're opening a drawer, the ability to open a drawer must therefore not exist. Now, Dell has plenty of examples of where we use the word pull in everyday life, and he's going to use all of those to show us that gravity can't be possible. Starting with the door.
So as you can see, we have to apply a pressure downwards on the handle. We then put our hand here on the back side of the handle and apply a pressure in order to bring the door inwards.
And he can even explain how to close a door.
Same again, when we are shutting the door, we have to push down on the handle.
But you know what? It's not just people's front doors that he can open either.
And the same again here. We would say I pulled the drawer, I pushed the drawer, pulled the drawer, push the drawer.
Go on then, one more time.
You open a drawer and you pull.
But of course, as we've learnt so far, we don't pull open a drawer because pull doesn't exist, which means gravity doesn't exist. It's all very complicated. Anyway, Dell continues to educate us.
Physicality again is the exact same. I have to place my hand over the handle, now applying the force that has been exerted on the inner portion, and the drawer opens. Now I'm applying the pressure again to close the drawer.
And we can carry on applying this type of logic to all sorts of stuff, like motorcycle handbrakes.
So again, as you can see, hand is over, the pressure is now applied here, pushing.
And even when you tow a car, you're not pulling it, you're pushing it.
Now, if we look at the situation here, as the car is accelerated forward, this is now catching on the back end of the car. The pressure is now being applied here, here, and here internally.
And Dell also shows us that once you've mastered the technique of opening a drawer with your hands, you can push it open with a rope.
Push.
In fact, you can debunk gravity with almost any household object.
Again, something simple as lifting a cup where people may struggle to understand.
Or even when doing exercise.
What we get here is what people would call a pull-up.
But you just guessed correctly, there's absolutely no pulling involved. Gravity debunked. Now, when I started watching this stream, I was hoping we were going to learn something a little bit more technical.
As I say, I'm not going to bother, showing the whole principles of the internal combustion engine.
Yeah, but in hindsight, it is probably best that maybe you didn't try to explain that. Anyway, just to show you how strongly Dell feels about the word pull and his belief that scientists need to use the word pull to justify some sort of invention of gravity, here he is on the subject one more time.
They require it to be the central hub of their whole shebang. They need this central aspect of a non-geometric non-entity that can pull stuff towards it, which is why they've got these visual representations of the warping and bending of space-time, but they can only show it on a planar aspect, two-dimensional. So, they don't show it in 3 dimensions because it's nonsense.
Now, it isn't just high IQ practical demonstrations like this that Dell's been doing in his research. He's also been contacting other YouTubers like myself to ask us why we dare use the word pull when we start talking about gravity. Here's what I said. Well, in a nutshell, I said, I don't care. It's all semantics. It doesn't matter whether we use the term pull or push. All we're doing is describing the relative directions the objects are moving in. We're not claiming to be describing the mechanics of what's going on. And that applies equally well to his favourite new force, which is push, or applied pressure, as he likes to call it. Now, Dell didn't like my answer to that, so he called me a liar and continued to ask me, how does gravity work and how does gravity pull things and what is the mechanics of that pull? Now, I kept saying, I don't know how gravity works. I don't know if anybody knows the exact specific mechanics of how gravity works, but we can't deny the fact that it exists and we understand its behaviour and we can use it to make predictions and accurate models, etc., etc. But Dell wasn't happy with that. So he asked me again. And again. And again. I said it didn't matter. So he asked me again. And again. I asked him if he was drunk. And he asked me again. And again. And again with the same question. And again. And then again. And then he asked me again.
and again, and again. And then, yeah, he asked me again, and again. And then he asked me again. And then again. And then he asked me again. So after failing to get me to claim that I actually know the true mechanics of gravity, and after failing to get me to accept that because we use the word pull, we should discard gravity, Del got a little bit upset and took his ball home.
Ew, you're just a liar.
Now, I know by now a lot of you will be thinking about magnetism and other non-contact forces which clearly attract two objects together, but we're not going to talk about those for now. What we're going to do is take one of Del's examples, this one.
Push the drawer.
And we're going to be showing Del that even something as simple as pushing a drawer shut with your hand isn't necessarily the result of a push force. I know that sounds a little bit odd, but to get to my point, let's have a little refresher on how muscles work with this 1 minute reminder. So muscle fibres are divided into these contractible little subunits that we call a sarcomere. Inside each sarcomere we have these thick myosin filaments represented by the red filament at the bottom and thin actin filaments which are represented by the yellow one above. Now that weird thing in the middle we're going to call the myosin head group, and the myosin head group wants to bond or bind or stick to that actin filament above, but it can't because of that green coil-like substance we're going to call tropomyosin, which blocks the binding site. But when calcium ions enter the sarcomere, they bond with these little blue things, which are called troponin. This causes the troponin to change shape, move the tropomyosin out the way, and now the myosin head group can stick to the actin filament. Now, it's worth noting that this can only happen if the myosin head group was previously bound with ATP, or adenosine triphosphate, and then hydrolyze this or split it into ADP, adenosine diphosphate, and an inorganic phosphate. And that's important because it's the release of this ADP that allows a myosin head group to change shape and pull the actin filament along with it, therefore contracting the sarcomere. So ultimately, muscle contraction, which causes that push force, is the result of chemical interactions. What is happening to the molecules, a rearrangement of those molecules to cause that myosin head group to change its position? What forces are happening at that low level between the electrons and the protons in those atoms to cause that movement? Can we call it a push? Can we call it a pull? How does that electrostatic force actually work? Well, I don't know, and I'm pretty sure this guy doesn't know either.
You open a drawer and you pull.
And even if we got right down to the very, very bottom of it and found out that as these molecules are somehow rearranging themselves due to electrostatic forces, there is something pushing on them somehow. Or even if we got down to the bottom of it with magnetism and found out that as magnets attract, they are somehow being pushed from the sides. That doesn't support this silly argument that gravity can't exist at all. We don't fully understand how gravity works. I don't understand how gravity works, but we can use it to make accurate predictions. We understand its behavior extremely well. And if it turns out that there is some sort of push force that's pushing things to the floor, it doesn't mean gravity doesn't exist. It just means we've gone one step deeper to learn how it works. But anyway, some people in the chat of Del's original video, which I've linked in the description, they don't want to go that one step further. They're just happy watching somebody open and close a door. Check this out. Now, as you might expect, Conspiracy Cats is going to be going to town a little bit on this whole idea in the next week or two at least. But I just wanted to get this out now and get it out of my system. But for now, this video's over. Bye.
And the same again here. We would say I pulled the drawer, I pushed the drawer, pulled the drawer, pushed the drawer.
In this video, we're showing a do-it-yourself ferrocell and how some magnets interact with it to show magnetic field lines, or something like it.
Many of you will know that my particular area of interest is magnetism, and that this is what my research focuses on. Prior to Colon sending me a link to Ken Wheeler's channel, I had actually no idea that there's a whole community of woo peddlers on the internet who also take an interest in the subject. The magnetism woo community spans a wide range of characters. At the bottom of the pile are people like Ken Wheeler, who is an obvious charlatan and a grifter. Then at the top of the pile is a channel known as Fractal Woman, which is run by Laurie Gardy, who is clearly a shut-eye. Now she has latched onto some demonstrably incorrect ideas, but she actually tests things, and as a result, she has a far more sensible framework. Now, I think her material is born out of a fundamental misunderstanding of the theory, and it certainly looks as if her honesty and curiosity will save her and eventually lead her to developing a decent understanding of the subject. Now, I would be remiss if I didn't mention Scientific Lee, with whom I had a brief exchange in one of his comments sections. That exchange encouraged me to make a video to address some of the points he made. That video did not come to fruition as it was long, and I decided to break it down into smaller pieces, and this is the first one. And there is something that most of the magnetic woo channels have in common though, and that is their use of the ferrocell. Now, the ferrocell is a simple device developed by a chap called Tim van der Relle. It is just two pieces of glass with a small cavity between the pieces. The cavity is filled with ferrofluid, which is just nanometer-sized iron filings suspended in a fluid. Around the circumference of the construction, you'll find a series of LED lights. When you place a magnet on the ferrocell and turn the LEDs on, you get cool patterns. And there's nothing that the woo community loves more than pretty patterns and geometries, as if they have magic properties. Tim van der Relle and many other people in the magnetic woo community will tell you that these patterns show magnetic field lines. However, as you go through the images of these things in actions, you will quickly find that this claim is rather problematic. So problematic, in fact, that even though Tim claims it on his website that the device shows magnetic fields, he explicitly states something different in the literature that he's trying to get published, like this paper, which actually, for the life of me, I can't see how it got published. A nice and easy way to visualize magnetic fields is by pouring some iron filings on a piece of paper and bringing a magnet near the iron filings. But many proponents of the ferrocell will claim that this is actually not really the magnetic field, and you should be looking at the patterns that the ferrocell shows, because that really is the magnetic field. But there we run into a problem. A magnetic field is actually defined in terms of these iron filings. The ferrocell may show something really profound. Now, spoiler alert, it doesn't. But whatever it shows, it is not a magnetic field. A field is defined in terms of the force that a particle would experience if it were at some position in that field. For example, the gravitational field is given by this expression. And this expression states that at some given position in space, a particle will accelerate towards the center of mass. The relationship between the field and the force is the product of the field and the amount of the property that the field acts on. In the case of the gravitational field, this property is mass. So to get the force, we multiply the field by the mass. Using dimensional analysis, this becomes more obvious. The gravitational field has dimensions of distance per time squared, or acceleration, but we can also see this as a force per unit mass. As the gravitational force is the product of the gravitational field and the mass in the field, we can take those dimensions and multiply them by mass to get force. And the same goes for the electric field, for example, which is given by this expression, which has dimensions of force per unit charge. That is to say, force divided by the property that the field acts upon. Place a charge in that electric field and we multiply these dimensions by charge, and we get force. The property that the magnetic field affects is magnetic moment, or charges that are moving at some given velocity. Either one of the two is fine. We can define the magnetic field in terms of that force using the Lorentz force law. And from dimensional analysis, we find that the magnetic field has dimensions of mass per time squared per current. A different but compatible definition of the magnetic field is in terms of a dipole moment. Now, a dipole moment is just something that has two opposite quote-unquote charges separated by some distance. A dipole moment is a vector quantity that points from the negative charge to the positive charge as per convention. The magnitude of the vector is dependent on the magnitude of the charges and the distance between the two. Although strictly speaking, you cannot have isolated charges in magnetism, and therefore you can't have two monopoles spaced some distance apart. We can still treat stuff as magnetic dipoles, and a magnetic dipole moment is often denoted with a lowercase mu. Another way to define a magnetic dipole moment is in terms of a current loop where you have a ring in which a current flows. The dipole moment is defined as the magnitude of the current multiplied by the surface area enclosed by the loop. Note that the surface area here is a vector quantity which is normal to the surface enclosed by the loop. Now we can define a magnetic field in terms of the torque, or the rotational equivalent of force acting on a moment in a magnetic field. The potential energy of a magnetic moment in a field is then given by the negative of the scalar product of the magnetic moment and the magnetic field. Now, if you are not familiar with the scalar product, for the purposes of this video, all you need to know is that the dot product of two vectors is the same as multiplying the magnitude of each vector and the cosine of the angle between the two. And when we plot this out as a function of the angle between the two, we find that the lowest energy state for a magnetic moment is to align with the magnetic field. Now, what has this got to do with iron filings? Well, iron filings are thin rods of iron, and small and thin rods of magnetic material like to be magnetized such that the poles are on the thin ends. Each atom in a magnet is a tiny magnetic moment, and they all like to be aligned. Each atom has a north pole and a south pole. So in the bulk of the magnet, the north pole on each atom is right next to the south pole of the next atom, and they are cancelled out until you get to the ends of the magnet, where the atoms at the surface don't have another atom to cancel their pole out. So you end up with lots of north poles on one surface and lots of south poles on the other surface. And these all add up to give to us what appears as one big north pole and one big south pole. But we can see a pole as a charge. The north pole is the positive or negative charge. I can never remember the two. And the south pole is a negative or whatever, the opposite charge. So we have two charges separated by some distance and therefore a magnetic moment. And magnetic moments align with the magnetic field as per the definition of a magnetic field. So iron filings on a piece of paper is the correct way of visualizing a magnetic field, because whatever it is that makes iron filings arrange themselves in that way, whatever that is what we define as the magnetic field. Next comes the idea of a field line. Now, a field line is defined as a line where at any point on that line, the direction of the magnetic field is tangent to it. This means that iron filings align themselves so their long axis is tangent to the field, or the field line. So we are now in a position to show that, despite what Tim van der Relly's website states, a ferrocell does not show magnetic fields or magnetic field lines. We can take this picture of a ferrocell, which according to the caption has 3 cube magnets on it. Now, this is useful because there are limited configurations in which these magnets can sit. And this can be that there's a pole on the top of the central magnet and the opposite poles on the top of the other 2 magnets, which would generate a field which looks like this. Or the same configuration, but the whole thing is rotated so the poles are facing towards you out of the screen, which would generate a field that looks like this. Now, intuition may tell you that the magnetic field should be out of plane in this situation, but you just have to remember that the magnets are raised slightly above the ferrofluid, so we get a slightly different picture. But finally, we have the situation where the magnets are all aligned and the poles are on the left and the right of each magnet. And that would produce a field like this. And we see that none of the instances match what the ferrocell shows. And this is our first big clue that the ferrocell does not show magnetic fields. Our next clue comes from considering the definition of a field line. Remember that a field line is defined as a line where the direction of the magnetic field is always tangent to the line. And then we take this image, and here we see lines crossing, and this is a problem. Because if these were field lines, then the direction of the magnetic field would have to be tangent to both lines at the point where they cross at the same time. And that's not possible. Now, I mentioned Fractal Woman earlier in the video. She has a more sensible idea about what the ferrocell show. Her claim is that the ferrocell shows isopotential lines, and this would be interesting, and from certain examples she gives, it can look that way. The first clue is that isopotential lines, which are lines which indicate all points where the potential is the same, are always orthogonal to the magnetic field. Now, the magnetic scalar potential is defined in terms of the magnetic field, such that the magnetic field is the negative of the gradient of the scalar potential. So a line connecting all points with equal potential energy would definitely be orthogonal to the magnetic field. But just like a field is the force per amount of the property that the field affects at a given point in the field, a potential is the amount of energy per amount of that property at a given point. And we see from this image that this notion must also be incorrect, because this implies one of two things. First is that there are two values for the potential where these lines cross, and this means that the magnetic moment and that position would have two separate values for potential energy. That would be like saying that you are simultaneously on the ground floor of a building and on the roof, or a cup of coffee would be warm and cold at the same time. So that is an unphysical explanation for what we observe. Of course, we could say that the potential is the same at the points where they cross, and that would imply that all the lines have the same potential, and that is every point on the line has the same value. And that would indicate that the potential is constant. And from our expression, we find that if psi is a constant, then it is not a function of space, and the del operator would return 0, which means that there is no magnetic field. So whatever the ferrocell shows, it is not consistent with our definition of magnetic fields, magnetic field lines, or the magnetic potential. It may show something interesting, but whatever it shows, it's not any of those. And that does leave the question as to what the ferrocell really shows. Well, by the looks of it, it is just specular reflections. We can look at this micrograph of a few particles inside the ferrocell, and we see that they are indeed thin rods, and we know that the long axis of these rods will align with the magnetic field. Now, specular reflections are the straightforward reflections that you get from a mirror. If the angle between you and the mirror's normal vector is equal to the angle between the object and the mirror's normal vector, you will see the object in the mirror. Considering that, this diagram is what would describe what happens inside the ferrocell. And we can model this using ray tracing. And here's an image that I made using a few thousand thin metal rods randomly positioned with their long axes determined by the smallest potential energy in a magnetic field. I placed 12 LEDs in a circle around the rods, and the LEDs alternate between cyan, magenta, and yellow. The fun thing is that this is pure ray tracing. It doesn't really do much more than calculate the path of the light whilst accounting for basic optical effects like reflection and refraction. But you can see that this reproduces the ferrocell-like pattern. And from this, we can surmise that the lines we see on the ferrocells are just the LEDs reflecting off the nanorods. Oh, and that paper by Tim I mentioned earlier, this is what he says happens in the ferrocell. In fact, this diagram comes from one of his papers. But on his website, he still claims that it is a magnetic field viewer. But in that paper, he also implies that the ferrocell shows isopotential lines with this image, where he claims that the left panels show a simulation of the right panel. Now, the two really do not match. Seriously, I'm astonished that this got published. It's not even as if the publisher's predatory or anything. MDPI is a very well-respected publishing group, and this goes to show that stuff does fall through the cracks during peer review. So in this video, we have established that the ferrocell does not show magnetic fields. This comes from what we define the magnetic field to be. The ferrocell does not show magnetic field lines because magnetic field lines cannot cross. And for the same reason, the ferrocell also doesn't show isopotential lines. What seems to be the case is that the ferrocell just shows specular reflections of the LEDs. And that leads to the question, does the ferrocell actually have scientific value? Well, I suppose that if you know the viewing angle and the position of the LEDs, then you can use that information to figure out the actual magnetic field, but that would require a lot of tedious computation. Instead, you can just take a Hall probe. Now, is the ferrocell interesting? Yeah, it shows some cool stuff and definitely is a cool toy, but it's not much more than a cool toy. So with that, thank you all for popping along. There will be another video in this vein, and we will be looking at block walls and what they are and how the magnetism woo community doesn't understand them. But a special thanks to my patrons who know who they are and how absolutely spectacularly brilliant they are. And thank you all for watching, and until next time.
Good evening, ladies and gentlemen. I'm the Sarcastic Bomb, and welcome to the channel. And very sorry for no content last week. Real life got in the way in the form of an ABBA tribute band, and a very, very busy night, and a very late night at that, with an early morning the next day. Ah, the life of a barman. But it does mean that this week we've got something absolutely hilarious for you. So we better roll the intro and get on with it. So this week's stupidity has been tripled, as we have Jake the Arsehole, Russian Vids and QNFE arguing over who's stupider and whose model works the best. And by best I mean doesn't work a fucking all. But they are flat earthers, so this is to be expected. It turns out that QNFE, Russian Vids and Jake the Arsehole have a bit of an ongoing feud of stupidity. None of them wanting to admit who's the stupidest. Between the three of them, I would struggle to figure out who's the stupidest, having familiarised myself with their videos. But I thought this week we could look at Russian Vid's attempt at calling the other two stupider than he is.
This is going to be the easiest debunking ever. And after this presentation, QNFE and Fake Jake are gone for good. They might as well delete their channels and find a new hobby. Because this nonsense, as we see here, like I mentioned many times, made by a glober, but it doesn't make sense on the globe. As we know, even the globe model states how the sun runs past or through the equator region, but this is how it actually works.
Well, they are some harsh words there from Russian Vids. He believes that QNFE and Jake the Arsehole are going to have to delete their channels and run away from his fabulous presentation. Now, do we actually think that all three of them are just fucking stupid and can't work anything out, but are that fucking stupid that what they've tried to work out, they've cocked up so much that all three of them look like fucking morons? And again, I feel like that's being polite.
With the circling sun, as I mentioned before, just like I stated, when it comes to super tropical fruits such as durian, these trees cannot survive anything below 75 degrees. Super tropical, super cold sensitive, and they only grow in the equatorial region such as Malaysia, Indonesia. They can grow in Hawaii, Puerto Rico, and this is all within the tropical equatorial region. They cannot grow anywhere outside, and this, without a shadow of a doubt, proves we have a circling sun.
I'm sorry, the fuck what? Because fruit like hot, therefore circly sun? No. That's a fucking stupid explanation. And you say globers are fucking nutters? No, we're not. At least our explanation sounds sensible. Because of Earth's tilt, the tropic areas get more daylight sun energy because that energy is spread out over a smaller surface area. Because where the tilt of Earth is, that has to cover more. That's quite reasonable. It means those areas stay hotter because they generally receive more sunlight energy over a smaller surface area. That sounds about right. Never any good at explanations after drinking. Oh, by the way, drinking tonight, 1985 from Y Valley Brewery. Just thought you'd want to know.
Now, this is the aspect where QNFE and Fake Jake are completely done. Like I said, they might as well delete their channels, their history. They have no future When it comes to trying to disprove the EE map, God's created circling sun over the flat Earth. Let's get right to it.
So first up, let's be really clear. It's actually a mistake to say that this is a flat Earth map. It's nothing of the sort. It's just an azimuthal projection from the North Pole.
Oh dear, Russian Vince, looks like you've got another flat earther to argue about over who's the stupidest one. Because as, I can't believe I'm going to say these words. As Phuket World just said, that's not a flat Earth map. It's just a projection. Not a flat Earth map. Oh, dear me. It's annoying when he's right, isn't it? But he's still stupid.
Saying this cartoon proves the circling sun path. No, it does not. RV didn't do any observations or any scientific experiments whatsoever. He didn't visit any of the scientific websites which tell you where the sun is going to rise and where it's going to set for every location.
Is it just me, or at that point did Jake the asshole actually sound like a sensible human being? Telling people to actually check out scientific resources to verify their claims. Isn't that what we've been telling flat earthers to do for fucking ever? Oh my word. It's quite disturbing when I now have to say, Jake the asshole is right. These are things you should do. Visit scientific websites, check your sources, and, as you possible, verify these claims. Fucking hell. So I've said Phuket Word is right and Jake the asshole's right in one video. I feel dirty. I feel dirty.
So Fake Jake's claim is the sun is actually physically setting in Antarctica. Physically setting sun in Antarctica. And again, like I demonstrated, even the bogus globe model doesn't make this claim. Ridiculous. And like I said, after this is done, Fakey Jakey and Cute and Fee are done.
I always love how flat earthers claim, you don't know the flat earth model. Yeah, that's because you don't fucking have one to start with. But then have no idea what the globe model represents or what it's trying to tell you. And you say, no, not even the globe model says that. You're looking at the angles to which the sun appears to set in South America in winter. When if you go a bit further south, the sun doesn't actually set. Okay. You don't understand that map, do you? You don't... That's it. You don't understand what it's trying to show you. This is going to be hilarious.
Now let's listen to Q and Fee here, who Jake just took Q and Fee's information not knowing it's 100% incorrect. Like I said many times, Jake just takes from other people, not knowing, not doing any further research. And let's get right to it with Q and Fee in this absolute ridiculous claim he makes.
I swear to God, if Q and Fe says something that I have to say he's right for, I'm going to lose my goddamn mind. Because I cannot have 3 flat earthers saying things that are actually right in one video while arguing about who's the stupidest flat earther. That would just debunk the entire video.
So you're telling the flat earthers the sun never go out of its bed? What is this?
So Q and Fee thinks this is where the actual physical sun ends up. I'll get more of that. Let's continue.
Look at the sun. It runs out of its path. Sorry to bring you the news. But the moon also make those angles.
And here's Q and Fee's model showing the supposed sun going over Antarctica. Absolutely ridiculous.
So here we have suncalc.org, the same program that was being used by QNFE, who happens to be right for once in his life. Now here we have South America and Antarctica and some sun things. Ooh! So the ball there represents position of sun. Does say not a problem. All your details here of time and all sorted. So, where did the sun rise? About there. Oh, Look at that. Position of the sun to the southeast. But the sun can't go below the tropics, according to you. Isn't that strange? And where did the sun then set? To the southwest? How could it be setting south? That would fuck up everyone's plans of flat earth sunness, that it should always be up here somewhere going round like that. Because otherwise, how would it make sense for... One second, let's move over to Australia. Let's go to Melbourne, because there's lots of people in Melbourne. I'm sure someone could probably verify this for me. So here we have Melbourne, slightly higher north, so less sunlight hours. Can someone in Melbourne please tell me in which direction the sun sets? And hopefully you're going to say southwest-ish. So, and did it rise below where Sydney is in the southeast? Because that would be very infuriating for Russian vids, wouldn't it? Dear me.
And let's get right to it with the thorough debunking of both, again, Q and Fee and Fake Jake. And first off, I want to thank Neil22 Emerson 89 for showing me this clip from Teddy C's channel. So credit is given to where credit is due when it comes to this nonsense. Let's take a look here. Now here is the actual sun.
At noon.
The mistake both Q and Fee and Jake are making is they think the sun actually heads here. No, this is where the sunlight is.
I'm sorry, what? You think there's only sunlight between the two angles? Or you think there's only sunlight in the crescent shape above? Because both of those things are fucking stupid. Because if that was the case, in the south of America on the 21st of December this year, there's going to be no sunlight. You didn't think this through, did you? You're in such a rush to try and call other flat earthers stupid. All you've done is shown how stupid you are. And it's great, because you're debunking the flat earth, and both of them are debunking the flat earth all in one go. I don't even need to do anything, really, apart from point, drink, laugh at you, and drink some more.
And let's move this forward here, little by little, so people understand what's taking place. Here's the sun in the equatorial region. Let's move this over a little bit more. Okay, you have time and date here with December 21st. And Jake is assuming in Q and Fee that this is the actual path of the sun, when the sun is actually up here, clearly within the equatorial region.
Well, it's time for serious, Dan. You can tell I'm serious, I'll put the hat on backwards. The complete mark of being horrendously properly serious about something. Now, if we just have a look at this magical thing. Dooba 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 dooba. Oh, look at that. It actually tells you the exact angle to sunrise and sunset from your location. Isn't that amazing? The other one probably did it as well, but I couldn't see it, so I thought I'd find one that definitely shows it nice and easily for you all. Isn't that amazing? Now, if we know from that position the angle to the sun is setting in that direction,
Recording
what
in
does
progress.
that mean? Yes, it means the flat earth map is fucking fucked.
Recording
because there
stopped.
is no flat earth map, there is no flat earth model, and of course, most importantly, there is no flat fucking earth.
Okay, let's move this over a bit more. And clearly you'll see what's happening here. Okay, you see the sun in the equatorial region. It's not heading in this direction. This is where the sunlight is.
Can you smell that as well? It smells like bullshit. Almost as if Russian Vids is trying to lie through his arse and try and make that thing work for him. Because he's only changing the month. He's not changing the actual time to show the path of the sun through the sky. Imagine a flat earther being dishonest like that and trying to do shit like that. Heaven forbid. Especially a religious one. They'll just end up burning on Satan's crotch. Maybe that's what he wants.
Let's move this up a bit more again. And you're going to see here, when it comes down to it, where the sun makes its lowest point. And as I mentioned, this is the globe model that Jake is using in his video presentation. But here's the accurate model here with South America. And this is the Tropic of Capricorn. The lowest point, once again, where the sun goes south and obviously circles above the flat Earth.
Oh, Russian, my sweet summer child. Now, if you are here on this map, and the sun is setting in this apparent direction, then there's one thing you do know. The sun cannot be here. No, it's a difficult concept, but you're either going to have to bin that flat Earth map because that flat Earth map is just fucking stupid and doesn't work, or maybe come to the realization that nothing works with flat Earth. So, it's up to you, really. Or you can just keep being a fucking moronic shill.
So here is where the sun's located, again on the equatorial region. The sunrise, this is where they're getting the sun, obviously in the morning. But again, the sun is in this location between the two tropics, remains within the equatorial region.
Now, sunrise in South America on the 21st of March is just below due east. See? Yeah, I actually went and...
Thank you, Sarcastic Barman. I had to interrupt that. It was going a little bit long, and I got a whole bunch of stuff coming up for you. The first thing that we have to do is move to the next live stream, because this one, oh my gosh, I have something in my eye. This one will self-destruct eventually. Where we're at? We're at almost 9 hours on this particular one. We can only do 12. So I have everything scheduled out. So get ready for the next live stream. We'll move to it automatically. So, all right, we'll see you in a minute.